Hello. Good morning. Am I audible, please?
Yes, sir.
Okay. Today is the National Mathematics Day, being the birthday of the great Indian mathematician Srinivasa Ramanujan Iyengar, a great man who made mathematics so easy and so explanative to even many professors. That is the greatness of Indian mathematics. It is simply because of he putting himself active and thinking from his mind, thinking everything, looking at everything and thinking from his own mind and trying to find out what satisfies him. That is exactly true mathematics. Vedic maths, I want to explain you the meaning of Vedic mathematics. Many of you think only the set of formulae that help to solve many problems so easily, so fast. But true meaning of Vedic mathematics, Sanskrit Ved Ganit, is nothing but the knowledge one conceives through one's own observation from his own angles, from his own observation, application, and confirmation. Knowledge is what the mind gives us within seconds. When you put a question, you get the answer immediately without any time. But your knowledge needs some time to recall what you learned and what you remember. So please use your own brain throughout this session, throughout these kind of speeches given by very good mathematicians. Listen to them and think from your own angle. Then only confirm it. That's only called Ved Ganit. Gananeva iti ganitaha. Whatever you observe and learn from it, that's only called Ganitaha. And that is Veda means the true, real, original mathematics. I hope you understand my explanation. For example, there are so many sutras, so many formulae, all of them are made up of Sanskrit words. You better try to conceive those terminology, the real meaning, in-depth meaning, and then you will learn those Vedic mathematics and you will enjoy knowledge you get out of those observations, applications, confirmations. Vilokana is nothing but deep observation into anything you come across, you see, you feel, you hear. And that is Vilokana. And that also from your own angle, Shunyamanyat Anurupyena. Except nothing, you think something, and from that angle, you observe anything. In life, you do all these things, my friends, but in mathematics, you are not doing it. In mathematics, also, you do the same observation, putting your brain, your sensory organs into use, and thinking from your own angle. I hope you are following my words. For example, the numbers you are using are just numbers written by digits or calling those digits by their place values. But a number is a quantity of similar units, quantities, similar units at single place, where you see entirely one place, one pile, one quantity, and that quantity you are feeling how much or how many of the units are there. If you understand that, then your mathematics becomes so easy. Your friends, your very well known and well practiced mathematics teachers and professors are talking to you or giving explanations from their own Vedic sutras. Please follow them. I hope you can understand my words. I am supposed to give you more explanation about these things, but as your first speaker needs lot more time and complete more time, not just if I take some time, he will be losing his time and you will be losing his some of his explanations. So I hope I have made my point and I hand over this class to Mr. Charan Lal, the first speaker of today's program.
Sir,
See you.
sir, history కూడా చెప్పేయండి.
Okay. Charan Lal,
Yes, sir.
you please carry on from your own topic.
Yeah, sir. Before that, can you briefly explain the Vedic math history to our audience?
Vedic math?
History, how to Swamiji was described.
Vedic mathematics is to us, Vedic mathematics is what Swamiji Shankaracharya of Govardhan Math Puri, then Govardhan Shankaracharya of Govardhan Math Puri, Shankaracharya Bharati Krishna Tirtha Swamiji. He was a great, great, great man. He did his MA in 7 subjects and everything he was university topper. Sanskrit, science, mathematics. He worshipped, he concentrated his thinking over mathematics for 8 years alone in forest. Then from his own knowledge of Vedas, and out of them Stapatya, Upaveda, whatever he read them from and whatever he felt, he wanted to explain to us in simple, understandable words. So he gave those, he wrote 16 books on this Vedic mathematics, but unfortunately, the disciple who requested the Swamiji to give him those books to get them printed from America, but on the way on sea, he lost all the books in the sea. Coming to know that Swamiji wanted to rewrite those books, so he made some notes about his sutras and explanatory steps for us, for a simple people, common people, to understand them the reality, the truth of these things. So he made on noting down. But as he passed away in 1960, his secretary, Manjulaben Trivedi, she tried to make a book of those notes from her own conception and those things. So she compiled them, but wherever short notes are there, she tried to expand them with his own words. So the present one and only one authentic book is what Manjulaben Trivedi has prepared. So the sutras 16 or upasutras as Manjulaben wrote, I don't think they are real things. Some of the upasutras are the main sutras. For example, Vilokana is the main sutra. And whatever you do, whatever sutra you are going, you please Vilokana karo. You observe it, think it deep into it, and compare these words with your own life examples, life experiences. Then only you will understand the greatness of Vedic mathematics. Okay. So, for example, there are some sutras. Eka adhityana. This eka, all of you think only one, but one is only one pile is in his way. If you understand that one pile less than, more than or less than what the number which you are very familiar with and very easy to operate with, and then you can do those operations so easily, thinking this one less or more. So please, as I request again, use your brain. Try to conceive the words. Try to conceive the step, not just on paper, but in your life experiences. Then you will realize the greatness. More, there is a lot of things to say, but again, I will be interfering into all these lecturers. I don't want to do that. I'll let you listen all those explanations from those well experienced teachers and professors. So please follow that. I hope you follow me, you have understood, and I request Charan Lal to carry on.
Yeah, thank you so much, sir.
Charan,
Thank you so much, sir.
please carry on.
Yeah, good morning, everyone. Welcome to Wonder Workshop. This is Charan Lal. I am Vedic maths trainer and high school maths teacher. And I am also author. I am working on Vedic mathematics past 8 years. Today my topic is vinuculam. Right? So don't bother whether vinuculam spelling is wrong or right. Why? Because in Swamiji Diary I was seeing NU. In some other books they are not writing U after N. Okay. So don't focus on it. Right. Vinuculam topic. In the vinuculam topic, we are using 3 sutras, Vedic sutra. One is Nikilam, Navataha, Charamam, Dashataha. And along with this sutra, we are using Eka Adhikena, Purvena, and Eka Nyunena, Purvena. So these 3 sutras are we are using in the vinuculam concept. Okay, later I will tell you what is the vinuculam everything. And let us see the English translation of these 3 sutras. Here, Nikilam Navataha Charmam Dashata means all from 9 and last from 10. Here, Eka Adhikena means 1 more than previous one. And eka nyunvena means 1 less than previous one. Okay, if you observe very carefully the English translation of sutra, all from 9, last from 10. Okay, here the charamam is indicates the word last. Dashata indicates 10. The navata indicates 9. And the nikilam, actually in my observation, I seen that nikilam having different meanings in different chapters. In this case, nikilam means here indicates all. Sometimes nikilam we are taking as base also. So particularly in this case, the nikilam indicates the total. Okay. And here eka adikena purvena, if you observe very carefully, eka means 1, adikena means more, purvena means the previous. In the same way, eka means again 1, nyunena means decreasing or less, and here purvena means the same previous. So these 3 sutras we are using in the vinuculam. We will see why we are using. Okay, right. In generally in our mathematics we have 3 types of number. Okay, one is positive number, another one is negative number, and the third one is neutral number. That is, but in Vedic mathematics we have the 4th type, that is vinuculam. Okay, so what is the vinuculam? Vinuculam is a number actually. Okay, but this number is containing positive and negative digits data. That is a combination of positive negative digit. It is called vinuculam. And the main purpose of vinuculam in Vedic mathematics is we are reducing the calculation complexity. That is the main purpose of the vinuculam. Okay, we will discuss one by one very clearly. But before that, I want to discuss some few basic things why we are using the Vedic 3 sutras in this class. So the 4th type is vinuculam number. It is a positive and negative combination number. Okay, right. Now see very carefully. First of all, let us see how we are representing a positive number and a negative number in Vedic. Okay, some difference will be there. So that is the reason I am talking about that. Suppose if you are taking any positive number, let me take here 21. In Vedic mathematics also you are writing 21, there is a no change. But whenever you are writing the negative numbers, we are doing some changes on it. For suppose, -2 if you are taking, then we are writing -2 as 2 bar. We are writing a bar over the number. It is an indication. Okay, for our easiness. And suppose let me take here -21. Then we can write it as 21 bar, or you can write it as 2 bar, 1 bar. In the same way, if you are taking 3-digit number, then you can write it 2, 3, 2, 3 bar, or you can write it as 3 bar, 2 bar, again 3 bar. In the same way, for 4 digits also we are writing the same format, 4, 8, 2, 9 bar, or you can write it as 4 bar, 8 bar, 2 bar, 9 bar. So this is the way of representing a negative number in the Vedic mathematics. I hope you all are understood. Am I right? Is clear for everyone? Any doubts, please you can raise your hand. Okay. Right. Now observe very carefully. Here Nikilam Navataha Charmam Dachata Sutra we are using along with Ekadikena Ekanunena Purvena Sutra. Okay. So look at here. Suppose let me do one subtraction problem here. 2000 minus 347. Okay, observe very carefully here. In general, in conventional mathematics, we are taking the borrow here. Then it is become 10. Again, we are taking the borrow. Again 10. We are taking the borrow. The last number become 10 and the remaining numbers become 9. So when you are taking the borrow from the 2, then this 2 is reduced by 1. That is, we are subtracting 1 from the last extremity. Okay, and now observe very carefully here. The unit place we are subtracting from the 10. So then we are getting 3. And the remaining place, if you observe very carefully here, the 9 is, the 4 is subtracted from the 9. Then we are getting 5. Again, the 3 is subtracted from the 9. Then we are getting 6. And whatever the last digit will be there, from the digit we are subtracting 1. So whatever words we are used so far, that converted into formula here. So what is the formula we are learning? Nikilam Navataha. Dashataha. Okay. So here the word Charamam indicates the unit place. You can see the unit place we are subtracted from the 10 only. Am I right? And the remaining digit 3 and 4 are subtracted from 9. So the Nikilam, the word indicates remaining digits, remaining all the digits. And all the remaining digits we are subtracting from the 9. Okay. So that is the reason Nikilam Navataha Charmam Dashataha will form from our conventional mathematics. Okay. And from the last digit we are subtracting. That means we are reducing the last digit by 1. That means Eka Niyunena. Eka Niyunena means 1 less. Are you understood why we are using Nikilam Navata Charvam Dashata in vinuculam? But again, I am not deal with vinuculam numbers so far. But I am telling about what is the sutra exact. So Nikilam Navata Charvam Dashata we are using in the sub along with help of Eka Niyunena. Without Eka Niyunena, you cannot get the correct result. When you are suppose 30,000 if I am taking and subtracting this number, just you perform Nikilam Navata Charmam Dashata on this number. Okay, the first number we are subtracting from the 10. So that we are getting here 7. The next number we are subtracting from the 9. So that we are getting 5. Next number from again 9, 1, again 9, then we are getting 0. So without help of Eka Niyunena Purvena, you are not getting the correct answer. This is the wrong answer. Are getting my point? Okay. So we have to do Eka Niyunena of the last digit. That is 2. You have to write, then only you will get the correct answer. Okay. So with the help of Eka Niyunena Purvena, we can perform Nikilam Navata Charma. Hope you all are understood this. Okay. Now, very important point here. Observe very carefully. Suppose let me take addition problem here. 200 plus 34 if I am taking. The answer will be 234. If you observe very carefully here the unit place 0 is replaced by the 4 and the tens place 0 is replaced by 3. You can see here. Yes or no? In the same way, let me take one subtraction problem. 200 minus 34. Let me rewrite this question. 200 minus 34, can I write like this? Yes or no? Just now I told you minus 34, we can write it as 3 bar 4 bar. Okay, so there is a reason here minus 34, I written 3 bar and 4. So whatever procedure you are done here, if you try to apply the same procedure on here, then what happened? Let us see. So this is the 0 is replaced by the minus 3. and this 0 is replaced by the -4. So that 2, 3 bar and 4 bar we are getting. Yes. Now observe very carefully the number 2, 3 bar and 4 bar. It is a combination of positive digit and negative digit. So these kind of numbers we are called as vinuculam number. You understood? So this is the problem is nothing but subtraction only. So this is the nothing but subtraction. In the subtraction we are using nikilam navataha charmam dashata with help of eka nunena purvena. So that is the reason whenever we are getting the vinucular number, the, those two formula we are using. Okay. So you understood now what is the vinucular number? Let me write some vinucular number. Suppose 2, 3 bar, 4 bar, 3, 2. Look at this number. This is the vinucular number, but because it having positive and the negative digit. Suppose 3 bar, 4, 8, 0, 3 bar. So it is also a vinucular number, but because it having a positive digit and the negative digit. Yes, you understood what I am saying? Right. Now, in our mathematics, vinucular numbers are not accepted. So, whenever we are getting the vinucular number, we have to convert it to normal number. The conversion is very important. So, for conversion, converting a vinucular number into normal number. So, for converting a vinucular into normal number, we have to understand the characteristics of the numbers. Then only we can easily convert a vinucular number into normal number. So, for converting a vinucular number into normal number, we can use two methods. One is place value concept. Another will be nikilam navataha charamam dashataha. Okay, these two concepts we can use for a converting a vinucular number into normal number. Clear? Right. Now, let us try to understand the characteristics of the numbers. Very, very important point is whenever you are observing a positive number, let me take here 23. Is it a positive number? So this positive number having only positive digit? Yes or no? Observe very carefully. Suppose let me take here a negative number that is 23. You can write it as 2 bar and 3 bar. So the negative number having only negative digit? Yes or no? Let me take one more example. You can write it as 3 bar, 2 bar, 4 bar. So all the digits are negative digits. You can. So this is the condition is very, very important. Are you getting my point? Positive number having positive digit, negative digit having negative digit. Okay. Right. Now, how to use a place value concept to convert a vinucular number into normal number? Okay. I am giving just one or two examples to understand the place values, because I am not going to use place value concept for converting a vinucular number into normal number here. Okay. I am always use the nikilam navataha charmam dashataha for converting vinucular number into normal. Okay. Now see, suppose let me take here one vinucular number. I am doing the conversion with help of place value concept. Suppose 2, 3 bar. It is a vinucular number because it having a positive and negative digits. Let me take one more example here. 3, 4 bar and 2 and 2 bar 3 and 3 bar 4 and okay. Let me I selected here 4 problems and try to convert these 4 problems using place value. Okay. Here the place value of 2 is 20 and the place value of minus 3 will be minus 3. So then we are getting here 17. And come to the second number, the place value of 3 is 300 and the place value of minus 4 is 40. Why? Because it is in the tens place. And the place value of the 2, it is located in the unit place. So that is plus 2. Okay, this is the positive digit. So that I am getting here 2, 6, 2. And then come to the second problem. The place value of the minus 2, it is in the tens place. So it is minus 20. And the place value of 3 will be 3 here. Why? Because it is in the unit place. So that I got minus 17. Okay, so come to the third problem. So minus 300 plus 40 minus 2. So that gives us minus 262. Is it clear? So whenever you are converting a vinuculam numbers into normal number by using place concept, we have to observe very important point here. That point is, whenever your vinuculam number, okay, I'm talking about vinuculam number. Whenever your vinuculam number is started with, okay, started with a positive digit. Look at now. Here, this is a vinucular number. It started with positive digit, that is 2. So that is the reason your answer is totally a positive number. Then answer is a positive number. Yes or no? See, here also the number is positive in the second example. And the answer will be total positive. Okay, this is the first condition we are using in the conversion of a vinuculam number into normal number by using Nicolam-North-Charan. And if you see the third example, here the vinuculam number is started with a negative digit, so that the total answer is a negative number. Here also it is started with a negative digit, so the total answer is negative. So vinuculam number is started with a negative digit. Then answer means after conversion I'm talking. Answer is a negative number. Yes, this is a clear for everyone. And before that I discussed two conditions. One condition is positive number having only positive digit. And a negative number having only negative digits. Okay, so these four conditions are very important for us. Okay, is it clear for everyone? Any doubt you can raise your hand. Okay, so just write down these four conditions. Along with these four conditions, I am going to use 1-2 more conditions. Let me discuss those things also. So just now sir said us Vilokanam is a very important sir. So here also I am doing the Vilokanam. By using Vilokanam Sutra, I observed four conditions. Okay. So again we are going to do some Vilokanam. Try to understand the number characters. Okay, right. Now see, whenever we are doing the conversion, very, very important point is grouping and selecting. This is the very, very important. So first we are going to see how to select. Okay, how to select. Okay, right. Observe very carefully. Suppose, let me take here one vinuculam number, that is 2, 3 bar, and let me take here another number 2, 3, 4, 8, 9. Here the negative digits are these three. Okay, let me take here one more example. Suppose 2 bar 3, and another example is 2 bar 3, 4 bar 8, 9. So how to select? Selection is very important. After that, we will do the grouping. So I already told you, vinucular numbers are not accepted in our general mathematics. That reason we have to convert a vinucular number into normal number. So while converting the vinucular number into normal number, we have to decide that which digit we have to remove. That is a very important. Just now I use it for conditions. Just now I written on the whiteboard. In that condition, if your number is started with a negative positive digit, then answer is positive number. Is it clear or not? So let me do unmute all. Right. So right. Now see, here also number is started with 2. So that our answer is positive number. Now tell me one thing. After conversion, your answer is positive. That means this total positive digit having only positive digit only. So answer is here again positive number. So having only negative digit, sorry, positive digit. So your answer is positive digit. But in vinuculam you have the negative digit. तो मैं क्या बोलना चाहता हूँ, जब आपका आंसर पूरा पॉजिटिव आ रहा है तो जो भी क्वेश्चन में दिया है उसमें सब पॉजिटिव है क्या?
नहीं. No, sir.
So your answer is positive, but your number having positive digit, all the positives your number having no. It having negative digits. So we have to select negative digit to remove. Here also, you have to select negative digit for removing. Okay, come to second problem here. Here, this number is started with negative digit. So the total answer, whatever after conversion, you are getting negative number. Here also you are getting a negative number. So your answer is negative number. It means it having only negative digit. But here we have all the negative digits. No.
No, only positive.
So positive we have. So we have to remove the positive. That is the way we have to select the digits to remove. Here also your total answer is negative. Answer is negative, having negative digit. Here all we have negative.
No. We have some positive digit.
We have. So we have to remove positive digit. In this way, we have to do the selection. Is it clear my point?
Yes.
Right. Now let us try to do the grouping. Okay. So 2, 3 bar, 2, 4, 8, 9, 3 bar. And 3 bar, 4, 8, 9, 6 bar. 9, 2, 8, 9, 6, 3 bar. Now observe very carefully. In first question, which digit we are going to select, positive or negative? We are selecting a negative digit. Why? Because your answer total is positive. Positive having only positive digit. But in this case, we have negative digit. Okay, let me write here. Answer is positive number. We know that. So positive number means all positive digit we have. But your number, look at this number, all positive digit we want, but there is no positive digit all. So we have to select -3 to make into positive. So here your selected digit is this one. And the second problem also answer is positive. So having positive digits in the answer, so we have to remove negative digit. So here you selected one digit, here you selected one digit, here you selected one digit. Total 3 digits you are selected to remove. Come to third problem and the fourth problem. Okay, this number having a negative number answer. Yes, having negative answer. Negative answer means all negative digits we want. All negative digits. But look at the example 3. All negative digits we have here? No. We want all negative, but here we don't have all negative. So positive digit we have. So we have to remove those digits and convert it to negative digit. Why? Because our answer having negative digits only. So here you selected this digit. In the same way, in the fourth problem also you selected 2 and 3. Okay, this is the selection procedure. After selection, we have to do grouping. It is very, very important. Wherever your selected digit is there, along with that selected digit, left side must be taken unselected digit. Must be taken unselected digit. Here you 3 selected in the second problem. In the left side must be an unselected digit we want. And the second, and after that you selected negative digit, again negative digit. So continuously it is negative digit. After continuous those negative digit, the left side must be have unselected digit. So that is grouping. Here we have 2 groups. Here we have 2 groups. Here we have only 1 group. So come to third problem here. We are selected positive digit. We want to convert them to negative digit. So what are the positive digit? 9, 8, 4. Continuously we have. After completion of your negative digit, the left digit we have to take unselected digit. That is very important. Whether it is a positive or negative, we are not bothering. But left side we have to maintain unselected digit. So here selected digit is 3. So you can select here 6 leftmost digit in the group, and 2 also we have. You can select leftmost digit unselected. And another point also I'm saying here, observe very carefully. I said we want a unselected digit, or else we can set unselected number in the left. It means here you are selected 3. So you can select 3 and 6 one group. Am I right? You can select like this also as a one group. Left side must be an unselected digit or unselect digits. That means number. So this is called grouping. Is it clear for everyone?
Can you please explain it again?
Which example?
This last one. Negative and positive grouping method. I don't understand.
For selected digit will be there in the group. In example 4.
Yes.
मैंने क्या बोल रहा हूँ कि जो भी selected digit है आपका, उसका लेफ्ट में एक डिजिट अनसेलेक्टेड होना है. ये जरूरी नहीं है कि एक ही डिजिट होना. आप 2 डिजिट अनसेलेक्टेड भी ले सकते, 3 अनसेलेक्टेड डिजिट भी ले सकते. वो बात मैं बोल रहा हूँ, समझा? एक ही होने का जरूरत नहीं है, 2 भी ले सकते हो, कोई प्रॉब्लम नहीं. जो भी आप सेलेक्ट किया है उसका लेफ्ट साइड में 1 डिजिट भी ले सकते हो अनसेलेक्टेड, 2 डिजिट भी ले सकते हो, 3 डिजिट भी ले सकते हो अनसेलेक्टेड, लेफ्ट साइड में है तो। समझा मेरा बात?
Okay,
Right.
thank you.
Yeah, welcome. So just now we are selected, sorry, we are learned selecting and grouping. Okay. So after selecting grouping, very important point I am going to discuss here. We are using Nikilam, Navataha, Charamam, Dashataha along with Eka, Nyunena, Eka, Adhikena. This is the sutras we are using. I already told you vinucular numbers is nothing but subtract. From subtraction only I derive vinuculam numbers. That is the reason I am saying. Okay. So and on each group we have to apply Nikilam, Navata, Charmam, Dashataha individually. Okay. And very important point is here. Observe very carefully. Directly I will write the conditions because we don't have time more. We have only 15 minutes. Suppose you are selected a negative digit. In the selection, you are selecting a negative digit. Is it clear my point? And if you are selected a positive digit to remove, it means, look at here, 2, 4 bar. Here you selected negative digit to remove. Why? Because answer is positive. Suppose 2 bar 4. Here you selected positive digit. Why? Because answer is negative. In this way, when you are selecting a positive digit, negative digit, this positive digit in the answer converted into, this negative digit converted into positive. And this positive digit in answer converted into negative. In the answer, your selected digit. In answer, I am talking about. In answer, your negative digit become positive. In answer, your positive digit become negative. This is the very important. Okay. This is the one condition. The next condition. Okay, the next condition is in the group you are selected a unselected digit. I'm right in the group. You are selecting in the left side, you are unselected. So unselected digit. Unselected digit on the unselected digit. We have to apply Ekanina, Ekadikena. When we have to use. You are selected a negative digit. Then subtract -1. It means Ekanina. Suppose you are selecting a positive digit, then you have to apply Ekadikena on unselected. So this is the procedure. Okay, let me do some problems. So please note down here. Let me explain you once again. By the conditions, you are selecting a positive digit or negative digit for removing. Suppose if you are selected a negative digit, that negative digit in the answer it is become positive. If you are selected a positive digit, in the answer it is become negative. It is clear. On unselected digit, we have to apply Ekanina or Ekadikena. If you are selected a negative digit, then subtract. If you are selected a positive digit, then add 1. Simple. Okay? Right. Let us try to do some problems here. Right. Observe very carefully. Suppose 2, 3, 4 bar we have. So can you tell me anyone which digit I want to select here? Anyone of you?
The
Yes,
negative
why?
digit,
Yes.
negative digit 3 and 4.
Yeah, why? Because answer is positive. Why? Because it is started with positive digit. So answer is a positive number. So positive number means all the digit must be a positive order. But in the given number, it is all the digits are not positive. So extra we have negative digit. you are selected a negative digit and the negative digit. Okay. After that, we have to form the group. In the leftmost, we have one unselected digit we want. So this is the one group. On each group, we have to apply all from 9, last from 10 individually. So what is the word I said? I mean, condition selected. If you are selected negative digit, in the answer it is become positive. If you are selected positive digit, so that is the reason subtract. So add 1. If you are selected negative digit, then subtract. Then subtract 1 from the unselected digit. Okay. So simply unselected digit, whatever unselected digit is there, we have to subtract 1 because you selected negative digits. That is Eka Nyunela Purvena. So that we are getting here 1. I hope you understand. After that, whatever numbers will be there, on those numbers we have to apply all from 9, last from 10. So negative digit converted into positive digit. So don't remember that point. Sorry, don't forget that point. So this is the unit place and this is the remaining place. In the unit place, we are subtracting from the 10. Nikilam Navada Charmam Dashata. Last from 10. So last digit always from 10 only. Remaining digit all from 9. This digit from subtracted from the 9. So what the difference we have here 6. You can see your negative number is converted into positive. The last number we are subtracted from 10. So that we are getting again 6. So this is the original answer of the vinuculam method. Suppose let me take here one more example and try to understand it. So this is the number, is a vinuculam number. So answer is here negative. So negative means all negative digits we have. In this example, all we have negative digits? No. Yes, we have positive digit. So you have to select the positive digit for removal. Okay. your जो भी पॉजिटिव डिजिट है उसके लेफ्ट साइड में एक अनसेलेक्टेड डिजिट होना है. You have to unselect digit in the left side. Now see, positive digit you are selected, so add +1 on the unselected digit. Here you selected negative digit, in unselected digit you are subtracted 1. You are selected here positive digit, so add 1 to the unselected digit. So we are getting here -1. Right. Now we have to apply all from 9, last from 10. First digit from 10, next digit from 9, next digit from 9. I already told you, if you are selecting positive digit, then it is converted into negative in the answer. Na? So it will be -1 and this one will be 0 bar and the from 10 will be 7. So observe very carefully, very important. I am not going to repeat again. So negative digit are become positive. Positive digit become negative. Remember this point. In every case, we are doing same. And another point is, you selected negative digit. That's the reason I'm subtracting 1. You selected positive digit. That's the reason I'm adding 1 to the unselected digit. On the unselected. So all these things is clear for you, everyone? Yes. Right. Now see, let me take randomly very big number to understand the answer. Okay. Suppose 2, 3, 4, 8, 9, 8, 9, 6, 3, 4. Let me take randomly here. Now see, answer is positive. That is the reason we have to remove negative digit. Again, I am repeating, answer is positive. So I want to remove negative digit. So negative digit, negative digit, negative digit, and unselected 1 digit. This is the one group. Okay, the next one. Negative digit, 1 unselected digit. After the negative. Negative digit, 1 unselected digit. So this is the 3 groups we are getting here. On each groups we have to apply individually all from 9, last from 10 with help of Eka Union and Eka. Okay. You can start from anywhere, no issue. Now, first thing, you selected negative digit. Yes. So subtract 1 from the unselected digit. This is the common for all, right? So this one I am getting 1. This is from 10 unit place on the selected group. Okay, and this is 9. So here it will be 6. Negative digit become positive. Negative digit become positive. Now here I am getting 7. This from 9. The unit place from 10. The group I am talking. So it is become 0 and it is become 2. So negative digit must be converted into positive. So first digit from 10, the remaining digit from 9. So here we are getting 8. Is 3, and this one will be 6, and this one will be again 6. So this is the your original number. Okay, suppose let me take one more example and try to understand that one also. Right. So here answer is negative. Answer is negative means I have to remove positive. Answer is negative. That's the reason we are removing the positive. So positive, unselected digit. Positive, unselected digit. Positive, unselected digit. Positive, unselected digit. So you are selected positive digit. After positive selected digit, we have one unselected digit. Whether it is positive, negative, we are not bothering. लेकिन एक अनसेलेक्टेड डिजिट तो होना है जो भी आपने सेलेक्टेड किया है उस डिजिट के लेफ्ट में, राइट. फर्स्ट रूल क्या था? यू सेलेक्टेड पॉजिटिव डिजिट on unselected digit we have to do place 1, that is a karikena we have to do, right. Now see first digit from 10, so this is my 1 bar. Okay, first digit, the unit place digit from 10, so we are getting here not 7, -7, but because the positive digit must be converted into negative digit. So 4 bar plus 1 is 3 bar. First digit from 10, next digit from 9. So it is 1 bar and this one will be again 1 bar. So 8 bar means -8 plus 1 is -7. Only one digit we have means it is we are taking as a unit place, that is last from 10. This is 1 bar. So 6 bar plus 1 means 5 bar. So next digit from 9. This is the positive digit, so converted into negative form, so that it will be become 6 bar. Last from 10, then it is become 6 bar. So your answer is -173117156. So this is the your original answer. I hope you all are understood. Okay, right. Next, very important, a normal number is converted into vinuculam number. So in the normal number, we are mostly focusing on a digit which is more than 5. More than 5. So that kind of digit we are going to select. Suppose 2, 8, 9, 6, 3, 2 we have. What is the condition? Why? Because whenever we have the larger digit, if you convert into normal digits, so the calculation becomes very easy. So that is the reason I am selecting a digit which is more than 5. According to that condition, if you form any other condition, then according to that condition, you can select any digit. There is no problem. But here particularly I am mentioning, I don't want a digit which is more than 5 because my calculation become very difficult with those digits. So that is the reason I selected a digit which is more than 5. So what is that? 6, 9, 8. This is the 3 digit you are selected. Selected digit के left में एक unselected digit होना, so grouping also come. Now see, you selected a positive digit, so add 1. Same condition, there is no change, so it is become 3. Right? From 9, it is become 1 bar. Why? Because positive digit converted into negative digit. So the positive digit converted into negative digit. And the last digit from 10, then it is become 4 bar. Now see 3 and 2, they are not in the group. So we have to write as it is. Which digits are not in the group? So we have to take as it is. So let me take here one more example and try to understand. Suppose 3, 8, 6, 0, 2, 9, 9, 3, 8, 1. So I want to select a digit which is more than 5. Here 8, 9, 9, 6, 8. So these are the selected digits. जो भी select किया है उस left में unselected digit होना है. Unselected digit. This is the group and unselected. So which are not in the group, you can write as it is. There is no problem. You can write as it is. Right. Observe very carefully. You selected positive digit, so add 1. Add 1. Add 1. Why? Because you are selected positive. So here it is become 3. It is from 9, 1 bar. From 10, 4 bar. Now it is 3. From 9, 0 bar. From 9, 1 bar. It is 4. So only one digit. That means from 10, it is 2. So this is the vinuculam conversion. Is it clear my point for everyone? Yeah. So I don't have much time. Let me take 1 or 2 examples with application. Okay. Wherever numbers we are using, wherever you are using number, you can use vinuculam everywhere. So let me take 1, 2 examples and try to understand that. Okay. Suppose 98 into 99 is there. Okay. Suppose if you converted this number, see 98 is there. So I want to convert these 2 digits. So selected digit. After that, one unselected digit we want. Yeah, Banu Aurora, can you give me example? So one unselected digit must be what? So we can put the 0. There is no problem. So add 1 here. So 1 from 10, 0, and it will be 2 bar. So it is nothing but 1, 0, 2 bar. In other words also, this number nearest to 100. 100 minus 2. You can see how I am writing. This is 100 minus 1. Okay. If you do the normal multiplication, so minus 1 I am selecting, multiplied with 2, then positive 2. Minus 1 into 0 is 0. Minus 1 into plus 1, that is minus 1. Next, I am selecting 0. 0 into minus 2. 0 into 0. 0 into 1. Next one, I am selecting 1. This is minus 2. And 1 into 0, 0. And 1 into 1 is 1. So here 2 I am getting 2 bar. Here 1 bar. Here 1 I am getting. See, whenever you are multiplying 98 into 99, you can see 72 we are getting. After that, here 81, and next 81 plus 7, that is 88. See how such big numbers we are getting. But when you are converting into vinuculam number, we are getting very small digits. So our calculation become very fast. So this is the vinucular number, so we cannot accept it. So here number is started with positive digit. So answer is total positive. Answer is total positive means removing the negative digit. So selected this one and this one. So this is the our group. So negative digit you selected. So subtract 1, 0. From 9, it is become 8. Why? Because the negative digit converted into positive. Next last digit from 10, it is become 8. And we have to unselected digit, that is 2, we have to write as it. So this is, oh sorry. Sorry, I did mistake here. Sorry, I'm extremely sorry. Right. Next one, we have to cross this one. So 2 bar and the 0, 1 we have to write. So 2, 0, 3 bar, 1, 0. So this is the vinuculam number. Okay. Now see, observe very carefully. This is 100 minus 3. That is 97 and 02. Here I use place concept. Otherwise, you can use Niklam Navata, Charmam Dashita here also. So see, compare with 98, 99 in normal calculation. multiplication procedure, you are getting larger number, but you are getting very simple digits for finding the answer very easy. Okay, you can use vinuculum in every way, in subtraction also, in squares, in cubes, in the divisions. Okay, wherever you can use the number, wherever our concept is exist. Another very important point I am going to discuss here. So far, whatever we have done, that is based on decimal system. Okay. So if you are not going to use decimal system, that means if you are working on it like a base, suppose if you are working on 100, so if you are system को आप use कर रहे हैं, समझ लो. That is the reason vinuculum number is not unique. Is not unique whenever you are using different systems. Suppose let me take here 9. With respect to 10, how much less than it is? 1 less than. So 1, that is 10 minus 1. Suppose 9, if you are using 100, then it is 100 minus 91. Suppose if you are 9, if you are taking 1000, then it is 1991. That is negative. So see, one number we are representing in different forms. Every time the answer will be 9 only. So if we are using in this way, then vinuculum is not unique. Is it clear for everyone? Yeah, thank you. So, आपका next class. स्क्वायर्स क्यूब रूट के बारे में है, हिमबिंदु मैडम लेने वाली है. Are you there, ma'am? हिमबिंदु मैम?
Yes, sir, I am available.
Yeah. I'm making co-host you. You can share your screen. Give me 1 second here. So before मैडम स्टार्ट करने के पहले आपको कोई डाउट है तो पूछ सकते हैं. Yeah, Bhanu Arora, you said we can we take numbers with zeros? It means, yeah, we can take numbers with 0 also. Let me discuss that one. Suppose 2, 0, 0, 3 bar, suppose we have. Okay. So this is the positive answer. So we have to remove negative digit. Okay. I already told you, whenever you are selecting negative digit in the group, whatever digit you are selecting, on that unselected digit, we have to subtract 1 because you're selecting negative digit. From 0, you cannot subtract minus 1. So that is the reason I told you, you can select you are doing wrong in positive number. क्या हुआ मैम?
Yes, sir, understanding, sir.
नहीं शशमी जी. Yeah. So again, you cannot suppose you can make the groups like this here. Okay. Every time subtract 1 from here, even you cannot subtract 1 from here, but you can subtract 1 from the leftmost digit, that is 200. That is nothing but 1993 bar. Sorry, 3 bar means it becomes 7.
7.
So you can
Yes.
solve. Okay.
Yes, sir. Thank you, sir. Thank you.
Yeah, can you tell me, Kashmi ji, you are doing wrong in the positive number means? Hello.
Hello, sir. You are taking a number 2893 and we take it as a +1. So it's 2 become 3, na?
हाँ
But you write
हाँ ओके 3 है.
but you are writing it at 2.
अच्छा गलत में लिखा होगा लेकिन प्रोसीजर तो समझ में आ गया ना.
हाँ, वो मुझे लगा, I think just कि you
नहीं
have to
नहीं
write it at 3,
3 है
but you
3
write
ही
it
है.
at 2. That
हाँ.
same minus digit.
हाँ. या कोई बात नहीं. +1 का मतलब आप उनको 2 का ऐड करने पर 3 आ जाता है. पॉजिटिव
And
नंबर नेगेटिव
8
में
become
कन्वर्ट
1.
करने के बाद 1 बार
1. Yes.
1 बार है. ये तो ग्रुप में नहीं है ना उसके 3
Yeah.
शायद गलत
Yeah.
में लिखा होगा. ओके थैंक यू.
Okay, that's why I confused.
नो 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 जो भी लिखते हैं ना उसको एज इट इज करना है. बार बार मैं बहुत बार ऐसा ही करता था.
Okay.
देखता है. या लाइक
Okay.
थैंक यू.
Thank you.
या हाँ अब टॉपिक है हिमबिंदु मैडम ले रही है स्क्वायर एंड क्यूब रूट का ऊपर. ठीक है. या मैडम प्लीज कंटिन्यू.
Sir, is I'm audible, sir?
यस मैडम.
Hello. Is I'm audible?
यस यस.
Yeah. Good morning, everyone.
Morning.
Good morning.
Good morning. Yeah. I heartfully invite you all for the one-day program workshop today. And as you all have heard about, just went to the Charan sir class, and I'm really glad to be the part of it. And let me introduce myself. My name is Hima Bindu. I'm a Vedic math tutor, and I have around 5 years of experience in Vedic maths, and I'm taking online classes as well as offline classes. And today I'm gonna take a topic on cube roots and square roots. So shall we start our class?
Yes, please.
Yeah. So we all know what are the square roots. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. Can you all see the board? Is the board visible?
यस यस मैडम.
Yes.
5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. Do you agree with me?
Yes, ma'am.
Yeah. So these are all the square roots. We all know that. And if we are given a number like 7,744 and we are asked to find the perfect square of this, how we will find? Let us see. Before going into the topic, I just like to tell you the pair numbers. Every number has a pair. If you observe carefully, the last numbers we have to match the last numbers. We have to look for the last numbers of each square. One is 1, 2 it's 4, 3 it's 9, 4 it's 6, 5 it's 5, 6 is 6, 7 is 9, 8 is 4, 9 is 1, and 0 is 0. That means 1 or 9, 2 or 8. If you see, 2 it's a 4, and even for the 8 we have a 4. The last number is 4. So 2 and 8, and coming to the 3 or 7. If you look at the 3 and 7, the last numbers are 9 and 9. Okay, and coming to the 4 or 6. So why we traced out like this is when we are given a number, we have to see the last number. If it is a 4, then obviously the answer may be the 2 or 8. The last number of the perfect square of the last number, it may be 2 or 8. Let us go with this example. So we will divide this number into 2 parts. Left side number and right side number. This is the left side and this is the right side. So in the right side, we have a last number 4. There is a possibility of getting the answer either 2 or 8. Let us write down the board. And coming to the left side, it is 77. So if we look at the perfect squares, the 77 will fall between 8 and 9. 8 is 64 and 9 is 81. 77 is falling between 64 and 81. So here there are possibilities of getting the 2 or 8. So how we will justify our answer, and we will make sure that our answer is going to be either 82 or 92 or 92 or 98. Well, how we can justify our answer is with a small technique. That is, we have to go for the least number. Least number is the 8. Yes. So I like to write the 8 here and I like to write the 8 here. So we have to take one answer from the answers we have raised out. So here if we see 82 and 88, 88 is the least number and 82 is the least number and 88 is the smaller number. So obviously this will be our perfect square of the given number. 7,744 perfect square is 82. Is it clear for everyone?
Yes, ma'am.
Any questions on the topic?
No, thank you.
Shall we go for the second example?
Yes,
Yes,
ma'am.
ma'am.
Is this topic clear to you? Do you want to note it down?
Ma'am, how did you take that 82? How did you come to that 82?
Yes. So see, we have looked for the last number, which is 4. And as I told you, there is a possibility of either 2 or 8 because these two numbers are the pairs of the numbers. Okay. So either if we get the answer as a 2 or 8. So I have written the two possibilities of 2 and 8. Now coming to the left side number is 77. 77 will fall in between 64 and 81. Yes, 10. And here we have to look for the 64 and 80. When we look into the 64 and 81, 77 will fall in between. And if we take the possibility of 8, 8 is the least number. When we compare with the 8 and 9, 8 is the least number. So we are taking the possibilities of 8 with the two numbers like 82 and 88. We are writing it in the left hand side and we have made it as 82 and 88. Yes, when we compare these two together, 82 is the least number. So with this we can confirm it as 82 is the perfect square of the given number. Is it clear, sir?
Why we are taking the least number, ma'am? Why it can't be 88?
It can't be 88 because we have to look for the least common number that we have. For example, see, in between 82 to 88, 82, 83, 84, 85 and so on. So 82 is the number where we will find this to be the perfect. Is it clear?
But why, ma'am, if we think that the number is very clear to this number?
Sorry, I didn't get your question.
Yeah, we can't take it, ma'am. Why? How we can take the least number will be nearer to the 7744. Why it can't be 88? That concept we can't able to clear.
See, we have to look for the least common number in the given numbers. Given number.
Yeah, ma'am, least okay. In all the case, in all the number, we want to take only the least number.
Yes, we have to take the least common numbers from
Okay.
the given number. I'll explain you once again.
Excuse me, ma'am, but 88 square is 7744, right?
Sorry.
Ma'am, isn't it
88
88?
square is 7744. It is not
One question at a
82
time.
square.
One question at a time.
Actually, if you calculate, 88 square is 7744.
80?
8 square.
Yeah. 8 square is?
88 into 88 is 7744.
Huh.
But you are telling 82 is the answer?
Yes. We are taking out the perfect square of the given number. If
Yeah,
you,
the perfect square of 7744 is 88 square.
is it 88?
Yes, it is coming.
Yes,
81.
ma'am.
Excuse me, ma'am.
Yes.
Ma'am,
Yes.
won't we take the number which is closer to 77?
No, I'm really sorry. 82 and 88, we have to take the bigger number.
No,
Highest factor, that is 80.
no, ma'am, 77 is closer to 81. That's why we'll take 88.
Sorry?
Ma'am, isn't 77 closer to 81?
No. Let me clear it once again. I just got confused. So see here, we are taking the two possible. This 77 will fall between 64 and 81. Is this clear to you?
Yes, ma'am.
Yeah. So here, as I told you, we are taking the pairs from the factors. So here, the last number is 4. So there is a possibility of getting 2 or 8 as a last number. Coming to the left hand side, we are taking the here we are taking the least common number, that is 64. So 8 and 8. So here there is a possibility of getting 82 or 88 as an answer, but we instead of taking the least common, we will take the highest common number, that is 88. So 88 will be the perfect square of 7744.
Madam, that is the only question. How you choose between 82 and 88?
Yeah, here we have to take the highest common factor for the square root.
Ma'am,
Excuse me,
shall I
ma'am.
clear it once again? Myself, Gautami, shall I clear it?
Just a second.
Yeah. See, the quotient is 77. Okay, the left side number is 77. And we have two options of answer. That is 82 and 88. Take the 8. Okay. With that 8, multiply the consecutive number of 8. 9 8s are 72. Okay. Then compare 77 and 72. Since the quotient 77 is greater than 72, we want to take the greatest number.
Yes.
Like this only we want to finalize it.
See, if the number 744 is closer to the smaller number 6400.
No, we can't take as the comparative smaller number or greater number. This will work out for every sum.
I'm teaching you the best method of getting the perfect square. So see here, if we look at the left side number, it's a 77. So 64 or is a bigger number. Bigger number is 81, and 64 is a smaller number, right? If the number 744 is close to the smaller number 64, that means if we make it like 680, so it will be 6,400, and 90 will be 8,100. Okay, so 66,400. Then the smaller number will be the 82. as the answer. However, if it is closer to the bigger number 81,
Yeah, that's what I was saying. Since it is
then we
closer
can
to
take
81,
88
we'll
as the
take it.
answer. Then we can take it take the answer as 88 only.
Yes.
But we can understand which is closer or which is far away, but for students it is difficult now.
No, for the students
No.
it will be easy to understand when they understand the concept properly.
Yeah, ma'am, I am telling the best way. This will suit for all kind of square roots. We can
Yeah.
easily find it.
You can find answer perfect squares for any numbers.
Ma'am, take the another example.
Yeah, sure. I'll take another example and give you a clear explanation on it.
6724.
I have a small doubt, ma'am.
I'll just clarify it. Let me take another example. So see, this is the number I'm taking. So we will divide it into two parts, 98 and 01. So our last number is 1. So there is the possibility of 1 and 9 because these are the pair numbers that we have traced out. So now see, next what we are going to do is the number 981, it's a least number. 98 will come between the 98 will come between 9 and 10. That is 81 and 100. Yes. So what we will do, we will just write the numbers like here on the left right side. We will write 1 and 9, and we will write the least common number, that is 9 and 9.
9 and 10, ma'am.
No, I'm
No,
taking
9
the
and
least
9.
number. I'm taking
No.
the least number here. I'm taking the least number. We will not go for the higher number. We will take the least number. Okay. So there is a possibility of 91 and 99. There are chances of two. To get the perfect square of this number, it may be 91 or 99. So here we can make a judgment that 99 will be the correct answer. How? By? Because this is the highest factor that we are getting and this is the lowest factor that we are getting here. So 91, this cannot be the answer, and 99, it will be the perfect square for the given number.
Ma'am, can't we just take, because 98 is closer to 100.
How to choose between 91 and 99? It is same doubt as the
Take
previous
the
one.
highest number. Take the highest number as your answer.
But before example, you have said that you want to take the least number.
Yeah, I was confused and I apologize for that. There also I have taken the highest number. Here we are taking the least number and after that we are taking the highest number.
Ma'am, can you please take 6724? 6724.
Is it your question?
Yes, ma'am. Because here you need to take the least number.
Let us see. So I will just split the answer into two, left and right. The last number is 4. So the pair numbers are 2 and 8. 2 and 8 and 67. It will fall between 8 and 9. So here I am taking the least number which is 8. So 8 and 8. So here here we have to go for the highest number, that is 88. So 88 will be the
No, 82 is the correct answer for that.
82 square is this, because we took the same number now. 88 square is 7744, so similar to the previous one, and 82 square is 6724.
82 square is 6724.
Some middle step is missing, I think.
Ma'am, can I just come in?
like there is a one step there which tells you which is the which is the right answer. So I'll just like to come there if you agree to it. Yeah. Can I share my screen if it's possible? I'll just write down the question, that is 6724. Can I share the screen?
Ma'am, 1 second, you can do it yourself, ma'am. I will instruct the I will give you instruction. You just write it in your board itself. Okay. For 6724, I will give instruction. Okay. No, you don't need to rub anything, ma'am. Whatever the step you have done is everything is right. Okay. Finding the correct answer only you are putting mistake. The two option is 82 and 88. Is it?
Yes.
Okay. Now the 8 is the common factor for us. Okay. So
Yeah.
multiply the 8 with the consecutive number. 8 9s are 72. 8 into 9 is 72. Okay. Now we have taken 67 only as the quotient. For 67 only we have chosen 8. Okay. Now compare 67 and 72. Comparing 67 and 72, 67 is the least number. 67 is less than 72. You write that step. 67 is less than 72. So less than. Okay. So we are taking the less than number. So 67 is less than 72. We are taking the 82 is the correct answer. Okay. Now you write the example for 9801. In 9801, we have two options in right side, 1 and 9. Okay. And the left hand number is 9. So the answer will be either 91 or 99. Is it? So what is the best answer we want to find means multiply the 9 with its consecutive number. 9 into 10, 90. 9 into 10, 90. Now compare 98 and 90. 98 is greater than 90. So we want to take the greater number. 99 is the best answer for 9801. Okay?
Okay.
Like this, you can do any number. So we want to compare the number which is less than, we want to take the less than number, which is greater than, we want to take the greater than number. This will perfectly suit for all 2-digit, 3-digit and 4-digit every square roots.
Yeah.
You try it for 3364, ma'am.
Let me clear it.
Yeah. I think everyone will understand in this step.
Yes,
3364.
Gautami ma'am, very easy, simple
Yeah.
explanation. Thank you, Gautami ma'am.
Yeah, ma'am. Thank you. 3364. Since it ended 4, the right hand answer will be 2 or 8. Okay. Then we are taking the quotient as 33. 33 is between 5 and 6. Between 5 and 6, we want to take the least number 5. Okay. Multiply 5 with its consecutive number 6. 5 6 are 30. Compare 33 and 30. 33 is greater. So 58 will 58 will be our answer. Because 33 is greater, we are taking 58 is our answer. And I will tell one example for lowest number. Try 6724. Yeah, end it 4, 2 or 8 will come. 64 is direct 8. 67 will lie under 64 and 81. So we will want to take 8. In this condition, multiply with the consecutive number. 8 9s are 72. Compare 67 and 72. 67 is the least number. No, first write the quotient. Always write the quotient first. 67. 67 less than 72. Okay. So we want to take the least number. Less than means, so we want to take 82. So 82 is the perfect square.
Yes. We can take it. I would like to share one more method, ma'am, just to identify. So in this 82, just can you write that 82, like 82, one big line and 88 in horizontal way? No, in a horizontal way. It's one more method I'm just telling you. In a horizontal line itself, right? 82.
one big line which separates one big line. After that, after 82.
Okay.
After 82, one big line and then
No.
88.
Like subtraction sign you put, ma'am.
No. The same. Okay.
Okay.
So now we have got two choices, that is 82 and 88. All right. In between 82, 88, you will always have a number, or whatever your the digits are, you will always have a number which will be ending with 5 or 0. So here the number is 85. All right. So can you just write below that line 85? 85. And what is the square of 85? So 8 nines are 8 into 9 is 72 and 25, right? 72. No, the square of 85. Yes. You entirely you can write the square of 85. Square of 85. No. Write the answer square of 85.
7225.
7225. 25, right? Yeah. Yes. Sorry, I'm not able to see. So what happens now? You have to compare this entire number with your question. So is 7225 greater than 6724 or less than 6724? So actually it is greater than. So your answer is 82. All right. So your question, you have to compare it with your question. So similar way, if your two choices are in between any number which is having the units place as 0, you can make the square of that. For example, if you have got two choices like 88 and 92, and if you have to decide the number, right? So you can make the square of 90 and see which is the, if the square of 90 is greater than your given question, and then you can decide the number. So that is almost similar way what I think earlier it is given.
Yeah.
Thank you.
Okay, thank you so much. And I learned most things today from you. Thank you for that.
Can we take one more examples of square root technique? Like 85, the other teacher told us.
Yes, sure, definitely. Five and 8, 4. I think this will be good.
Kanchan ma'am, can you teach us again?
Yeah, so 4, the 4 is ending, so it will be again 2. For 84, it will be 2 and 8, right? And 51, for 51, will be your answer is 7 or 8?
7.
7 or 8. So, ma'am, you can just write everything horizontally. So it will be like 72. I'll just write it here. So 7 and 8, and what is that? 2 and 8, right? You're also 51, right? 7 and 8. So your actually possibilities are 72 and 78, 82 and 88. So there are 4 possibilities. Okay, so we can't even ignore the last possibilities. So first possibility is 72, second possibility is 78, then 82, 88. Now you can just write it like this. I'm just showing you in the box. Just write it horizontally like this, so it will be very easy to identify.
Just a second.
72, 78.
But that can't be 4 possibilities, no?
Yeah.
How 82 and 88 will come?
No, it is a possibility right now. To narrow it down, we will make as 90 square. So once we do the 90 square, 1100, so your answer is less than 8100. So again, you do 75 square of 75, that is 7 8s are 56, 25.
Ma'am, taking single digit square itself, student will
Yes. So
take
this is,
complicated.
yeah.
How they will do 90 square for finding the easiest square root?
90 square is 8100, right? I mean,
No,
see,
and not all students can do it, no. So
okay,
this is
no, you actually, we only take first 2 possibilities, right? Always. But sometimes when actually even I teach the kids, sometimes what happens, even this number, 3rd possibility and 4th possibility may arise. It is very rare case.
No, never it will
No,
come.
ma'am, it can't, ma'am. Only the least number 7 will come.
Least number will always come.
8
Never
won't
Yeah.
come, ma'am. 8
Yeah,
won't come.
only like if it lies between 7 and 8, we should take only 7.
Yeah.
72 or 78. So we'll get the middle number 75 square root of
Okay, yes, yes.
square of
Even if you see
75.
these two number, so you can make it as a 75, right? Here,
Yeah,
75
taking
I have
square
to
root of 75 is complicated, no?
No, it's not
Square of
complicated at all.
75.
75, you have to just take ekadikena purvena to do the
Yeah,
square root
ma'am.
of 75.
Yeah, yeah.
So
See,
7
ma'am.
into 8, 7 into 8, that is 56, and your 25. So your 75 square is 5625. Okay,
Yeah,
because
ma'am,
we
it is not necessary. Just you take 7 alone. 7 8 of 56. Compare 51 with 56. It is
yeah, that
very
is also
simple.
okay. Yeah, that is
Yeah,
also
it is very simple. No, why we want to go complicated method? Just a 7 8 of 56 is enough. 51 is less than 56. We can take the least number. 72 as the perfect square. See, if you are comparing 7225 with 5184, what will come?
Yeah, I mean that is the entire number you will have, right?
No.
When you are having, see, if you see if you compare 5625 with 5184, it is very easy to compare. Then just comparing the first two digits.
No, first two digit is the easiest one, ma'am.
Yeah,
First two
first
digits.
7 8 is 56. It is enough, ma'am. We don't know it to take square root of 75 and all. See, ma'am, 72 and 78 is the two outcomes. What it will come, okay? Then take 7 and multiply it with its consecutive number. 7 into 8. 7 8 of 56. Compare 51 and 56. 51 is less than 56. It is direct and everyone can understand. Even those who are weak in maths can easily understand 51 is less than 56. So we can directly take the lowest number as our answer. 72 is our answer. Instead of comparing 5184 with 5625. Okay. 51 is less than 56 is very, very easy.
Yes, sure.
Yeah. So we can save more time in that.
Yeah, right.
Yeah. So no, there won't be 4 outcomes. Definitely there won't be 4 outcomes. Only 2 outcomes will come. The least number will be our right answer.
Yeah.
In option 7 or 8, we should not take 8. The correct method is taking only 7. We should not teach students that there is 4 outcome. It is a wrong method.
Yeah, because it's a complicated method. We have to go to the far then and we have get the answer.
Yeah, Vedic is mainly for the simple time saving. So
yeah,
we are taking out 4 outcomes and we want to compare and we want to reduce it one month, so more time will go.
Yeah, but the simple you give me the method, it's a very easy. Just multiplying with the other number and then find out the
number.
number.
Yeah, consecutive
Yeah,
number and comparing with it. It will be very easy.
Yeah,
and it
that's
is suit for 2 digit, 3 digit and 4 digit also.
Yeah, ma'am. But other ma'am method is very complicated.
I think everyone will get this method.
Yeah.
Yeah, ma'am, you can try with any 2 examples so that everyone will clear with it.
Ma'am, try it with the another numbers.
Bindu ma'am? I think she muted.
Yeah, please tell me.
No, ma'am, if you try with another 2 to 3 sums so that everyone will clear off with the.
Okay.
Try one sum with ending with 5, ma'am, and one sum with ending with 0. It will be direct square.
Okay. Let us take a number like 529. Will it be okay? 3-digit number.
Yeah, ma'am.
Actually, we have a disturbance here. So our last number is 9. So possible numbers and possibility pairs will be the 3, yes, 3 and 7. 3 and 7. I'm just making it flash here. Okay. So 52 will fall between 7 and 8. Yes. 7.
Ma'am, we
Ma'am,
can't
it's
able to split 52 and 9. Since we are taking square root, the last right hand side it should be always 2-digit only, not single digit. So we
ma'am
want to
is
split
very
5
much
and 29.
confused.
Okay. Now 9 is the ending number. The 9 should end with either 3 or 7.
Ma'am is so confused.
या आपने जो बताया है कुछ लोगों को कंफ्यूज हुआ है, बात क्लियर कर देता हूँ इसमें। चलो
Can I explain it, sir? But I'm not having board and all. But I can explain it with note and pen.
या सुनिए, एक ही बात मैं बता देता हूँ, जो भी उधर क्या हुआ करें, मतलब उसका रीजन क्या है। तो आपको इधर 2 पॉसिबिलिटीज आ रहा है, मान लो। ओके, मेरे को एग्जांपल लेता हूँ। फॉर एग्जांपल मैंने 92 लिया, 98 लिया, ये 2 पॉसिबिलिटीज मेरे को आ गया। समझ लो क्वेश्चन क्या है वो। बाकी जो whatever number I got, the 2 possibilities I got. Okay, so observe very carefully. Whenever you are taking the numbers 91, 93, 94, 95, okay, 96, 97, 98, 99. So these 2 numbers are your problem. Am I right? Okay. So one madam said that she was finding 95 square.
Yes.
Why she was finding 90 square? Suppose if you are finding 90, suppose you look at here, 92 into 92, you are possible, suppose 84. This one is 90, 24. Okay. And 98 into 98 is 9604. Now observe very carefully. Suppose question is given that 9604. So 2 possibilities are 2 and 8. So this number is nearest to 81. So you are taking 9 and 9. Here you got 2 positivity. Am I right? So now observe very carefully. Here the number is 9604. So in middle number, if you see, this is 9025. After onwards, 9026, 9027, up to so on, 9064 will come. That means whatever answer is there, it is lie to the right side. Right side means we have 3 possibilities. In the 3 possibilities, we are selected only one. फिर राइट को फॉल हो रहा है ना, राइट को फॉल होता है मतलब वो 98 को डिनोट करता है। इसलिए हम जो मिडिल नंबर को फाइंड आउट करते हैं, फाइंड आउट करके ये जो भी बड़ा नंबर इधर फॉल हो रहा है या नहीं तो यहाँ फॉल हो रहा है। सपोज मैंने 84 64 लिया, इसको भी इसी तरह 2 कॉम्बिनेशन है, लेकिन 84 64 विल कम दिस साइड, 949023 अप टू सो ऑन 98463 सॉरी 65, उसके बाद 64 आता, मतलब ये पॉइंट इधर लाई हो रहा है। इधर लाई का मतलब 92 ही पॉसिबिलिटी है, क्योंकि वही सेलेक्ट किया है ना। इसलिए मैडम ने क्या कर रही है कि 95 का वैल्यू फाइंड आउट कर रही है। पहली कॉन्सेप्ट था। सेकंड कॉन्सेप्ट क्या है कि both में आई थिंक सो she was saying try to find, suppose 92 is 90 is 8 is given, I mean those are 2 possibilities, then simply try to find out the product of एक आदि के नाम पे 10th place digit. That means whatever 10th place digit we have, take एक आदि के नाम it and find the product of that, then you are getting 90. So you are finding 90 and you are taking this 96. So 96 यहाँ फॉल होता है, 91, 92 अप टू 96 का मतलब बड़े नंबर के साइड जा रहा है। सपोज 84 में लेता हूँ, 84 तो इधर फॉल होता है, मतलब छोटे नंबर के डायरेक्शन में जा रहा है। समझ में आ रहा है ना? जो भी आपको इधर 90 आया है वो क्या है, वो यहाँ का 90 है। वो मैडम ने पूरा पार्ट सॉल्व करना है, वो पूरा पार्ट में आप स्मॉल पार्ट सॉल्व करना है। आप देख सकते कि आपका 90 इधर ही है, आपका 84 इधर भी है और 96 इधर भी है। 90 के बाद इधर जा रहा है का मतलब जो भी इधर 95 लिया ना, 96, 97, 98 यही आंसर आना है। इधर फॉल हो रहा है, राइट साइड फॉल हो रहा है मतलब। समझा ये सब कुछ? क्लियर है? मैं थोड़ा ज्यादा एक्सपर्टली एक्सप्लेन कर दिया मैंने, समझा कि नहीं सिर्फ बताओ। ये बात ये चल रही है, मैं आपको प्रोसीजर बता देता हूँ। मेथड 1 आपने जो किया है उसके बारे में बात करता हूँ मैं। सपोज एक क्वेश्चन में लेता हूँ, इधर ध्यान से ऑब्जर्व करिए। क्वेश्चन नंबर 9604 स्क्वायर रूट फाइंड आउट करना है। ये 2 का पॉसिबिलिटी 4 का पॉसिबिलिटी 2 एंड 8 है। ये 96 किसके किसके बीच में होता है? अब उनको 81 के बीच में, 100 का बीच में, मतलब 9 स्क्वायर के 10 स्क्वायर के बीच में रहते हैं। लोएस्ट नंबर लेते हैं। लोएस्ट नंबर क्यों लेता है कि 98 से ज्यादा हो रहा है, मतलब वो आंसर 98 में नहीं आएगा, 100 में चले जाएगा, इसलिए 9 को कंसिडर कर। अब इसको सॉल्व करने के लिए दो तरीका, 92 और 98, या नहीं तो इधर 92, 98। बीच का नंबर कितना हो गया आपका? 95 हो गया, मतलब 90, 25। 90, 25 को ये नंबर अपन को इसी साइड लाई होगा, मतलब यहाँ से ज्यादा जा रहा है, मतलब 98 इसका आंसर होगा। और सेकंड मैडम ने बोला 9 का नेक्स्ट मल्टीपल ले लो, अपन को 90 आ गया। ये 90 और ये 96, 90 के बाद ही 96 आता, मतलब बड़ा नंबर को चूज कर। समझ में आ गया आपको क्या बोल रहा हूँ मैं? क्लियरली सबको?
यस सर।
इसमें कोई डिस्कशन नहीं, लेकिन आपको मैं एक असाइनमेंट देता हूँ। जो भी बिंदु मैडम ने, हिमा बिंदु मैडम ने बोला है उसमें एक सच है, एक ट्रू बात है। वो ट्रू बात क्या है कि अब मैं बता देता हूँ। यू हाउ टू वर्क आउट ऑन इट एंड देन टेल मी वेदर इट इज वर्किंग और नॉट। जस्ट आई गॉट द आइडिया फ्रॉम हिज हर लेक्चर। ओके, so observe very carefully. 1 square is 1, and the 2 square is 4, and the 3 square is 9, and the 4 square is 16, and the 5 square will be here 25, and 6 square is 36, and 7 square will be here 49, 8 square will be here 64, and 9 square will be 81. So observe very carefully. We have to verify or we have to find which possibility is correct one out of two possibilities. Okay. So let me discuss here one problem, that is 7396. And another problem also let me take here, 7056. These two numbers are perfect square. Okay. So these two numbers are ending with 6, so that we have the possibilities in the unit place 6 and 4 for both numbers. Okay, is it clear? Now see, the 73 is lies between which numbers? Yeah, 73. I did correct or anything wrong? Yeah, 54 and 92. So we are taking the 8 smaller number here and here. सिंपल सा ऑब्जर्वेशन है, 64 एंड 81 का बीच में रहते हैं। नाउ टेल मी 73 इज नियरेस्ट टू 81 और 64? कौन सा नंबर किसको नियरेस्ट है? 73, 81 तो 64 के बाद ही आता है, मतलब बड़ा नंबर है वो, उसलिए बड़ा नंबर को चूज करो। 64, 84 के बीच में लाई होता है। ये 70 किसको नियरेस्ट है? किसको नियरेस्ट है 70?
64।
64 स्मॉलर है, बिग नंबर है, स्मॉलर है, मतलब स्मॉलर को चूज करो और बीच में जाके आपको एक आदि के ना लेके प्रोडक्ट फाइंड आउट करना, या नहीं तो 85 95 जो भी नंबर एंडिंग विद 5 होता है उसका स्क्वायर निकाल के टाइम वेस्ट मत करो। जो भी मैंने इधर बताया ना आपको, जो भी आप जो रेंज लेते हैं ना, उस रेंज में देखिए बड़े नंबर के नियरेस्ट है तो बड़ा आंसर, छोटे नंबर के नियरेस्ट है तो छोटा आंसर। ये वाला जो भी हिमबिंदु ने बताया है उसमें मैच हुआ है। ये पूरा वे में सब नंबर्स को सेटिस्फाई करते या नहीं आप चेक करके मेरे को मैसेज करिए, ठीक है। दिस वाज वेरी सिंपल ना, विद कंपेयरिंग रिमेनिंग टू मेथड्स।
Yes, sir. This one is very simple.
Suppose let me take here one more. I'm not sure whether it is work for all numbers or not. Just I observe this from her lecture. Just now. Suppose let me take one more example. Suppose 62, 41, 50 and 41. So numbers are ending with 199. We know that. Here 62 is nearest to 49 and 64. So we are going with 7 here and here. Okay. Here also we are taking 7 and 7. Let us try the same technique will works or not. I don't know. Here the ranges you are selected 49 and 64. So this 62 nearest to big number. That means big answer. This 50 nearest to 49. That means smaller number. Is it clear? Whatever ranges you are selecting, by those two ranges we are using for comparison for finding our exact possibility answer. It works now actually. I don't know whether it works for all the numbers. I not tried. You have to try it and tell me. Clear? Yeah, clear for everyone? Or?
Can you just explain again the last part, how you are deciding only with that one single number?
One single number means?
Like 71 and 79 we got, right? Beyond that, what that part? You can just explain that.
This is 62. This is the ranges you selected from this table. Okay. These two numbers you are selected, finding the 7. Is it correct or wrong? I'm asking to you only, madam. ये 7 को डिसाइड करने के लिए हमें दो रेंज लिया है, क्या 79, 60. अब तो लास्ट दो डिजिट 62 किसका नहीं रेस्ट है, बड़े नंबर को और छोटे नंबर?
यस सर,
बड़े नंबर
है तो बड़े आंसर चूज कर लो पॉसिबिलिटीज में। इधर 50 है, इसके लिए भी आप यही रेंज यूज किया है 49, 64 फ्रॉम द टेबल, लेकिन लास्ट टू डिजिट 50 है। 50 का मतलब इसका नियरेस्ट है 49। ये तो छोटा नंबर है, इसमें दोनों में ये तो छोटा है, इसलिए छोटा नंबर। बाकी कुछ फाइंड आउट करने का जरूरत नहीं, वो बात मैं बोल, समझा?
Yes, sir.
Right. A 5
This
minutes
one
break.
very smallest numbers and a bigger number and a small trick.
Small trick है, बताते क्या? Okay.
I have just one question. How to identify if it is the right square root? Sorry. Means if we can get that perfect
Actually, हम एक नंबर परफेक्ट नहीं है फाइंड आउट कर सकते, लेकिन एक नंबर परफेक्ट है, बड़ी मुश्किल की बात है फाइंड आउट करने। एक एग्जांपल मैं बता देता हूँ, अपन को बहुत सारे कंडीशंस अवेलेबिलिटी है, बहुत सारे कंडीशन, लेकिन आई एम नॉट एग्री विद दोस कंडीशन। Why? Because let me tell you one rule for you. Suppose 2, 8, 9, 6, 4, 8. Let me take here 4. The first condition, the perfect square number is ending with 4, 1, 9, and a 6 and 5, blah blah blah. Okay, these 5 digits will be appear in the unit place digit. That is the one condition. And different conditions we have, whether the number last digit are divisible and divisible by 8 and 4, and the different rules we have. Suppose if you take one perfect square number and you apply all the condition on that perfect square number, then the perfect square. Okay, I will tell you one problem. याद नहीं है कि conditions क्या है. Suppose 72, 79, 21 is a perfect square number. You have to check all the conditions you have used and you are verified that, and this number is a perfect square. But if immediately if I put 8 here and you are checking only last 4 digits according to the rule, then it is a wrong statement. This is not a perfect square. You getting my point? So इसलिए मैं बता रहा हूँ कि perfect number को find out करने का तरीका नहीं है exactly. कुछ कंडीशन से हम देख सकते हैं लेकिन 100% कर नहीं कर सकते. मेरा ऑब्जर्वेशन शायद एग्जिट होगा तो होगा, मेरे को पता नहीं, लेकिन मेरे को अब तक तो नहीं पता. लेकिन वो जो नंबर इट इज नॉट परफेक्ट स्क्वायर को हम फाइंड क्लियर. या सो टेक 5 मिनट्स ब्रेक, उसके बाद अपन नेक्स्ट क्लास में एंटर होंगे. ठीक है, या टेक 5 मिनट्स. थैंक यू.
Hi.
Yeah, Jyotirmay. I have checked 3-digit like 196, 250, 576 and 676. It is not working. No, work करता है ना? कहाँ गिर गई? Yeah, suppose one. Hello. Please keep silent.
छोड़ देना, ये क्यों उसकी जान के पीछे पड़ी है? मेरे को लगता है गया कुछ ना.
Yeah, Jyotirmay ma'am, 196 है. So they are ending with 4 and 6. And the 10th place digit will be 1 only. So 1 is nearest to 1. Am I right? So 1 का लाई हो रहा है
Do
मतलब?
it in a whiteboard. Do it in a whiteboard, na? So everyone can see.
That's why I said you just I got that idea. You have to check whether it is working or not. Yeah. Okay. Visible?
Yes, it's visible.
So 196. So then you are taking 4 and 6. So we have 1 square and 2 square is 4. And here it will be 1. So we are taking 1 and 1 here. Okay. And 256 also they take it. Here it will be 1 and 60. Okay. Right. What happened? Here we have the ranges, these two ranges. So this one is nearest to here. So we are selecting here smaller one. And these two again nearest to this one. So again we have to take this one. But this is not the correct one. Actually correct one this one. Why? Because 2 is very nearest to this one. Okay. And remember one thing. Whenever you are doing a special technique or a special method, don't think they will work always correct. Why? Because I will tell you small reason for you. So whatever method so far you are used, let me take here one example. Okay. Yeah, 1296 is there. So let me take 4 and 6 here. And this number is nearest to 1 square, that is 1, 4, after that 9. So it is, we are taking here 9 only. Okay. So that is 3 and 3 we are taking. First method, you are taking this 3 and if you are multiplying with next number, then you are getting 2. In this case, this 12 is equivalent to the 12. Okay, and observe very carefully. Actually, the procedure is we have to find the middle number to verify whether the given given 1296 is lying to the right side or left side. This is the correct way we can decide it. From this method, if you are again taking chart, then in this case we are getting tie situation. Okay, it works for all the numbers. When we are getting this kind of number 12 equal to this 12. So that is the reason I said we have to check where it is working or not. I don't know. Just now I got it, that procedure. And remember one thing, when you are dealing with smaller numbers, in the smaller numbers you are applying the same logic on it. Maybe you will get some tie situation, or you are sometimes you are not getting the answer. So every time I suggest to everyone to try to remember at least 25 squares from 1 to 2. Then using of 1 to 25 square, we can estimate remaining perfect square numbers answer. So for finding remaining perfect square number answer, you are using 1 to 25 square. The same technique may not be work on 1 to 125. Maybe work, may not work. We are not giving the surety on it. We have to observe all these things. Okay. Clear?
Sir, now what is your answer for 1296?
1 to 9 is whenever you are getting tie situation, you are getting simply whatever method you said, just to find 35 square means 20, 25. So 20, 25, if you are comparing this number, it is lies right side. That means it will come after 1225. 1225 का मतलब 36 ही होता है.
Yes, so that is why, sir, I was telling that time that any number you will get now, it will be, you will have the units place as 5 or 0. Then you can make the square of that. So one more, can we take the example of square root of 5, 6, 1, 6?
No. We will discuss that at this section. I take break.
Okay, sir, thank you.
Thank you. Yeah, madam, please, you can continue, ma'am. I make you host. Yeah, Vinisha, ma'am.
Can everybody hear me?
Yes, please.
Yes, can everybody hear me?
Yes, madam.
Perfect. Okay, so my name is Vinisha Jain, and I am a Vedic maths tutor. A little bit I know about Vedic maths. I have been teaching online students from the time when the COVID started. And I had a good interest in mathematics. I won't say that I'm a mathematician, but yes, I had an interest, and that's the reason, I thought, let me refresh it a little bit. And since COVID was going on and people were talking a lot about Vedic maths, so, just out of curiosity, I joined the classes with Mr. Dhaval Bhatia. And it was more to refresh myself and to understand how it is different, how Vedic maths is different from mathematics. So, so whatever I learned, definitely I read a lot of books after that, learned a lot of techniques, learned, through lots of such, workshops. Charan sir has also taught me a lot of things. I keep watching the videos on his channel. So it has been an interesting journey as of now. So whatever little I have learned, from that, I have picked up 2 small topics for you, which I would like to share. And before I start off, so this was my background. And I'm happily married. I've got 2 kids studying in grade 2 and grade 4. My daughters really enjoy when I teach them small techniques about mathematics. Now you must be wondering that what are you going to teach with a grade 2 student? My younger daughter, when I taught her a table of 9 on the fingers, she just loved it. And today she knows it so well that she always want to do it on that. So that's the power of Vedic maths, or we should say the techniques that we have known as of now. They are so interesting that everybody can fall in love with it. Very right, Jyotiramay. I'm sure you're saying it to sir, but that's very correct. So as in the morning, sir was, when he started with the session today, I don't know his name, but he was really a learned person. He told me about the history of Vedic maths. I really enjoyed, because people nowadays want to know the techniques, want to learn the techniques, know about the sutras and everything, but they don't know the history that he told us in the morning. So thanks to you, sir. So if you're there, I just adore you for it. Thank you so much. And Sharan sir, today I have attended your live session. It was wonderful. Vinuculam cannot be easier than this, the way you taught us. Wonderful. As far as Vedas are concerned, it means knowledge. We all know it. Are we all teachers here? Are we all teachers here?
Yes, ma'am.
Oh, that's great.
Yes, ma'am.
Okay. So, because I teach more of, small students, school students. So I, give them a lot of magics, and, play with the numbers. So they enjoy, they keep, be engrossed with my conversation. So I really enjoy doing that with them. That's why I was telling you, the table of 9 on the fingertips, they love it. So a grade 2 student, you can imagine, knowing a 9 table when they are being taught about 2, 3, 4, 5 tables. They are just introduced with the multiplication technique, and they can do 9 table. They feel really proud of it. And I do a lot of, magics. It's not actually magic as we know, because we are all teachers. We know how Vedic maths work. So it's more of playing with the numbers. So that I would say is really a good forte with me. That I'm able to keep my students, small kids, with me. Okay, so before much taking of your time, let me go on to the topic that I would like to take on.
I also learned with Dhaval Bhatia, sir.
Okay, that's great. Okay, so I am taking up multiplication with series of 1. So, do we understand what is series of 1? I have watched many videos of various, institutes. They start with 11. They all start with 11. Neither to say that, we all know that multiplying any number with 1 is the same number. So nothing to say about it. So we all start with 1, and usually the series, the YouTube videos ends with 11 only. They start with 11 and end with 11 only. Nobody teaches you that it's just one step ahead and you're done with the whole series, as many number of ones you have. So when we say series means the repetition of ones. So one of the numbers in the multiplication, so either of the multiplicants is a series of 1. That is what we are going to learn right away. So when I'm saying the multiplication with the series of 1, I am saying that, say if I have this number, so this is one of the multiplicant and the other multiplicant is 11, 6, 11, okay? Now, I will teach you a simple technique which ends here only. You will be able to use my technique for any number of ones in the number, okay? So here, what I'm going to do is, I'm going to count the number of ones. Let's understand from the basic. So here, my number of ones are 2, right? When I have two numbers, 2 ones, I subtract 1 from it, which comes out to be 1. So what I'm going to do is, I am going to put 1 dash on this side and 1 dash on the other side of the number. Right? Are you all with me? Yeah, am I?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay, so I have put 1 dash on either side because I have 2 ones here, and 2 minus 1 is 1. Right? So I get 1, and that's why I have put 1 dash on either side of the number. Now, what are these dashes? These dashes are the invisible zeros. Okay, these are invisible zeros. So you can put it as dash, you can put it as 0, you can put it as star, as you feel comfortable. Okay. Now, I don't put zeros because if the number itself has a 0, you might get confused and can make a mistake. So I usually put dashes. Okay. So what I'm doing is, I am taking 36 as the number and putting dash on both the sides. Now, again, since I have 2 digits in my question, I need to start from my right-hand side, go towards the left-hand side, 1 digit at a time, and only 2 digits need to be added together. What I'm trying to say is, let me change the color so it's more visible. So I'm starting with the right-hand side. So it goes 6 and 0. So my dash, 1 dash and 6 gets added together and I get the first digit. So 6 plus 0 is 6. Now I leave 1 digit this side and move on to the next digit and add these two together, which means 6 plus 3 is 9. Again, leave the digit on the right-hand side and move towards the left-hand side. which comes out to be 3 and a 0, which is 3. And this becomes my answer. Understood? So 36 multiplied by 11 is 396. See, when you look at the videos, what does it say? It says you put this 3 as is, add these two digits together, which is 9, and then put the second number at the end. Then also you get the same number. Exactly, this is what I'm saying. But why I'm telling you this is, so you can do any digits here and any number of digits here. The process is same. Yeah, did you get it? So the number of digits increasing here or the number of ones increasing in the series will not change the method. This is getting this directly is only workable when you have 2 digits. But this method will work for any number of digits. And that is the reason, instead of telling you two different methods, I'm telling you one method so that you can do any multiplication. Understood? Any doubts?
Ma'am, please explain once again.
Yeah, sure, I will do that. So let's take another example so that it's interesting. Okay, let's take 42 multiplied by 11. Since I have two ones here, I am going to put 2 dashes on either side, which are invisible zeros. Again, as I have 2 ones here, I need to add 2 digits at one point in time, starting from the right side, going towards the end of the left-hand side. Keep on adding 2 digits at one time. You will keep leaving 1 digit from the right-hand side and add on towards the left-hand side. So when we start, it goes 0 plus 2 gives me 2. Leave this digit, which is a dash, an invisible 0. And 2 and 4 is added. Gives me 6. And then leave 2, gives me 4 plus 0, which is 4. So this becomes my answer. Yes, ma'am, it's clear now?
Ma'am, it depends only two digit?
No, it works on any number of digits and any number of ones. I will just go over it. This much is clear?
Yes.
Okay.
Yes, ma'am.
Now let's increase the number of digits. Okay, before increasing, let me just tell you the carryover in it so that it is clear right here. Okay, so say my number is 68. Okay, and to be multiplied by 11. Same rule follows. We put 1 dash on both the sides. Okay, and since I have 2 ones here, so 2 digits to be added together. So 0 plus 8 gives me 8. And 8 plus 6 is 14. So I write 4 here and 1 gets carried over here. And now, so this I have done. Now 6 and this 0 will be 6 plus 0, 6 and 1 carry over 7. So this is how we handle the carry in this case. Right? Clear? Yeah, any doubts, anybody? No? Okay. Now let's increase the number of ones and the digits. Okay. Okay. And here I take 3 ones. Now I have 3 ones. So my 3 minus 2 is, 3 minus 1 equals 2. So that means I need to put 2 dashes on both the sides. Is there any chat box? No. Okay. Yes. So I put 2 dashes on both the sides. These are invisible zeros. Now I have 3 ones, so which means I need to add 3 numbers at one point in time, right? So to add 3 numbers, we start with the right hand side. So this 0, and this 3 gets added at one time. So 0 plus 0 plus 3 is 3. Yes? Now leave one number from this side and add one number on the other side. So we start from this 0. 0 plus 3 plus 2 is 5. Yes? Next would be that I need to leave this also and start from this 3. So 3 plus 2 is 5. 5 plus 1 is 6. Gets me 6 here. Now I leave this 3 and start with this 2. So 2 plus 1 is 3 and 3 plus 4 is 7. So I get 7 here. Now I leave this 2 also and start with this 1. So 1 plus 4 is 5 and 5 plus 0 is 5. Last but not the least, I leave this 1 also and start with 4. So 4 plus 0 gives me 4. So this is my answer. Yeah, any doubts?
No, ma'am.
Yeah, clear? It's an interesting technique.
Yes, ma'am.
Yeah.
Ma'am, can I take 4 digit, 4 times 1?
Yeah.
1 example.
Yes, then you have to add on 4 digits at one point in time. That's it.
So both sides are 3 blanks, ma'am.
Yes, absolutely. So 4 minus 1 is 3. So 3 dashes on both the sides. Yes, that's the logic. And you know how to handle the carry also. It gets added to the next digit. Let's have a look. Anybody wants to give an example? Or should I take mine only? Okay, let's look at this. So we have 4 ones. Okay. Now, when I have 4 ones, so 4 minus 1 is 3. So I put 3 dashes on both the sides, invisible zeros. And 4 ones means I need to add 4 digits at one point in time. Right? Yeah, is it getting clear?
Yeah, ma'am.
Remember, as many number of ones you have, that many digits need to be added together. And you will automatically reach the point where all the dashes are covered to the left-hand side also. That's the answer. Yeah, anybody having any doubts? Please.
No, ma'am.
Yes. So anybody wants to do any more examples? So I hope the series of 1 is clear. It's very interesting, you know, kids, those who don't want to do multiplication, they really enjoy doing this, you know, jumping, because they are taught the number line at a very early stage. They really enjoy it. It's beautiful technique. Thank you, sir. Okay, so anybody wants to do any more examples, or should I go ahead with who's this? Please don't do anything on the whiteboard.
Yeah, wait, I will stop the. Just 1 minute.
Yeah. Okay. Yes. Anybody has any doubts? Or we move to the next series.
Ma'am, please do the subtraction again, ma'am.
Subtraction?
I mean the sum again, ma'am.
Okay. So, one more example. Okay. Let's take 302 multiplied by 1, 1, and 1. Okay. Now, since we have 3 1s, so 3 minus 1 is equal to 2. So I put 2 dashes on either side of my number, and I have 3 1s, so I need to add 3 digits at one point in time. So 0 plus 0 plus 2 is 2. 0 plus 2 plus 0 is 2. 2 plus 0 plus 3 is 5. 0 plus 3 plus 0 is 3. And 3 plus 0 plus 0 is 3. So this is the answer. Yes? Yes, any more doubts? No? Should we go ahead with the next series?
Yes, ma'am.
Perfect. Okay, so the next one is, see, all the other series are also very, very simple. Once you know the series of 1, all the series can be done. Okay, let's do multiplication with the series of 9. This is a little different than the series of 1. That's why I'm taking up series of 9 now. Okay, when we say the series of 9 means the number of 9s as one of the multiplicants. Right? As many number of 9s. Okay. Now, there are 3 situations to it. Number 1 is, we call it as equal, meaning the multiplier and the multiplicand, both the numbers have equal number of digits. Meaning, say I have 72 multiplied by 99. So you can see that the multiplicand and the multiplier, both the numbers, have equal number of digits. This has 2 digits, this has 2 digits, right? Yes? So let's look at this case. If I have equal number of digits, doesn't matter how many 9s. If I have 3 9s, I will have 3 digits here. If I have 4 9s, 4 digits here. So whenever we have equal number of digits in the multiplicand and the multiplier, what can we do to do the multiplication? So a very simple method is the simplest, and you will enjoy it. Subtract 1 from this multiplicand. What is that?
71.
71. Now, whatever we have got, 71, subtract each of its digits from 9, digit-wise, okay? So, which means, so 9, I've got 71. So, this is the left side of my answer, okay? 71. Now, if I subtract 7 from 9, I get 2. And when I subtract 1 from this 9, I get 8. And this is my final answer.
Ma'am, please repeat once again.
Sure. Okay, so let's take another example. I have 81. Okay, I need to multiply it with 99. to multiply with 99. So I have equal number of digits. That's the rule. Okay. Now 81 minus 1. 81 minus 1 gives me 80. Now each of these digits, 80, needs to be subtracted from 9. So 9 minus 8 is 1 and 9 minus 0 is 9. So this becomes my answer. Check it out, whoever has the calculator. Yes? Is that correct? Anybody checking in? Anybody checking in?
Yes, it's right.
Yes, ma'am. Yes, same.
Okay. So understood?
Yeah, ma'am.
Okay. So let's do a couple of examples. Okay. Say I have 732 to be multiplied with 999. As I said, the first rule is that my number of digits are equal in both multiplicand and the multiplier, right? Now, next step is subtract 1 from this number. I get 731. Now, second step is to subtract each of these digits from 9. So 9 minus 7 is 2, 9 minus 3 is 6, and 9 minus 1 is 8. And that's my final answer. Yeah, it's a matter of 2 seconds. We should get the answer. Once you practice, right now, since you're learning, it's taking time to make you understand. But once you practice it, it's very, very fast. Yeah, it's very, very helpful for the kids in, their examinations where they have to do the MCQs and they have to just select the correct answer. And instead of solving it, the whole using our traditional multiplication method, it takes longer. And this is the fastest method.
Ma'am, we can take also 999. Can I take it 888? It's same? No.
No. It's for the 9. It's for the series of 9.
Okay.
Like we just did the series of 1. So there's a technique for it.
Yeah.
Okay.
Yeah.
So series of 8 is handled differently.
Yeah.
Yeah.
Ma'am,
all the series can be done, but every technique, every series has a different technique.
Yeah.
Yeah. So this is for the series of 9.
Ma'am, one more example, 4 digit.
Yes, sure. Okay. Let's take 8, 8, 8, and 8. Sorry, my handwriting is a little poor. Multiplied by 4 times 9. Because as I said, that the first rule for this method right now is to have equal number of digits. So let's do a subtraction of 1 here. I got 8, 8, 8, and a 7. Now, the second step is to do a subtraction of each digit from 9. So I get 1, 1, 1, and a 2. And that's my answer. Isn't it faster?
Yeah, ma'am.
Yeah, interesting. Since you all are teachers, I don't know if you all know it very well. Yes, any more examples? Anybody wants to try out, check out on the calculator? Please go ahead, feel free to do it. Okay. Now, I taught you one part of it, which is when I said that it is called equal. In the series of 9 itself, when the multiplicand and the multiplier have equal number of digits, right? No, but there can be more cases, no? When the digits are more or less, isn't it? Let's look at the case of more. Okay. Why I'm taking more first is because it's very similar to the equal one. Less is a little different technique. Okay. So let's do more. When the number of nines are more. When I'm saying more means nines are more. The multiplier is the number of digits in the multiplier is more. So say I have 65 to be multiplied with 3 nines. So see, my number of nines are more. Yes? Now, what to do in this kind of a scenario? It's exactly same. Trust me, it's exactly same. Add a 0 here. Okay? There is a significance of this 0. The significance is, now let's do this. I will tell you how it matters to add on a 0. So our first step was to subtract 1. Let's do the same thing. Do a subtraction of 1. We got 0, 6, and a 4. Correct? Now, what is our second step? Is to subtract each of these digits from 9. So 9 minus 0 is a 9. 9 minus 6 is 3. And 9 minus 4 is a 5. Now, whoever has the calculator, please check out, this is the answer. Now, when I said to add a 0, and it has a significance, people say that, add on a 0 at the beginning, I mean, it doesn't have a significance. So, no, it has a significance. It is important. Why it is important here? If you don't put this 0, you will not get this 0 here. Yeah, and that's what I'm looking for. Why? If I don't put this 0, I'm not going to get this 9. Yeah, I know 064 can be written as 64 also. Yes, you can. But if you write 64 and then start subtracting each digit from 9, you will get 6435 as the answer, which is not the correct answer. Yes. So the correct answer is 64935. Please check out whoever has the calculator. Any doubts? Please ask me.
No, ma'am.
Yeah, is it clear?
Ma'am, 65 multiplication 4 times 9, ma'am. Can I take?
4 times 9?
Yeah, ma'am. It's
Same.
happened?
Yeah.
Same.
Why not? 65 multiplied by 4 times 9. So see, this is again the case of more 9s, right? So I have to make this equal. How will I make this equal? Put 2 zeros. Now, when I do a minus 1, I'll get 0, 0, 6, and a 4. And now subtract each of these digits from 9. So I get 2 9s here. 9 minus 6 is 3, and 9 minus 4 is 5. So my answer is 649935. That is why these zeros are important. Otherwise, you're going to miss on these 9s and then the incorrect answer. Yes? Good question. Thank you so much. You can add as many zeros to make it equal as long as the number of 9s are more. Okay? When it is the case of less, we'll go over it as a third case, if the time permits. So that's a little different scenario, how we do it. But equal and more are pretty much similar, except adding of the zeros. And this needs to be done very carefully. As many number of zeros can be added to make it equal in terms of the number of digits to 9s. And then you subtract each digit from 9 so that you get these 9s in between. Yes, anybody has any more questions? No? Is it like all clear or all clear? What is it? Yes, please, I would like to hear from all of you.
All clear, ma'am.
All clear. Hope it's a good one, all clear, huh? Thank you, Bhushan sir. Thank you, Sapna ma'am. Kriyan, thank you. I don't know how you pronounce it. Kriyan Radhi. Jyotirmay, thank you, thank you. Very perfect explanation. Thank you, Somaya. Thank you. Oh, thank you, Kriyan. Thank you. Okay. So since we have some time, so let's go over the third case. I really like it. Third case is of a less. Okay. So again, when I'm saying less, I mean the number of nines are less and the digits in the multiplicand are more, right? So say, let's take an example of 205 to be multiplied with 99, right? So here, what we are saying is, here I have number of digits, 3, which are 3 digits in the multiplier, and in the multiplicand, and the multiplier has 2 digits, which is 99. Yes. So my number of digits are less in the multiplier. So what do I do? Atif Arman. Thank you, Atif sir. Thank you. Okay. So when the number of nines are lesser, can anybody guess what to do? Yes. Now you can open your mics. We are not too many, so we can open the mics and shout.
Ma'am, same process.
You mean add a 0 here?
Yeah, ma'am.
Won't help. Won't help.
I mean, 205 minus 1 is equal to 204.
Okay.
Then
how would this 0 help? We are not using this 99 anywhere, isn't it?
Yeah.
So how would this 0 help? This won't help. Yeah, good try. I like it. Good try. But see, we are not using this multiplier anywhere. We have done equal, we have done more. We haven't used it anywhere, isn't it? We have done all the operations using this. Yeah. Any more tries? Bhanu ma'am knows it. Yes. Okay, so what we are going to do in this case is, we are going to use our multiplier in this case. How we are going to use it? We are going to change it to 100 minus 1. Okay, 99 is equal to 100 minus 1. And then multiplication with 100, with ones are the simplest, right? So the process is do 205 multiplied by 100. So what do we get? 205 and 2 zeros are added, right? And when we multiply 205 with this 1, we get 205. Yes, multiplication with 1 gets a same number. And we have a minus sign at the center, so we'll take a subtraction of this. Right? Now, subtraction of this will give us 2029 and a 5. In the morning, sir told us about the vinuculam process. We can use that and do the subtraction. Yes? Easy? Interesting? Yes. Anybody having any questions? This is not a difficult,
Ma'am,
but it's.
can I explain once again?
Yes, yes, I will. It's not difficult, but it's little different than the other two techniques of more and equal. That's the only thing. Okay. So let's take 315 multiplied by 99. So we can write 99 as 100 minus 1. So see, if you have 3 nines, you can take it as 1000 minus 1. Right? If you have 4 nines, you can take it as 10,000 minus 1. That's not difficult. So multiply this, we get 3, 1, 5, 0, and 0, and 3, 1, 5 here. Okay. Now, a small technique to do the subtraction. A small technique, okay? I call it as magic, okay? So do a subtraction of 1 from this number. We all know it as 31499. Do a subtraction of 1 from this number also gives me 314. And now without doing a borrowing, I can do the subtraction, right? So this is my answer for this one. Yeah. Anybody having calculator checking on? Please do that. Yes. Any doubts? Any more questions? Chat. Can we use the same method of 119,000 for all the method instead of the topics we explained before? Won't they be a little longer, Kanchan?
Yeah.
No, actually, I was first you told that the digit should be same, and then the number of nines is less than the multiplicand, and the number of more is 9 is more than the multiplicand, and all. So there are 3 types, right? So now you have explained 100 minus 1 and again 1000 minus 1 and all. So can we use the same thing for all? Like 100 minus 1 if you do and 1000 minus 1, instead of thinking that seeing the number of nines are equal or less or more and all. So that was my question.
See, that would be faster. That's a very, very faster technique. You don't have to do subtraction also in that case. It's the straight away, just by observing, you can get to the answer.
Yeah, so there you were using 2 sutras there, right?
No, why? It's simple.
No, there are 2 sutras used actually there. So one is Ekanyena Purnena, that is subtracting by 1, and other one is Nikilam Navasharanam, which Charan sir had explained. So these 2 sutras, they were used there. So if somebody is not really aware of sutras, it's very difficult to even memorize all these things, right? So it is 100 minus 1, 1000 minus 1 is much easier. If
No, listen, Kanchan, you're getting it wrong. See, if I have to do 735 multiplied by 999, okay, you will go 1000 minus 1. Yes. So it would be 73.
Why, ma'am? Both the side digits are same, no? 3 digits over here and 3 digits.
That's what Kanchan is saying. That's what Kanchan is saying. That why not go it this way? Okay. So that it's the same method for all. One method for all. Okay. This is what Kanchan is saying. Right? Have I understood you correct, Kanchan?
Yeah. So in this also, see, we are using that Ekanyena Purnena because 5 we will do it 4, and then we will do Nikilam all from 9 last from 10. So these 2 sutras are used everywhere.
Yeah.
Right.
Yeah. But you see, how many steps have you added? How many steps have you added? So first you go this way, you write this, and then you use subtraction technique also, right? Here, by looking at this number, I can go 734. I can start writing my answer. 734, 9 minus 7, 2, 9 minus 3, 6, and 9 minus 5, 4 is 5. So I got the answer in my mind itself. Yeah, it's about just being faster. See, the answer is going to be same.
Yeah, thank you.
Yeah, it's only about a fast. You know, you can just look at it and find out the answer. Here, you definitely have to write it to do the subtraction at least. Yeah. I mean, you can think of this one in your mind. You can write this, and then doing the subtraction, you have to write and then do the subtraction. This one go direct. It's only about matter of time. That's it. The answer would be same.
Yeah, Vinisha ma'am.
Yeah. Is it Charan?
Yeah, Charan.
Yeah. Yes, sir.
So जो भी आपने कर रहा है अच्छा है, बहुत अच्छा है, उसमें कोई डाउट नहीं। लेकिन एक मैडम ने पूछा है कि इसको एक यूनिकनेस क्यों ना दे। मैं सबको सजेस्ट करता हूँ कि जो भी आपने जो भी मेथड सीखा है, बच्चे को अलग अलग टेक्निक देने के प्लेस में एक यूनिक टेक्निक देने पर वो क्या करते हैं कि एक मेथड सीख सकते हैं। उसलिए शायद मैडम बोला होगा कि हम दो
Definitely, you're right, sir. That's what I told Kanchan ma'am also.
उसलिए मैं इसमें सेम मेथड में और आप कुछ किस तरह ऑब्जर्वेशन करके एक पैटर्न जैसा बना सकते वो मैं बताता हूँ। सेम मेथड होता है, लेकिन आपने विलोकनम करके ऐसा किया ना, सेम मेथड। ऑलमोस्ट सबको समझ में आ गया, शायद कुछ नहीं है ना इसके बाद आपका?
नहीं सर।
हाँ, आप एक काम करिए, नंबर 3 मेथड को पहले एक क्वेश्चन फॉर्म करिए, नंबर 2 मेथड को सेकंड में लिखिए, नंबर फर्स्ट मेथड को थर्ड एग्जांपल में, 3 एग्जांपल लिखिए रैंडमली।
ओके,
ये जस्ट ऑब्जर्वेशन था, विलोकनम था, जो भी सूत्र आपने यूज कर रहा है उसको सूत्र को विलोकनम में, विलोकनम सूत्र को ऑब्जर्व करके हम कर सकते हैं। पहले हम नाइन्स कम होना है, एग्जांपल लिख दो, कोई बात नहीं, जस्ट रैंडमली एग्जांपल लिख दो।
Okay, so let's take this one only that we just did. 205 multiplied by 99.
और इधर सेकंड एग्जांपल मोर नाइन्स लिख दो।
Okay. Different example or the same example?
आपका मर्जी, आप कुछ भी लिख सकते हैं।
Okay.
मैं एक पैटर्न बताने वाला हूँ, क्योंकि एक अब खुद करना है, सब लोग यही काम करना है कि यूनिक कैसा बना सकते। एक बात मैं बताता हूँ कि मैं भी तुम्हारा स्टेज से यहाँ तक आया था कि जो भी आपने क्या क्या मेथड टीच कर रहा है सब ट्रेनर्स, वो भी मैंने सबको टीच करके आया था, तो आप गलत मत सोचना, ठीक है? मैं वो सीख के आया।
Not at all, sir. Even Kanchan ma'am also raised a very nice point. We can do a same method for all of them, and it's very workable. It's the same thing.
Yeah, and remember one
I
thing.
personally think it to be a faster method. That's
not like that. Again, it look like unique. And remember everyone, actually मैंने एक बात 888, 777, 444 जो भी मोनो डिजिट नंबर्स होता है, मोनो डिजिट का मीन्स इट रिपीटेड डिजिट को हम मोनो बोलते हैं। Whenever you are taking a mono digit into another number, every number has a different characteristics or the different behavior. So depend upon that behavior, we are selecting few numbers like ones and nines. They by we are taking those mono digit has a multiplier, then we are getting the answer so quickly and compare with other numbers. So that is the reason we are focusing on these two numbers only. That's the point you have to note it, everyone. Yeah. The first step is just we have to observe here how many nines you are taken in the first question. Just underline it. Two lines. So in the multiplicand also just select करना है, यहाँ 2 digit को select करिए from unit place. Right. Here में second example में आए तो 3 digits है अपन को. So यहाँ 3 digit, यहाँ 3 digit 9 select कर दिए. और नीचे हम आए तो 3 डिजिट है इसलिए वो भी सेलेक्ट कर, ठीक है. राइट. अब एक बात मैं बोल रहा हूँ क्या है कि जो भी नंबर दिया है उसका एक यूनियन पूर्ण लिख लो सब. एक यूनियन पूर्ण मींस वन लेस देन द गिवन नंबर दैट इज 204 स्लैश राइट 3 नेक्स्ट नंबर 301 स्लैश why because we are writing in the right place complements reason जो भी सेपरेट करके दिखाएंगे तो समझ में आ जाता है उसलिए. राइट. अब देखिए how many digit you marked there. Okay, just write the all from 9 last from 10 of those digits. That is 05 you marked there, so just write it 95 is all from 9 last from 10 in the right. All from 9 last from 10 just select market digit जो भी मार्क किया ना मल्टीप्लिकेंड में उसका all from 9 last from 10 लिख.
Okay.
हाँ उसका
95
लिख दो राइट हैंड. और इधर 302 का भी all from 9 last from 10 लिख दो, that is 698. और यहाँ भी लिख दो 665 है ना. हाँ 665. राइट. जो भी स्टेप्स आपने दिया है वो कंप्लीट हो गया, लेकिन अब एक बात देखना है कि जो भी मार्केट डिजिट है उसका मैंने कॉम्प्लीमेंट लिखा है क्योंकि जितना 9 होता है उतना मार्केट 9 है जीरोस आ जाता है. जो भी आपने पीले 100 माइनस 1000 माइनस किया ना में ये 9 0 को रिप्लेस करते हैं, इसलिए मैं उसका कॉम्प्लीमेंट लिख दिया. लेकिन फर्स्ट क्वेश्चन में देखिए मल्टीप्लिकेंड में 2 डिजिट मार्क किया है लेकिन एक डिजिट एक्स्ट्रा है, उस एक्स्ट्रा डिजिट को लेफ्ट हैंड में से निकाल दो. मतलब 2 है ना, 2 को निकालो. हाँ एक्स्ट्रा नंबर है तो मल्टीप्लिकेंड में लेफ्ट हैंड से निकाल दो. एक कंडीशन, पहला कंडीशन subtract from left hand side. So then no unmarked digit in the 205 unmarked digit is 2 only. That 2 is subtracted from the left hand part.
204 minus 2.
Yes.
Yeah, so that will become 202.
Right, and write the 95.
Okay.
So what we learn here, whenever unmarked digits are there in the multiplicand, we have to subtract from the left hand side.
Okay, perfect. Very good.
In this case, we have more 9s. Yeah, we have more 9s. So whenever you are getting more 9, just write in between the left and right part. How many extra 9s we have? Only 1. So just write in between left and right part. In the third case, there is no extra 9, there is no extra multiplicand digit. So that will be answer.
Super.
In this way, try to make uniqueness. So single method देके उधर इधर एक दो condition ऐड करके देने पर easy हो जाता है. ये मैं बोल रहा हूँ कि fast आ रहा है.
Yes, absolutely.
एक uniqueness दे रहा है.
Yes.
ठीक है.
Yeah, very nice, sir. Thank you so much, sir.
Yeah, here I used the sutra. All from 9, last from 10, ekanunena purvena, and the vilokanam. Why I am using vilokanam is if I solve this problem 99, if I convert it into 99 as 100 minus 1, I seen that in the left part, whatever ekanunena part will be there, from that number, I am subtracting 2. Every time I am seeing that part. So by the vilokanam I am doing here now. तो पहले आप उसको नंबर ऑफ प्रॉब्लम सॉल्व करके उसको समझना है कि क्या पैटर्न चल रहा है. सो इसी तरह जब भी कुछ भी मेथड्स हो वैदिक मैथमेटिक्स में आपके पास, ट्राई टू जनरलाइज थोड़ा उधर इधर करके थोड़ा आगे बढ़ाने के लिए कोशिश करना. क्योंकि 1950 1960 उस टाइम 1965 शायद बुक रिलीज हुआ है। कम से कम अपन को इधर 35 प्लस इधर 20 मतलब 50 इयर्स हो रहा है इजीली, मोर देन।
Yeah.
और थोड़ा ये अपना आगे बढ़ना है, सिर्फ उसके बाद हम स्टिक नहीं होना है। वो मेरा पर्सनल ओपिनियन था।
Yes, yes, sir, absolutely. Very nice technique, sir. I also learned it.
थैंक यू। अब शायद नेक्स्ट। और एक बात बताता हूँ कि मेरा क्लास में मैं कभी भी एक मेथड को फॉलो नहीं करता हूँ। टाइम पे दिमाग में क्या आता है वही बताता है। शायद आप ये मत सोचना कि मैं ये मेथड यूज कर रहा हूँ। ये डिपेंड्स होता है कि मैम एवरी टाइम आई चेंज माय मेथड। इट डिपेंड्स अपॉन द चिल्ड्रंस IQ. इफ दे आर नॉट
Yes,
अंडरस्टैंडिंग
yes,
दिस
yes,
मेथड,
sir. But बच्चों के साथ मुझे भी ना
टीच यू योर
न्यू
मेथड।
न्यू टेक्निक्स यूज करना पड़ता है।
आपका मेथड टीच करता हूँ। वो बच्चे थोड़ा शार्प है तो ये कर देता हूँ।
Yes.
तो यारी होता है अपने बच्चे के लिए।
Correct.
थैंक यू सो मच मैम।
Thank you, everyone. Thank you, everyone.
बहुत स्वीटली टीच किया है, मैं बोल सकता हूँ।
Thank you so much, sir. Thank you, everyone. Hope you liked my session. Thank you.
एंड कमेंट में दिया है कि देयर वाज लाइक 6 6 7 7। मैंने बोला ना दे हैव डिफरेंट कैरेक्टरिस्टिक्स। सी रीजन when you are talking about nines, we are doing suppose 19 and if you are taking as a multiplier, so 100 minus 1 you are writing. So मैंने can you share again whiteboard if you don't mind? मैं उसको कॉम्प्लिसिटी बताता हूँ, whiteboard शेयर करूँ। Suppose 29 into 77 लिख लो, रहने दो ये। अब देखिए इस मेथड को हम पहले क्या करना है कि लास्ट फ्रॉम 10 सॉरी ऑल फ्रॉम 10 लास्ट फ्रॉम 10 को यूज करना है। इसलिए हम क्या करना है कि ये 77 को बेस नंबर से निकालना पड़ेगा। तो निकालेंगे तो क्या हो जाता है 100 माइनस 23 आ जाता है। अब 9 का बिहेवियर देखो, 100 माइनस 1 होता है कि वो बहुत नियरेस्ट होता है, तो इसलिए 1 से मल्टीप्लाई करने पर हमको इजी हो जाता है। लेकिन इस नंबर का कैरेक्टरिस्टिक्स क्या है, ये बहुत दूर होता है। और 100 से 29 करेंगे तो 29 100 आ जाता है, उसमें कोई प्रॉब्लम नहीं। फिर 29 को लेके 23 तो करना पड़ेगा ना। उधर जो भी टेक्निक अप्लाई करते हैं वही टेक्निक वर्टिकल क्रॉस से इसके अप्लाई करके आंसर ही निकाल सकते हैं। इसलिए मैं बात बोल रहा हूँ कि कहाँ इजी आंसर निकालने के चांसेस आ रहा है, हम उसको पिक कर रहा है, वो समझो पहले लोग। ये टेक्निक वेक्निक नहीं है, ये जनरलाइज साइंटिफिक प्रूफ था। सो इसको हम मेथड्स बोलेंगे तो सही होगा, इंक्लूड इंस्टेड ऑफ टेक्निक। अच्छा अपन एक्सेप्ट किया है टेक्निक से, मेरा पर्सनल फीलिंग था, हम लोग मानने का जरूरत भी नहीं। या
Thank you so much, sir.
Yeah, right. So thank you so much, madam.
Thank you, sir. Thank you.
77 को ब्रेक करके भी तो यूज कर सकते हैं ट्रिक।
Yeah, in many ways we can do. There is no problem. But where we are getting the easiness?
Because it becomes so easy when we break it into the 11. 77 multiplying with 11 multiply with 77.
Yeah.
And use the
Shamshi
one.
जी, Shamshi जी, मैंने ये word use किया है कि suppose the same technique wherever I use it for 9, all from 9, last 10, एक and four, if you want to use those two formula, was in all cases, then it is not what those sutra. Whenever you said like 77, you can write 11 into 7. Then it is work. There is you are not using all from 9 last from 10 सूत्र। वो सूत्र भी यूज करने के लिए कॉम्प्लेक्सिटी क्या है उसके बारे में बता। लेकिन मैं ये नहीं बोला है कि इसको उसका अल्टरनेट नहीं है अल्टरनेट। ये सूत्र को हम अप्लाई करने के लिए ट्राई करते कोशिश करते, वर्कआउट नहीं हो सकता है, वो बात मैंने बोल रहा।
Okay, sir. Because in Vedic mind there are so many sutras and so many tricks.
Yeah.
Thank you, sir.
या नेक्स्ट टॉपिक अपन को गरिमा मैडम लेने वाला है। मैडम का टॉपिक सॉरी मैडम,
Yes,
आज
sir, I
अपन
am
को
here only.
वर्टिकल क्रॉसवाइज को यूज करने वाले हैं मल्टीप्लिकेशन।
Yeah, sir, I am here only to take the class, if you allow me.
या बहुत सुंदर सा टॉपिक है वो। एक मिनट में आपको होस्ट बना
Okay, sir.
दिया मैम, आप शेयर कर सकते
Hello, everyone. This is Garima Mandwani, and today I'm going to take the session on the vertically and crosswise multiplication. This method is also known as many of masters and many institute calling it crisscross method or general multiplication or rapid multiplication. You can call it any name. So I am calling it general multiplication. Why? Because we can take any number in this method. So for this method, our sutra is Urdhva Triyabhyam. Urdhva Triyabhyam. So the meaning of this formula is vertically and crosswise. And we have one diagram for this. The diagram is like, first I am going to take 2 by 2 multiplication. For 2 by 2, we are going to make a diagram in 3 parts. So this is how I am taking for my students also and for teacher course also. This is really easy to understand for students if you will go with the diagram and explain them with dots. These dots we are pretending as a digits, 2 digits, 2 by 2 digits. So first part is you have to connect first 2 dots. Second part you have to connect all 4 dots crosswise. And the last part you have to connect last 2 dots. So this how this is vertically and crosswise. Student and children can understand it easily with the help of the diagram. And one more thing I'm explaining them that when you have 4 digits, your answer will be in 3 parts. So 4 minus 1, 3 parts. And if you are going to take 3 by 3, 6 digits, so 6 minus 1 answer will be in 5 parts. So after this, we will go for 3 by 3. First, we are going with the 2 by 2. So I'm taking a random number. If my sum is 27 multiplied by 84. So our answer will be in 3 parts. As our diagram are in 3 parts, you can give the numbers also 1, 2, 3. So first part, you have to multiply first 2 digits, 2 into 8, 16, 2 8s are 16, put 16 in the first part. Last part, you have to multiply last 2 digits, 7 multiplied by 4, so 28. And middle part, you have to multiply crosswise, so 2 by 4 and 7 by 8. 2 4s are 8, 7 8s are 56. 56 plus 8. So 56 plus 8 is 64. You have to put 64 in the middle part. So you have to multiply crosswise and add them and put it in the middle part. And from every part now, single digit will come down. You have to start with the last digit. So 8 down. This 2 you have to take in the next part. So 2 plus 4, 6. And then 6 you have to take here. So 6 plus 16 is 22. So our answer is double to 2268. So this is how we are applying this 2 by 2 method. I hope everyone understood. If you have any question, any doubt, you can ask me, unmute yourself, or you can put it in the comment box. I hope I am audible and visible to everyone.
Yes, madam.
Yeah, thank you so much. Shall I go with one more example for 2 by 2, or we can move to 3 by 3?
Ma'am, 3 by 3.
Okay, we'll go for the 3 by 3. So for 3 by 3, if I will explain the diagram, so you have to take all three dots in the every, so in short, I am going to explain. Like middle part is important in everything, every method. So 3 by 3, if I will take, so first part, you have to connect again, first 2 dots. Second part, you have to connect first 4 dots. And the middle part, you have to connect all 6 dots like this. And then after that, next part, last 4 dots and last 2 dots. So this is how our diagram will be in the 5 parts. So now if we will do, sorry. Sorry, can anyone help me how to go with the next page?
मैडम शायद ऊपर होगा और स्मॉल एरोस होता है उधर इधर ऊपर टॉप में जो व्हाइट पेपर या नहीं तो नीचे नीचे प्लस आइकॉन है ना नीचे राइट कॉर्नर में एक बॉक्स है उसके प्लस सिंबल है ऊपर जो व्हाइट पेपर में व्हाइट बोर्ड का व्हाइट पेपर में राइट कॉर्नर बॉटम राइट बॉटम.
Okay, thank you, sir. So here I am taking 3 by 3. So if my number is 385 multiply by any random number you can take here. Four, 2, 9. So now we have 6 digits and our answer will be in 5 parts. So you have to make 5 parts of the answer. First part, first 2 digits, 3 and 4, 3 4s are 12. So you have to put 12 here. Second part, 4 digits. So 3 by 2 and 8 by 4. 3 2s are 6, 8 4s are 32 plus 6 is 38. Last part, last 2 digits, 5 9s are 45. So you have to put 45 here. Second last part, last 4 digits, 8 by 9 and 5 by 2. 8 9s are 72, 5 2s are 10. 72 plus 10 is 82. You have to put 82 in the second last part. And then middle part, you have to take all 6 digits. So 3 by 9, 3 9s are 27, 4 5s are 20, 20 plus 27 is 47, and 8 2s are 16. 47 plus 16 is 53. Sorry, 63. 47 plus 16 is 63. So you have to put 63 in the middle part. And then the same rule, from every part you have to take 1 digit down. So 5 down, 4 plus 2, 8. Then this 8 you have to take here, 8 plus 3, 11. So 1 down and 1 carry over above the next digit. So 1 and 6, 7. Again, you have to take to the next part. 7 plus 8, 15. So 5 down, 1 carry over above the 3. And then this 1 plus 3, 4 you have to take here. 12 plus 4 is 16. So 16 will come here. So this is our answer. Okay. This 3 by 3, we can go with the, like if your sum is 3 by 2, suppose my sum is 472 multiply by 29 or any 2-digit number you can take. So this there also you can apply this method. Only you have to fix a 0 here and then go with the same method. So first part 4 multiplied by 0 is 0. Last part 2 9s are 18. Second part 4 2s are 8. 7 multiplied by 0 is 0. So 8 only. Second last part 7 9s are 63. 2 2s are 4. So 67. 63 plus 4 67. And the middle part 4 9s are 36. 2 0 0 and 7 2s are 14. 36 plus 14 is 50. So 50 in the middle part. And then 8 down. This 1 you have to take here. 1 plus 7, 8 again. And then 6 you have to take in the next part. So 6 plus 0, 6. And then this 5 you have to take here. 5 plus 8, 13. And this is our answer. So this is how we can go with the 3 by 2 multiplication also. And after explaining this much, 2 by 2, 3 by 3, again, my question with the students only how to go with the 4 by 4. And it will really increase their thinking levels that how to go with the 4 by 4. And they are suggesting me how to make the diagram for 4 by 4 and how to go with that. So same question I want to ask from you also. If you are, I think here everyone is a teacher or maybe some students are there. So you can suggest me how to go with the 4 by 4. Anyone?
7 parts.
Yes, we have to make 7 parts of the answer, correct? So first part, first 2 dots. Second part, first 4 dots. Third part, first 6 dots, and the middle part, all 8 dots, you have to take the big cross and the middle cross. So this is how you have to go with the middle part and then reverse thing. So this is how we can apply this multiplication in any number. And this is very, very useful for squares also. You can go with the big numbers square with this method also, 3 by 3 or any 3-digit square or any 4-digit square. You can go with this method very easily. Okay, so this method is done here. If you have any other question, any other queries, or I can take any other method if anybody wants to. So,
Ma'am,
4 by 4 method, can you explain it? Like,
sorry.
the diagram. 4 by 4 method, can you explain it?
Yes. Okay, we are going to take one example for 4 by 4. So I'm direct taking in the sum. Is it okay or you want a diagram?
I want diagram, ma'am.
Okay, 1 minute.
Ma'am, diagram also will do.
Okay, 1 minute. So this sum I am taking here and diagram I am making down here. So first part, you have to connect first 2 dots. I'm not making 8 dots, but I am explaining you in the dots only. And the second part, you have to connect first 4 dots. So like cross. And the next third part, you have to connect first 6 dots. So again, the same how we done in the 3 by 3 middle part, you have to connect like that. And the middle part here, you have to take all 8 dots. So here you will connect corner to corner and then middle dots crosswise. So this is how this middle part will go. And then again, next part, last 6 dots. So last 6 digits, you have to leave the first 2 digits and last 6 digits, you have to make the diagram like this. Then last 4 dots, next part, last 4 dots. And the last part is last 2 digit. Am I clear? This diagram is clear with you, I think so. So now let's see how to go with the sum. So you have to make 7 part of the answer as we have 8 digits. So again, I'm saying that whatever number of digits you have, your answer will be 1 less of that. So 8 digit less 1 is 7. So our answer will be in 7 parts. 3, 4, 5, 6, and 7. So first part, 4, 3, first 2 dots, 4 3s are 12. You have to put 12 here. Last part, last 2 digits, 7 6 are, sorry, 42. So you have to put 42 here. Second part, 4 digit, 4 2s are 8, 3 8s are 24. So 8 and 24 is 32. Second last part, 7 5s are 35, 2 6s are 12. 35 plus 12 is 47. You have to put 47 in the second last part. Third part, 4 5s are 20, plus 3 2s are 6, so 26, and 8 2s are 16. 16 plus 26 is 42. So you have to put 42 in the third part. Third last part, last 6 digits. So 8 6 are 48. 7 2s are 14. 48 plus 14 is 62. 2 5s are 10. 62 plus 10 is 72. So you have to put 72 in the third last part. Now the middle part, all 4 digits. You can even write down if you are not, students are not in first session, second session, they are not able to do addition mentally. So they can write it in the corner. 4 6 are 24. 7 3s are 21. 2 2s are 4 and 8 5s are 40. So 40 and 4. And you have to add. So here 9 and here 8. 89 is the sum. So you have to put 89 in the middle part. This much clear, everyone? So now the same rule, 1 digit from every part will come down for the answer. So here 2 will come down. Then 4 you have to take here. 4 plus 7, 11, 1 down. 1 carry over above the 4. 1 plus 4, 5. You have to take here. 5 plus 2, 7. Then 7 you have to take here. 7 plus 9, 16. 6 down. 1 carry over. 1 plus 8, 9. 9 plus 2, 11. 1 down. 1 carry over. 1 plus 4, 5. 5 plus 2, 7. And then this 3 plus 12, 15. So the answer is 15716712. Is it clear?
Ma'am, do the addition once again, ma'am, please.
Which addition? Middle part?
Yes, ma'am.
The last final answer?
Yes, ma'am.
Okay. So last digit 2 will come down. Then 4 you have to take in the next part. 4 plus 7, 11. So 1 down and 1 carry over above this 4. And this 1 plus 4, 5 will go to this 2. 5 plus 2, 7 down. Then this 7 will go to 9. 7 plus 9, 16. So 6 down. 1 carry over above the 8. 8 plus 1, 9 will go to this 2. 9 plus 2 is 11. So 1 down. 1 carry over above the 4. 1 plus 4, 5 will go to this 2. 5 plus 2, 7. 7 down. And then this 3 will go to next part. 3 plus 2, 5 and 1. So answer is 15716712.
Okay, thank you, ma'am.
You're welcome. Okay, so this method you can extend to any number of digits, 5 by 5, 6 by 6. I mean, you can create your thinking skills also. You can develop your thinking skills that how we can go with 5 by 5, 6 by 6. Okay. So this topic is, I am done with this topic. If you have any question or you want more explanation, I can go with that.
Yes, ma'am. This extreme right first and the second digit are, we can do it manually. But is there any other way, or just it's a matter of practice. Let's suppose there are 3 digits or 4 digits, then it is difficult to write in difficult to multiply and then to add the numbers. Is there any shortcut for this, or you just need to practice that thing and it will come?
Yeah, you have to practice with this. Actually, shortcut is like different method are there. Like before this methods were explaining the multiplication by 9. So we have many methods. So when you have particular type of sums, like we have multiplication last totaling 10, or multiplication by 11, or there is one method multiplication by 12 to 19. So particular sum you can go with the quick method, which is related to that topic. But for this topic, if the number are not related any other topic, then you can go with this topic only. And it is like the shortcut is you have to make the practice of addition, or you can write in the corner and then you can do it.
Because the way you did 6 4 are 24, 7 3 are 21, everything first you did it in your mind, right?
Yes.
When I take 24, 21, I add it and I miss the first number, like that happens. So anything we can do for that.
Sir, this is the only practice. Like I can make this 24, 21, 40 in my mind only, because I'm taking every day I'm taking the classes. I'm working with the school also. So there also I'm taking Vedic math. So it's only the thing which you can practice and you can make it fast.
Okay, thank you.
Yeah. Any other question? Actually, Charan sir gave the advice, if there is any other method, we can go do it easily, because he is really expert in this field. So sir, you can help us if there is any other method they can.
Actually, I'm not going to use like a particular format, like a 2 digit into 2 digit, 3 digit into 3 digit, 4 into 4. I'm not going to use, why? Because you are teaching patterns. Suppose in the previous example, you given 3 digit into 2. Am I right? And just you're keeping 0 to the left place, highest place, and you're making again equal digit using 3 into 3. Of doing like that, I have only one pattern, and it is working on, I mean, it works on place values. You think you are doing whatever, लेकिन वो place value पर काम करता है. If you once understand that logic, every number, any kind of number, without putting zeros also, we can find the answers. But it takes time actually. Let me explain you one example. Suppose 2 digit into 2 digit, right? Any randomly.
Yes, you can take some.
Yeah.
Shall I stop sharing, sir? You will continue with that?
No, you can write. You can write.
Okay. So shall I write 3 by 2?
Okay, your wish. You can write any places. Suppose write 1, 2, 3.
Okay.
And what is the next digit you are? Wait.
Okay.
Write those 2 digits below 4 and 3.
Okay.
Because मैंने आपको चांस नहीं दे रहा हूँ कि आप 0 लगाने के लिए, इसलिए मैं 7 8 को रख दिया. मैं 7 8 3 के नीचे 8 के नीचे रख दो तो 0 लगा सकते हो.
Here.
हाँ, नहीं उधर नहीं, लेफ्ट हैंड में.
Left hand?
लेफ्ट साइड में 7 8 का लेफ्ट साइड में आप 0 लगा के 3 डिजिट कर रहे हैं ना.
Yes.
हाँ, वो चांस मैं आपको नहीं दे रहा हूँ क्योंकि मैंने 4 का नीचे लिख दिया क्वेश्चन.
Okay.
अभी भी सेम मेथड हम यूज करते हैं. पहले 7 into 4 करा.
So 4 7s are 28. We have to write here. Okay.
अब इधर क्या किया है कि मल्टीप्लेयर में हाईएस्ट प्लेस डिजिट में 7 है. 7 को चूज किया है. 7 पहले 4 से मल्टीप्लाई हुआ है. क्लियर?
Okay.
अब 7 नेक्स्ट प्लेस में 3 से मल्टीप्लाई होता है.
Okay.
कितना आता है? 21.
Yes. So shall I write 21 here?
आपका मर्जी लिख सकते हैं, कोई बात नहीं. फिर और एक कॉम्बिनेशन का ऐड करना पड़ते है ना.
So I'll put this line here.
हाँ, लाइन. अब मैं क्या बोल रहा हूँ कि एग्जैक्टली 7-3 को लाइन ड्रॉ करो एक बार। 7-3 को राइट। अब देखिए एक्चुअली 7 का प्लेस कितना है, 10 है। 3 का प्लेस कितना है, 10 है।
10 है, राइट।
10 का मतलब आपने 100 का प्लेस में 21 लिखा है, लेकिन और एक 100 प्लेस वैल्यू भी आ जाता है, उसको हम फाइंड आउट कर। वो हम कैसा फाइंड आउट करते हैं कि 3 के लेफ्ट साइड में क्या डिजिट है,
8।
लेफ्ट
में 4 है।
और जो 7 सेलेक्ट किया ना उसको राइट साइड में क्या डिजिट है,
7 का राइट में 8।
हाँ, इसी तरह कॉम्बिनेशन को देखने पर भी अपन को सेम प्लेस वैल्यू का आंसर आता है। सो 3 का लेफ्ट साइड में 4, 7 का राइट साइड में 8, दैट इज 4 into 8, 32 भी 100 प्लेस वैल्यू का नंबर है।
ओके।
उसको मैं ऐड कर देता हूँ
21 में।
हाँ 21
plus 32, so you have to add it.
हाँ ऐड कर दिया, राइट।
Okay.
छोड़ दो, बाद में कर लेंगे।
ठीक है,
राइट। अब शार्ट लगाओ। अब मैंने 10th प्लेस के लिए फाइंड आउट कर रहा था। अब देखिए पहला 7 सेलेक्ट किया, 7 4 से मल्टीप्लाई कर दिया फर्स्ट स्टेप।
राइट।
सेकंड स्टेप में 3 से मल्टीप्लाई कर दिया, हो गया। थर्ड स्टेप में मैं क्या करता हूँ, 8 डिजिट से मल्टीप्लाई करता हूँ, हो गया 8, मतलब 56 आ गया।
8 8s are, oh 8 7 are 56, yes.
अब मेरे को बताइए, तो जो भी 3 7 का लाइन ड्रॉ किया ना, उस लाइन को हटा दो, 7 3 का लाइन। अब इसके किसको मल्टीप्लाई किया है, 7 8 को मल्टीप्लाई किया है,
राइट। 7 8
हाँ लाइन को ड्रॉ करो। हाँ अब देखिए आपका करंट पोजीशन 7 के पास है, 8 के पास है। मल्टीप्लिकेंट में 8 के पास करंट पोजीशन है, मल्टीप्लेयर में 7 के पास है।
करेक्ट।
ये दोनों मल्टीप्लाई करने के बाद आपको 10th प्लेस वाला आंसर आया है, लेकिन और एक 10th का भी मिल सकता, अपन फाइंड आउट कर सकते हैं। सेम प्रोसीजर, मल्टीप्लिकेंट में लेफ्ट साइड जाओ, 8 के लेफ्ट में 3 है, 7 के राइट में
8 है,
मल्टीप्लाई कर दो,
3 8s are 24. We have to add 24 in this 56.
अब करंट पोजीशन कहाँ हो, 8 and 3 के पास हो, और 3 के फिर लेफ्ट में 4 है,
करेक्ट,
और एक डिजिट, लेकिन 8 का राइट में कोई डिजिट ही नहीं है,
राइट।
इसका मतलब मल्टीप्लिकेशन नहीं कर सकते,
नहीं
क्या
कर
है, स्टॉप हो गया।
तो
अब
0
फोर्थ,
yes.
अब फोर्थ प्लेस में मेरा 7 8 के नेक्स्ट डिजिट में मल्टीप्लाई होगा, लेकिन 8 के नेक्स्ट डिजिट नहीं है इधर,
कोई नहीं है, राइट।
उसलिए हम क्या करता है, उसको छोड़ के 8 को ले लेते हैं।
ओके।
8 कभी भी आप ऐसा न्यू डिजिट लेने पर वो हर टाइम क्या होता है कि यूनिट प्लेस ही मल्टीप्लाई होता है, एक कंडीशन। Whenever you are selecting a digit in the multiplier, new digit, it is always multiplied unit place of the multiplicand.
Okay.
मतलब 64, 8 into 8, 64. You can write
64 in the last part here. Okay.
In the same way, can you take like smaller numbers, 4 digit into 3 digit?
Okay.
Don't find the answer because everybody knows. Just I'm saying the pattern.
Yeah, actually, I have the practice of what I explained is from the long time. So it is, this is my personal suggestion that it is little bit confusing for students. Like we can understand as a teacher that what you are explaining. Yeah, that what, yes.
मैं बताता हूँ, मैं क्या है कि आपको मैंने प्लेस वैल्यू के बारे में समझने के लिए बताया था, लेकिन इस पर मैंने बच्चे पर भी प्रयोग किया था, टीचर्स पे भी प्रयोग किया था, स्टूडेंट्स पर भी प्रयोग किया था। दे कैन डू वेरी फास्ट, क्योंकि 15 साल एक्सपीरियंस है टीचर्स वैदिक मैथमेटिक्स में, और बच्चे भी। मैं आपको प्लेस वैल्यू बीच बीच में बोला है कि आपको मैंने कुछ नहीं बताया, उससे प्लेस वैल्यू के बारे में मैंने इधर ओपन किया था, लेकिन मैं ऐसा नहीं बताता, सिर्फ 3 कंडीशन बताता हूँ। पहला कंडीशन क्या है कि वी हैव टू सेलेक्ट ए हाईएस्ट प्लेस डिजिट फ्रॉम द मल्टीप्लेयर, That means multiply each and every digit of the multiplicand in each step. पहला कंडीशन. सेकंड कंडीशन क्या है कि जब भी आप मल्टीप्लाई करते हैं सिलेक्टेड डिजिट है वो करेक्ट पोजीशन से लेफ्ट साइड राइट साइड जाके भी मल्टीप्लाई करना.
ओके.
आपको मैं एक काम करता हूँ, आप स्क्रीन को हटा दो, मैं जो एक नाम लिखता हूँ, नंबर बोलता हूँ, नंबर लिखिए, आपको इजी समझ में आ जाता है मैं क्या बोल रहा हूँ. ABCD.
Shall I write ABCD?
Yeah, give the space between the words so that everyone can easily understand. Write in the smalls. ABCD. Write any 3-digit number, suppose XYZ.
Sorry, sir. Please repeat again.
XYZ, 3-digit number, XYZ. थोड़ा नीचे लिखो.
Under this.
आपका मर्जी, आप कहाँ भी लिख सकते हो, कोई फर्क नहीं.
Okay.
ऊपर भी लिख सकते हो, नीचे भी लिख सकते हो.
ठीक है sir.
My first condition is we have to select highest to place digit from the multiplier, that is X. Right. अब लाइन ड्रॉ करिए हॉरिजॉन्टली. मैं जो बात बताता हूँ सिर्फ उसको लिखिए.
Okay.
वो नहीं, बैलेंसिंग करने के लिए अपन एक लाइन ड्रॉ करते हैं ना नीचे, दोनों नंबर के नीचे मल्टीप्लाई करने के बाद.
Sir, you can take the screen. I mean, you can make your host yourself. I'm not getting what your instruction you are giving me.
Yeah.
Yeah, please you do, and then I can understand easily.
क्या है कि मेरा कहना क्या है कि अपने इतना मेथड्स लेने का जरूरत है, क्योंकि 1 to 3 years बैक मैंने भी आपने जो बताया वही मैंने सीखा था, मैंने सबको टीच किया था, लेकिन मेरे को उतना अच्छा नहीं लग रहा था क्योंकि डिवीजन में मेरे को यूज नहीं हो रहा है. इसलिए मैं क्या बोल रहा हूँ कि A B C D X Y Z. ओके. पहला कंडीशन, we have to select the highest place digit. Is it clear every time? Why? Because I'm starting from the left side to right side. So it will be multiplied by first digit AX. In the second step, it will be multiplied by second digit XB. But this is your current position.
Yes.
In the multiplication move, left side, here right side. That means A into Y also belonging to the same place. Okay. Now I want to multiply with third digit, that is XC. This is my current position. Move left side, move right side, that is BY also same position. Okay. Again move left side and right side, that is AZ. That is also belonging to the same position. After that we don't have any place value. Next. In the fourth step, my digit will be multiplied with fourth digit AD. So this is your current position. So left side and the right side, that is CY we got. You can clearly see I stopped at C and C. From C, left side and right side, if you move, that is BZ. So these two things I want to multiply. Okay. Now see. Next step, your X's must be multiplied the digit which is after D. But there is no digit. So that is the reason I want to select new digit here. So that is new digit is always multiplied by unit place digit. That is YD. Again same procedure. Go left side, go right side. That is CZ is the same place digit product. Okay. Next, if you go to the B, after that there is a no place. Just you skip that step. Right. Again your DY is multiplied with the next digit of the D. But there is a no digit. So that is the reason I want to select new digit. The new digit again always multiplied unit place digit only. Then I got the answer. Simple. You can take यही 3 कंडीशन को मैं आप 3-4 क्लास में सपोज इस कॉन्सेप्ट को सिखाने के लिए कोशिश किया. सपोज मान लो मैं क्या करता हूँ कि जो ने मैंने 3 स्टेप्स बोला ना, क्या एक डिजिट सेलेक्ट करना है, हर प्लेस में एक एक डिजिट से मल्टीप्लाई होता है, और लेफ्ट साइड राइट साइड कॉम्बिनेशन लेना है, और नया डिजिट लेने समय पे वो हर टाइम यूनिट प्लेस से मल्टीप्लाई होता है. ये 3 कंडीशन सपोज आपको 4 क्लास लगा है तो सपोज बच्चों को मैं 2 क्लास में पूरा समझा देता हूँ. पैटर्न गीटन कुछ नहीं बोलता हूँ. मैं एग्जांपल करके दिखाता हूँ आपको. सपोज 2 3 4 into 42. ओके. मैंने बोलता हूँ जो सुनो, आपको समझ में आता कि नहीं मेरे को पता नहीं, लेकिन मैं बताता हूँ.
Okay, sir.
I selected 2. 2 is multiplied by first number, that is 4, that is 8. तो 3 कंडीशन बारे में बात करें. Next, my 2 is multiplied with second digit of the multiplication s. इससे फर्स्ट स्टेप में फर्स्ट डिजिट हो गया, सेकंड में सेकंड, मतलब 4 आ गया. करंट पोजीशन में इसमें लेफ्ट जाना, हर बार लेफ्ट जाना मल्टीप्लिकेशन में, इधर राइट जाना, मतलब 4 3 के पास हो, मतलब 12, 16 आ गया. राइट, मतलब ये दोनों डिजिट को भी मल्टीप्लाई करना है उसका. राइट, आप देखिए मेरा 2 सेकंड डिजिट को मल्टीप्लाई होगा, मेरा 2 थर्ड डिजिट को मल्टीप्लाई होगा, लेकिन कुछ डिजिट है क्या इधर? नहीं है, इसलिए मैं इसको एलिमिनेट कर देता हूँ. न्यू डिजिट को सेलेक्ट कर. हर टाइम न्यू डिजिट सेलेक्ट करने के टाइम पे यूनिट प्लेस से ही मल्टीप्लाई होगा. ये थर्ड कंडीशन. सो मेरे को 6 आ गया, और करंट पोजीशन में लेफ्ट साइड राइट साइड जाने पर 4 4 है, ये 16 था, मतलब 22 मैंने लिख दिया. राइट, अब फिर मेरा 3 क्या करता है कि नेक्स्ट डिजिट से मल्टीप्लाई, लेकिन नेक्स्ट डिजिट नहीं है इधर, इसलिए मैं क्या करता हूँ और एक डिजिट को सेलेक्ट कर लेता हूँ. कभी आप एक न्यू डिजिट को सेलेक्ट करते हैं और हर बार यूनिट प्लेस से ही मल्टीप्लाई, इसलिए मेरे को इधर कितना काम है. आंसर क्या है? 8. ये 3 कंडीशन सब मल्टीप्लिकेशन में अप्लाई होता है. मतलब 3 2 1 0 4 2 0 1 था. सेम कंडीशन एक बार ऑब्जर्व करिए, क्योंकि आप में सब कुछ मैंने डिस्कस नहीं कर रहा था, ओरली ऊपर ऊपर बता रहा, उसलिए शायद आपको समझ में नहीं आता है, लेकिन कोशिश करो समझ. राइट, 4 सेलेक्ट कर लिया. 4 किससे मल्टीप्लाई होता है? मेरा 4 किससे मल्टीप्लाई होता है?
3 से.
3 से 12 हो गया. राइट, सेकंड स्टेप में
4 को
4 into 2.
4 and 2 3 and 2.
हाँ, समझ गए अब बात. 8 + 6 कितना?
14.
थर्ड स्टेप में किससे मल्टीप्लाई होना है?
3 0 4 1 and 2 and 2.
थर्ड में थर्ड डिजिट से मल्टीप्लाई होगा. ठीक है, इसका लेफ्ट में इसका राइट में 2 2 है, इसका लेफ्ट में और इसका राइट में 3 0 है.
करेक्ट,
मतलब
4 4
8 आ गया. अब मेरा फोर्थ स्टेप है. फोर्थ स्टेप में मेरा डिजिट किससे मल्टीप्लाई होना? फोर्थ डिजिट. ये मेरा फोर्थ डिजिट 0 था. लेफ्ट जाओ और राइट जाओ, सेम, मतलब 2.
यस,
लेफ्ट जाओ राइट जाओ 0, लेफ्ट जाओ राइट जाओ, मतलब 4 6 0 9, मतलब पूरा 9 आया.
करेक्ट.
अब मैंने क्या बोला? नेक्स्ट मेरा फोर्थ सेलेक्टेड डिजिट 4 नेक्स्ट नंबर से मल्टीप्लाई होना, लेकिन इधर कुछ डिजिट नहीं है. ये क्या करना है? न्यू डिजिट को सेलेक्ट करना है. न्यू डिजिट हर बार किससे मल्टीप्लाई होता है? कंडीशन यूनिट प्लेस से मल्टीप्लाई होता है, मतलब 0. फिर से लेफ्ट साइड राइट साइड 0, लेफ्ट साइड राइट साइड 2, मतलब इधर मेरा 2 आया. फिर मेरा 2 मल्टीप्लाई करने के लिए कुछ डिजिट नहीं है 0 के नेक्स्ट. नया डिजिट से नया डिजिट किससे मल्टीप्लाई होता है? यूनिट प्लेस. 0 आ गया, लेफ्ट जाओ फिर राइट जाओ, 1 आ गया. इधर लेफ्ट जाने पर 2 है, लेकिन राइट जाने पर कुछ डिजिट नहीं है, इसका मतलब उधर कॉम्बिनेशन नहीं है. तो इधर मेरे को 1 आ गया. राइट, हमारा सेलेक्टेड डिजिट 0 था. 0 यूनिट प्लेस को रीच हो गया. उसके बाद नेक्स्ट डिजिट से मल्टीप्लाई होना, लेकिन नेक्स्ट डिजिट नहीं है, इसलिए न्यू डिजिट को सेलेक्ट करना, इससे मल्टीप्लाई होता है. ये 3 कंडीशन सबको यूज करना. पैटर्न नहीं सिखा.
यस,
समझा? यूनिक एक ही मेथड में आ जाता है. इस मेथड को ध्वजांक मेथड में एज इट इज 100% सेम लॉजिक से मैं यूज करता हूँ.
Yes, sir. This is really beautiful method, and I mean this, but this need a really good practice to go with this fluently.
हाँ, उसलिए मैं बताता हूँ ना. 4 क्लास मैंने क्या सोचता हूँ कि जनरली पैटर्न सिखाने के बिना इसको मैंने उसको अच्छा तरह दो क्लास में या नहीं तो 3 क्लास में सिखा दूं,
जी सर।
एक बार वो समझ में आ गए तो कितना बड़े नंबर में भी सेम 7 into 7 भी मैंने न्यू पैटर्न सिखाने का जरूरत नहीं है, सेम लॉजिक 7 into 3 कर रहा है, सेम लॉजिक। और एक
करेक्ट।
बात बता देता हूँ, सुनिए। आप लोग मोस्टली प्रिफर करते हैं डिजिट्स को इस तरह कॉम्बिनेशन को और इसी तरह कॉम्बिनेशन मल्टीप्लाई करने के मोस्ट ऑफ, लेकिन जो मेरा कंडीशन से ये 4 केसेस को सॉल्व कर सकते बिना चेंज द exactly wherever the digit located their place you don't want to change, take as it is position. Here 32 is in this position, then kept same position, you can apply the same thing. 4 ही केसेस को यूज करता है, ये 4 केसेस हमको डिवीजन में आता है, इसलिए उस डिवीजन को इजी करने के लिए मैं इस पैटर्न को सीखा। ओके, मेरा पास तो ये मेथड मैं अभी यूज कर रहा था, मैं सब गवर्नमेंट टीचर्स को भी यही टीच किया था, हमारा गवर्नमेंट टेक्स्ट बुक में ये मेथड देने की कोशिश कर रहा हूँ।
हाँ सर, पर अगर हमें छोटे बच्चों को सिखाना है, जैसे 3rd 4th के बच्चे हैं, दैट कैन दे अंडरस्टैंड दिस?
नहीं, उसको हम सिखाना है कि गेम तरह, मतलब डायरेक्ट नंबर लेके मल्टीप्लाई करके सिखाना, प्लेस में क्या करना है कि गेम तरह करना, क्या करना है कि फॉर एग्जांपल मैं तोड़ दे रहा हूँ, ये वर्कआउट होता है कि नहीं मेरे को पता नहीं, लेकिन मैं एग्जांपल कह रहा हूँ। सपोज XY दिया मैंने, भाई बच्चे को पहला कंडीशन देना है कि हर बार इसको ही सेलेक्ट करने के लिए पुश करना, बोलने के लिए उसको समझ में आता है कि अच्छा मैं ये कर लेता हूँ। करने के बाद सर ने बोला है कि इसको सेलेक्ट करने के बाद इससे मल्टीप्लाई कर, सर बोला इसी तरह गेम जैसा कुछ भी एक्टिविटी जैसा बार बार रिपीट कराओ, समझ में आता है। एक ही बार तो नहीं समझ में आता है कि आपने 2 into 2 लिया ना, इसी तरह एक ही बार नहीं समझ में आता, क्योंकि ये सिर्फ 2 into 2 है, ये लॉजिक सब नंबर्स के लिए। 1 hour क्लास ले लो, क्या फायदा है, एक बार 1 hour क्लास में पूरा समझ गए तो हर मल्टीप्लिकेशन खुद कर लेता हूँ विदाउट आवर प्रेजेंस, उसके बारे में सोचना ऐसा।
ओके सर।
इसको कर लो, उसके बाद ये इससे मल्टीप्लाई होता है, सेकंड में सेकंड से मल्टीप्लाई होता है, हर बार आप इसको मल्टीप्लाई करने के बाद पीछे जाओ, आगे आओ, पीछे जाओ, कुछ भी एक्टिविटी जैसा आपका स्ट्रैटेजी यूज करिए, एक बार देखिए बेनिफिट में फायदा आ रहा है तो आप कर सकते।
Sure, sir. I will do practice. I mean, I will try it and will do the practice also.
Yeah, sir, can you prefer any book for this method? Ma'am, this is the method designed by me only. They are not available in any book. जो भी मैंने
actually I learned this 2-3 I mean this dot method, the diagram what I made, that also I referred from a book or where I learned the Vedic math. The teacher taught me that one only.
Yeah.
So
गरिमा जी, आपको नहीं बोला था, मेरे को एक मैडम पूछा है कि कमेंट में दिया है कि इसके लिए कोई बुक है क्या, उसके लिए बोल रहा था।
सर आपका कोई चैनल है जहाँ पे ये इन डिटेल वीडियो है? क्योंकि अभी मतलब सर के ऊपर से गया है, सच्ची में कुछ समझ नहीं आया है, टू बी वेरी फ्रैंक।
मेरे को पता है कि मैंने जो भी विदाउट आपको कुछ ही एक्सप्लेन नहीं किया, बिना किया ओरली मैंने बता दिया, आपको नहीं समझ में आता, वही मैं बोल रहा हूँ। इसको स्टेप बाय स्टेप स्लोली जाएंगे तो समझ में आता है। एटलीस्ट विल बी टेक 1 hour टू अंडरस्टैंड टोटल काम क्या चल रहा है।
ओके, सो आपका कोई वीडियो है यूट्यूब पे या फिर आपका कोई चैनल है?
Yeah, already I given the link in our group, so you can.
Okay.
So actually, if you don't mind, मैं गरिमा मैम, thank you so much. आप कितना सिंपल सी कॉन्सेप्ट को बता दिया है कि अपन को मैक्सिमम 4 डिजिट तक ही यूज होता है, 4 डिजिट तक आप सिंपल वे में बता दिया है, लेकिन उसको मैं और एक थोड़ा पॉइंट ऐड करता हूँ मेरे कॉन्सेप्ट के लिए, क्योंकि मेरे को उस टाइम पे टाइम नहीं मिला है। या राइट, सपोज 98 into 76 if I am taking, okay, if I convert this number into vinuculam number, then it is 1 2 bar, then this number you can write in different ways. You can take a nearest to 100, or you can write this 76. You can write 100 minus 24. That also, or you can write it this number 80 minus 4 also. It depends upon you how you are selecting. Suppose let me take this one, because just how to do 3-digit into 3-digit multiplication. Observe very carefully. First 1 into 1 I multiplied here. Okay, we have 5 places जो भी मैडम बोला है ऐसा, और 4 1 into 1 करने के बाद -2 into -4 मेरे को 8 आ गया. सेकेंड स्टेप में 4 डिजिट को कॉम्बिनेशन लेने के लिए मैडम बोला था, ये -2 था, ये 0 था, इसका मतलब -2 था. और राइट में से भी 2 डिजिट को लेने के लिए बोला था, ये +4 था, ये 0 था. सो केवल आई गॉट +4. और उसके बाद मैडम ने बोला है कि 3 डिजिट मतलब 6 डिजिट कॉम्बिनेशन लेने का. तो here -4 and this will be -2. The middle number will be 0. Then I got 6 bar. So 8, 4. Convert this number into normal number. First number from 10, next number from 9. So negative number, so subtract 1 from the last number, 0. So this is my answer. So now see, if you multiply 90 into 76, we are getting larger number, like 48 here, next will be 56 and 54, that is totally 100, I think. Okay, see, next one 60. How larger numbers we are getting. Here it will be difficult to addition. Compare with it, like this single digit.
वहाँ पर 10 होगा, 100 नहीं, वहाँ पर मिडिल में 110 होंगे.
110, yeah, 110, yeah, it is 110, not 100. Yeah. So देखिए मेरे को इधर कितना कितना बड़े नंबर आया था, इधर आप देख सकते हैं सिर्फ I got single digit. That is the benefit of the vinuculam. Are getting my point? So my suggestion is जो बच्चे को नेगेटिव नंबर के बारे में मतलब पूरा बताना है, वो कैसा वर्क करता है, क्या करता है. उसके बाद विनुकुलम सिखाओ, और विनुकुलम सिखाने के पहले नेगेटिव डिजिट को एडिशन सबट्रैक्शन कैसा करते हैं उसके बारे में क्लैरिटी देना है. ये सब देने के बाद विनुकुलम टीच करेंगे तो फायदा होगा. बिफोर डायरेक्टली आप जाके विनुकुलम ट्राई किया तो it is very difficult to children understand, because they don't know, some students they don't know what is the product of this one, what is the sum of this one, pata nahi tha, because they don't know clarity on it. How to know the number of digits in your answer? By just seeing the multiplication. That is a very good question. I will tell you what is the reason behind it. Suppose if you are taking 24 and 86, let us assume, very careful. This is a 2-digit number, means it is a unit and it is a 10. Here also it is a unit and it is a 10. Simply multiply highest to place digit 10 into 10. That means 100. So 3 digit we are getting. Simply. That is the mathematical reason. If you go with logical reason, Madam already told you, just you have to count the number of digits. Total 4. 1 less than of 4 is 3. That means you will get 3 digits. Same way you can see here, if I am taking like this, you go with the place values, ones, tens, 100, 1000. Here it will be ones and 10. So 10 into 1000 is 10,000. Okay. Yeah, so 10,000 means you will get 5 places. Okay. Otherwise, just you count the digit 1, 2, 3, 4, 5, 6. 6, Eka union is 5. So just you write 5 digits. Is it clear?
Yes, sir.
Yeah, thank you so much. Yeah, and और एक एडिशनल पॉइंट था, यू कैन अप्लाई जो भी गरिमा मैडम ने आपको बताया था वो टेक्निक, उस टेक्निक को आप अलजेब्रा में भी यूज कर सकते. ठीक है, नॉट ओनली न्यूमेरिकल्स, अलजेब्रा को भी यूज. थैंक यू.
So please take one example for algebra.
या गरिमा मैम आप लीजिए, आपका क्लास है ना, वो अच्छा है।
Algebra, I can't. I mean, in this multiple crosswise, you all, I want to learn from you.
Okay. So x, yeah, x plus 3 into x minus 2. It look like a 2-digit number. Yeah, x plus 3 and x minus 2. It is like a 2-digit number. Yes or no? So same step. आपने पहले audience को बोला है कि you have to multiply these two numbers. That is, then you are getting x square.
Yeah.
That there are 3 places as usual. After that, you said you have to multiply these two numbers.
3 to
Here.
the 6. Yeah.
Here you are getting minus 6.
6.
After
Yeah.
that, you said that you have to multiply this one. That is 2x. Next, this one. That is 3x. So that sum is only plus. Right place. Your answer is x square plus x minus 6. So this is same thing.
Yes.
As it is. Algebra be covered.
Yes, sir. Understood. Thank you, sir.
Yeah, suppose x square plus 3x plus 2. If you are multiplying x plus 1, in the same way you can put the 0 also, no problem. Okay. 1, 2, 3, 1, 2, 3. First will be 0. The last is 2. That is plus 2. Your second step is you have to multiply this into this. That is only x cube. Here it will be 3x. This will be, sorry, 3x, 2x. That is plus 5. For that, we have to find the middle step. That is x square 0. So only x square. Plus
3x square.
Totally 4x square.
4x square.
Your answer is x cube plus 4x square.
Plus 5x. That's true. Yes, sir.
Same. Why? Because here also we are focusing on place.
Yes, yes. Thank you.
Please explain it once again, sir.
क्या जी? Yeah,
like the second step, how you are getting x cube?
Second step, madam said select 4 digits.
Okay.
And madam, and you have to do cross multiplication. Square into x is x cube. And 0 into 3x.
Okay.
0. After that, we have to add them. So we are getting only x cube. X cube plus 0.
Okay.
Thank you so much. Next, we have class on linear equation, simple equation, I think so. Roshini madam लेने वाली है.
Okay, sir. I want to leave. Shall I leave now, sir? Okay, thank you so much. Thank you everyone for participating. Thank you, sir, for organizing this platform. Thank you so much.
Karima ma'am too.
You're welcome, Rashni ma'am.
हम पहले मिल चुके एक बार.
Online, right?
Right.
हाँ, आपको कुछ सीखना था शायद आपको.
हाँ.
हाँ, thank you so much, ma'am. Okay, everyone. Bye-bye. We'll meet you again. Sir, ऐसा platform आप मतलब छुट्टी है तो I can easily manage. But I am also working with the school और evening में classes रहते तो it's difficult every time to manage.
Yeah.
Okay. Thank you so much.
Yeah. Actually, अपन को ब्रेक नहीं है, कंटिन्यूसली है कि रिसर्च पर्संस उसको अलर्ट किया है उस टाइम पे आके. ये मैं आपको YouTube में भी प्रोवाइड किया है कि सपोज अब लंच ब्रेक है तो आप ज्वाइन हो सकते हैं, कुछ लोग लीव कर सकते हैं. सो जो भी लीव कर रहा है सुबह से क्लास में जुड़े हैं उसके लिए जो भी आपका लंच के बाद फिर वापस देखने के लिए लाइव रिकॉर्डिंग चल रहा है, वापस जाके देखे फिर आके ज्वाइन हो सकते हैं। नया लोगों को ये कंटिन्यू चलते रहे। थैंक यू।
So you are from which state of India?
मैं तेलंगाना।
Telangana. Okay, I'm from Hyderabad.
Me too. Yeah, Roshni. Yeah, you can.
Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon, ma'am.
My name is Roshni Agarwal, and today I am telling you about equations. ठीक है? हम इक्वेशन कैसे फाइंड आउट करते हैं, इक्वेशन क्या चीज होती है, लीनियर इक्वेशन क्या है, इजीली सीखेंगे। ओके, आपको व्हाइट बोर्ड दिखाई दे रहा है?
जी मैम।
ओके, तो हम छोटा सा इंट्रोडक्शन पार्ट ले लेते हैं। व्हाट इज द इक्वेशन और व्हाट इज एन इक्वेशन। तो इक्वेशन शोस इक्वेलिटी, ये बात आपको ध्यान देनी है। इक्वेशन शोस इक्वेलिटी। अगर मैंने यहाँ पर लिख दिया 2x + 3, इसमें भी आप देखेंगे इक्वेशन में वेरिएबल पार्ट होता है एंड कांस्टेंट पार्ट होता है। वेरिएबल पार्ट में हमेशा, ठीक है, जहां पर भी अल्फाबेट टर्म होगी हम उसको क्या बोलेंगे, इट इज वेरिएबल। और यहाँ पर जो इंडिपेंडेंट टर्म है उसको हम बोलेंगे कांस्टेंट। गॉट इट?
जी मैम।
एंड इट इज वेरिएबल। अब ये बात ध्यान में रखना है कि अब मैंने यहाँ पर लिख दिया 2x + 3, इट इज नॉट एन इक्वेशन। क्यों इक्वेशन नहीं हो? इसको हम क्या बोलेंगे, एक्सप्रेशन। जब तक आप इक्वालिटी शोस नहीं करते इसके आगे एज अ 0 लिख लो, या उसके आगे और भी कुछ टर्म हो सकता है, जरूरी नहीं है यहाँ पर 0, बट यहाँ पर आपका डिवाइडेशन पार्ट होना चाहिए, LHS इज इक्वल टू RHS। ठीक है, लेफ्ट हैंड साइड एंड इट इज इक्वल टू राइट हैंड साइड। जब हम क्या बोलेंगे उसको, इट इज एन इक्वेशन। ठीक है, सो हम पहले देखते हैं सिंपल इक्वेशन हम किसको बोलेंगे। इट इज अ जनरल टाइप ऑफ इक्वेशन जहां पर हम सिर्फ डील करते सिंगल
बेटे।
व्हाट?
सॉरी मैं अपनी बेटी को बुला रही थी।
वी आर डीलिंग विथ सिंगल वेरिएबल। हियर वी आर डीलिंग विथ सिंगल वेरिएबल, उसको हम बोलेंगे सिंपल इक्वेशन। जैसे यहाँ पर मैंने एग्जांपल ले लिया 2x + 8। अब यहाँ पर मैंने बताया इक्वेशन शोस इक्वेलिटी। इक्वेलिटी में हमने ले लिया x + 10। यहाँ पर आप देख रहे होंगे सिंगल वेरिएबल है, यहाँ पर वेरिएबल x है, यहाँ पर भी वेरिएबल x है। ठीक है, लीनियर इक्वेशन में क्या होता है, सिंगल वेरिएबल भी हो सकता है, यहाँ हम लिख सकते हैं x + y = 0 है, x भी वेरिएबल है एंड y भी वेरिएबल है। जब 2 वेरिएबल होते हैं हम उसको बोलते हैं लीनियर इक्वेशन बाय 2 वेरिएबल। ठीक है, तो यहाँ पर हम डील करते हैं, इस इक्वेशन को सॉल्व करते हैं। यहाँ पर आप देखेंगे तो अगर हम जनरल मेथड में सॉल्व करें इसको, तो आपको पता होना चाहिए कि कौन से साइड, लेफ्ट हैंड साइड में क्या होता है और राइट हैंड साइड में क्या होता है। तो लेफ्ट हैंड साइड में क्या होता है, वेरिएबल। ये बात हमेशा आप ध्यान में रखिए, वेरिएबल इज ऑन लेफ्ट हैंड साइड एंड राइट हैंड साइड होता है कांस्टेंट। इसीलिए हम यहाँ पर सूत्र आपको फॉर्मूले दिए होते हैं छोटे छोटे, तो यहाँ पर आपको फॉर्मूला दिया गया है a - c इज इक्वल टू d - b। यहाँ पर आपको बताया a b c d, लेकिन यहाँ पर क्यों बताया, क्योंकि हम वेरिएबल को फाइंड आउट करेंगे तो वेरिएबल जो है वो लेफ्ट हैंड साइड आ जाते हैं। तो वेरिएबल आप देखो यहाँ पर 2x, राइट, a is equal to 2x, d equals to 8, c equals to x and d equals to 10। a हमने लिया है 2x, 2x वेरिएबल है, इट इज ऑन राइट हैंड साइड, इसीलिए हम लेते हैं 2x एज इट इज। -c है यहाँ पर, -c क्यों दिया है, क्योंकि ये राइट हैंड साइड में वेरिएबल है। राइट हैंड साइड का वेरिएबल जब लेफ्ट हैंड साइड चले गया, हम उसको वापस ला रहे हैं, तो ये क्या हो गया, माइनस हो गया। इसीलिए हम यहाँ पर लेते हैं माइनस डी। डी इज अ कांस्टेंट, कांस्टेंट डी जो राइट हैंड साइड में बरोबर है, इट इज ऑन राइट प्लेस, इसीलिए हम डी एज इट इज लेते हैं। एंड माइनस बी फ्रॉम वी आर टेकिंग फ्रॉम इट इज लेफ्ट हैंड साइड, दैट्स व्हाई वी आर टेक माइनस साइन हियर। So 2x minus x, आप देखोगे 2x minus x is equal to x and 10 minus 8, it is 2. So हम हमारा आंसर इजीली निकाल सकते हैं, राइट। हमें फॉर्मूला a माइनस सी डी माइनस बी इसको याद ना रखते हुए हम ये बात ध्यान में रखें कि लेफ्ट हैंड साइड में हमें वेरिएबल ट्रांसफर करना है और राइट साइड में हमें कांस्टेंट करना है, राइट। Any doubt in this problem? No doubt. Okay. मेरी आवाज आ रही है ना?
Yes,
Yeah. I'm clearing. जिम अभी तो हमने डील किया था, ठीक है, ये प्लस था। हम एक देखते हैं कि अगर नेगेटिव नंबर्स में होता तो हम कैसे डील करते हैं। सपोज आई हैव अ क्वेश्चन हियर, 7y डिवाइडेड बाय 5 इज इक्वल्स टू y माइनस 4। यहाँ पर भी सिंगल वेरिएबल है, सो इट इज सिंपल इक्वेशन। यहाँ पर सिंगल वेरिएबल y है, बट यहाँ पर क्या हो गया आपका, आप देखोगे तो ये फ्रैक्शन में आ गया। सो somebody is confusing it कि हाँ हम सॉल्व कैसे करें, ये तो फ्रैक्शन में आ गया। तो बहुत सिंपल बात है कि अभी जैसे हमने बताया, पहले तो इसको सिंप्लीफाई कर लेते हैं। सिंप्लीफाई हम कैसे करेंगे, जस्ट वी हैव टू क्रॉस मल्टीप्लाई। सो 7y इज इक्वल टू 5y माइनस 20, राइट। अब आपने क्या सीखा कि वेरिएबल पार्ट है, वेरिएबल पार्ट को हम कहाँ लेते हैं, एज अ वेरिएबल पार्ट एज अ लेफ्ट हैंड साइड, राइट। एंड राइट हैंड साइड में होता है कांस्टेंट। वेरिएबल पार्ट जो है हमारा 7y एंड जो यहाँ पर चलेगा राइट हैंड साइड माइनस 5y इज इक्वल टू, यहाँ पर आप देखोगे तो जो ये कांस्टेंट पार्ट है वो राइट हैंड साइड में ही है, राइट। सो हम इसको एज अ माइनस 20 ही लेंगे। So 2y is equal to minus 20 and y equals to minus 20 by 2. So you get directly your answer. It is minus 10. Okay. ये था हमारा टाइप 1 इन अ जनरल इक्वेशन। थोड़ा सा आगे बढ़ते हैं, नेक्स्ट लेवल का क्वेश्चन देखते हैं, टाइप 2। So let's see type 2. If the equations are like x plus a, x plus b is equals to x plus c multiplied by x plus d. Okay. अगर हमारे इक्वेशन जो टर्म है वो पैटर्न ऐसा होता तो x इक्वल्स टू व्हाट, यहाँ पर हम क्वेश्चन ले लेते हैं। यहाँ पर मैंने क्वेश्चन लिया x plus 1, x plus 3 is equals to x minus 3 and x minus 5, ठीक है। तो व्हाट इज द आंसर, तो छोटा सा फॉर्मूला यहाँ पर हम डिटेक्ट कर लेते हैं, क्योंकि अगर हम इसको पूरा सॉल्व करेंगे, ठीक है, इस इक्वेशन को अगर हम सॉल्व करते हैं तो लास्ट में क्या रह जाता है, इस इक्वेशन को अगर हम सॉल्व करेंगे तो आपके पास बचेगा x इक्वल्स टू सी डी माइनस ए बी डिवाइडेड बाय a प्लस बी इज माइनस सी इक्वल्स टू एंड माइनस डी, ठीक है। जब आप इस इक्वेशन को सॉल्व करोगे तो आपके पास ये फॉर्मूला आएगा। इसी फॉर्मूले के थ्रू हम इसको एज ए नंबर देकर आप कैलकुलेट कर सकते हो, ए बी सी डी। सो व्हाट इज सी डी हियर, these two number, we have to multiply. -3 into -5, you get 15 plus 15 minus a into b. यहाँ पर a है 1 and b है 3. 1 3 जा 3. A plus b. Now we have to plus it. 1 plus 3, you get 4 minus c. अब माइनस का साइन है यहाँ पर और यहाँ पर भी हमारा क्या है -3 है. तो माइनस इंटू माइनस क्या होगा प्लस. यहाँ पर भी माइनस साइन है, यहाँ पर भी -5 है. तो माइनस इंटू माइनस प्लस. गॉट इट दिस पॉइंट. तो यहाँ पर आपको साइन के तरफ ज्यादा ध्यान देना पड़ता है. आप साइन को जब भी साइन आती है माइनस प्लस, आप थोड़ा सा ध्यान देकर उसको कीजिएगा. ठीक है. तो जब आप कैलकुलेट करोगे यहाँ पर 12, 4 plus 3 7, 7 plus 5 it is also 12 and here you get x equals to 1. Right? So ये क्या था? It is also simple equation. It is type 2. When the collectivity is same, that collectivity is 0, we can say it. Got it? थोड़ा सा और आगे बढ़ जाता है. हम लेते हैं टाइप 3, टाइप 3rd टाइप क्वेश्चन. When the patterns are ax plus b divided by cx plus d is equals to pq term. ठीक है. ये था हमारा पैटर्न क्वेश्चन. उसको अगर हम सॉल्व करेंगे so you get x equals to dp minus bq. dp minus bq. जब हम क्रॉस मल्टीप्लाई करके इसको सॉल्व करेंगे तो हमें क्या आंसर मिलेगा? लास्ट फाइनल आंसर dp minus bq aq minus cp. तो ये आपका टाइप 3. It is a pattern and it is a solution part. Solution हम एक क्वेश्चन ले लेते हैं. Example, when given question is 2x plus 1 3x minus 2 is equals to 9 by 10. ठीक है. So यहाँ पर क्या है? ये a, ये x, it is a b, it is a c, x, d और ये है आपका p और ये है आपका q. राइट. एज हमने यहाँ पर ये नंबर्स दे दिए उनको लाइक दिस पैटर्न. ये हमारे पैटर्न में सब्स्टिट्यूट हो गया. अब हम इसको सॉल्व करेंगे. x इक्वल्स टू dp. तो हमें क्या करना है? जो कांस्टेंट टर्म है हम फर्स्ट उसी को मल्टीप्लाई कर रहे हैं. राइट. क्योंकि इसमें भी क्या हो जाता है, जब आप x वेरिएबल और कांस्टेंट इक्वल्स टू कर रहे थे, यहाँ पर अगर हम डिवाइड में लेंगे तो डिवाइड में क्या हो जाता है? न्यूमरेटर पार्ट में आपका कॉन्सोनेंट हो जाता है एंड नीचे वेरिएबल डिनोमिनेटर में. ये बात ध्यान में रखेंगे और साथ में इसको सॉल्व कर लेते हैं. सो यू गेट हियर व्हेन यू क्रॉस मल्टीप्लाई dp minus bq, you get here minus 18. 9 into 2 and bq कर लेंगे क्रॉस मल्टीप्लाई. सो यू गेट प्लस 10. अब यहाँ पर है नीचे aq. वेरिएबल टर्म को हमें मल्टीप्लाई करना है. अभी हमने क्या किया? कांस्टेंट टर्म, इंडिपेंडेंट टर्म को हमने मल्टीप्लाई किया. अब वेरिएबल को हम मल्टीप्लाई कर रहे हैं. सेम क्रॉस मल्टीप्लाई कर रहे हैं. सो 2 into 10, 2 into 10 it is 20 minus 3 into 9 it is minus 27. समझ में आया? तो 18 माइनस साइन है, 10 बड़ा है, you get minus and here minus 7. गॉट इट?
मैम फिर से थोड़ा सा अगर आप एक्सप्लेन कर सकते हैं, मैंने नीचे x कहाँ चला गया, a क्यूब में जो मल्टीप्लिकेशन है,
यहाँ पर
a तो मतलब 2x है ना, तो फिर सिर्फ आंसर 20 क्यों आ रहा है?
हमने यहाँ पर a क्यों लिया है ना, a क्या है आपका, a क्या है, ये x टर्म लिया है क्या हमने यहाँ? मैंने लिखा a x।
हेलो,
हाँ आपको आवाज आ रही है?
जी जी जी।
हमने यहाँ पर लिखा है a, यहाँ पर लिखा है x, यहाँ पर लिखा है मैंने, राइट? हम ax इंटू क्यू कर रहे हैं क्या a क्यू कर रहे हैं?
हाँ, अच्छा ठीक है, हाँ
समझ में आया?
जी जी, अब समझ आया।
तो यहाँ पर भी आप जो वेरिएबल पार्ट है या ABCD जो हमारी अल्फाबेट है उसको थोड़ा सा, क्योंकि हम यहाँ पर सॉल्व क्या कर रहे हैं, वैल्यू जो फाइंड कर रहे हैं वो x की तो वैल्यू फाइंड कर रहे हैं ना।
जी जी जी,
Got it?
हाँ जी समझ आ गया।
तो हमने अभी क्या किया, फॉर्मूले बनाकर उसमें सब्स्टिट्यूट कर कर आंसर निकाले, राइट? हमारे इक्वेशंस थे, उसको हमने कुछ फॉर्मूले दिए, कुछ पैटर्न दिए, उसमें सब्स्टिट्यूट किया और फिर आंसर निकाले हमने, राइट? लेकिन हम देखेंगे एक जो सूत्र है इसमें वैदिक मैथ्स में, इट इज शून्यम सामुच्चय सूत्र, ठीक है? इसका मतलब क्या है, जब आप इक्वेशन देखते हो, राइट, इक्वेशन देखते ही आपको ये तुरंत समझ में आ जाएगा कि व्हाट इज द वैल्यू ऑफ एक्स। शून्य में it is already decided value, it is 0. Okay, so how we can find out easily? So I'm seeking it by using the shunyam samuchya sutra. What is the sutra name? Shunyam. Shunyam means 0. That is the main important sutra here. Samuchya sutra. तो यहाँ पर अगर मैंने बोला टाइप 1 दे देते हैं हम इसको, व्हेन योर एक्स इज, जो भी आपका वेरिएबल है उसमें क्या होगा, एक्स इज अ कॉमन फैक्टर। अगर उसमें अगर आपको दिखाई दे रहा है कि ये कॉमन फैक्टर है, इसमें दोनों साइड में एक्स वेरिएबल पार्ट जो है वो सेम है, तो आपका एक्स क्या होगा, इट इज 0। एग्जाम्पल लेते हैं यहाँ पर, अगर मैंने दे दिया यहाँ पर 8 इज इक्वल टू 8 प्लस 1 इज इक्वल टू 9 x प्लस 1, ठीक है, ये क्वेश्चन है। तो यहाँ पर मेरी वैल्यू डिसाइडेड है। व्हाट इज डिसाइडेड वैल्यू, x1 प्लस x प्लस 1 इट इज इक्वल टू 0। सो लेट्स सी हाउ इट इज, ठीक है, ये x प्लस 1 हमारी 0 कैसे आ सकती है? तो यहाँ पर देख रहे होंगे जब हमारा ये वेरिएबल टर्म है, अगर मैं इसको x प्लस 1 को y अज्यूम कर लूं और यहाँ पर भी मैं यहाँ पर x प्लस 1 को y अज्यूम कर लूं, तो यहाँ पर क्या बता रही है, इक्वेलिटी हमें क्या शो कर रही है कि दोनों साइड की वैल्यू क्या है, सेम है। अगर हम 8 इंटू वाई करें, इट इज इक्वल टू 9 इंटू वाई, और ये दोनों कब पॉसिबल है, ये कंडीशन कब पॉसिबल है, जब आपका ये y टर्म है वो 0 हो, जब आपका ये y है वो इक्वल टू 0, तभी ये इक्वेलिटी पॉसिबल है, राइट? समझ में आया? यस,
यस 0 है तो ही आएगा या।
So that's why we can say x plus 1 it is equals to 0। और यहाँ पर फिर हम x की वैल्यू फाइंड आउट करेंगे, तो ये मत सोचो कि x की वैल्यू 0 आई है, हम x की वैल्यू 0 नहीं ले रहे हैं, हम क्या ले रहे हैं, x plus 1 equals to 0। तो x की वैल्यू आएगी -1, जब यहाँ पर 0 के ये 1 जो है आउट ऑफ जाएगा, उधर जाएगा राइट हैंड साइड। So we take x equals to, therefore x equals to -1। So यहाँ पर हम डायरेक्टली विदाउट यूजिंग एनी सूत्र, विदाउट कैलकुलेशन, हम डायरेक्टली कुछ कंडीशन ऐसे होते हैं वहां पर हम बता सकते कि व्हाट इज द जीरोस वैल्यू, ठीक है? ये समझ में आया? इट इज द फर्स्ट कंडीशन। ऐसी कुछ कंडीशन हम देखेंगे। सो लेट्स सी सेकंड कंडीशन। if independent terms are the same on both sides. ठीक है, जब हमारे इंडिपेंडेंट टर्म, अब मैंने आपको इंडिपेंडेंट टर्म को क्या बोलते बताया कि कांस्टेंट, जो भी कांस्टेंट वैल्यू है उसको हम क्या बोलते हैं, इंडिपेंडेंट टर्म। ठीक है, तो अगर ये दोनों साइड, लेफ्ट हैंड साइड एंड राइट हैंड साइड, दोनों साइड सेम आ रही है, तो हम क्या कर सकते हैं, इसको इजीली बोल सकते हैं कि x इक्वल्स टू 0। अब यहाँ पर हम डायरेक्टली शो कर सकते हैं कि हमारे जो भी वेरिएबल वैल्यू है उसकी वैल्यू क्या आएगी, x इक्वल्स टू 0। एग्जाम्पल, x प्लस 4, x प्लस 3 is equals to x plus 6, x plus 2। ठीक है, ये क्वेश्चन है। अभी हमने देखा था इस टाइप के क्वेश्चन को हम कैसे सॉल्व कर सकते हैं। इसका फॉर्मूला आएगा सी डी माइनस ए बी ए प्लस बी एंड माइनस सी माइनस डी, राइट। तो ये इसका फॉर्मूला था, माइनस सी माइनस डी। अब हम इसको देखेंगे कि विदाउट यूजिंग दिस फॉर्मूला, by seeing we can say this question, the answer is x equals to 0। तो x equals to 0 आएगा कैसे, हमने अभी देखा कि कंडीशन क्या होनी चाहिए, when the both independent terms are same। यहाँ पर आप इंडिपेंडेंट टर्म्स देखो, आपका कांस्टेंट है यहाँ पर 4 3, so 4 3s are, you get 4 3s are 12, right। यहाँ पर देखेंगे 6 into 2, if you multiply 6 to the 12, दोनों साइड क्या है, लेफ्ट हैंड साइड एंड राइट हैंड साइड, आपके जो भी कांस्टेंट पावर है, कांस्टेंट वैल्यूज है, वो क्या है, इक्वल है, राइट। तो जब भी आपके इंडिपेंडेंट टर्म्स इक्वल्स होते हैं तो वी कैन से x इक्वल्स टू 0। आप इसको कैलकुलेट करके देख लो, फॉर्मूले में सब्स्टिट्यूट करके देख लो इस क्वेश्चन को, आपकी x की वैल्यूज क्या आएगी, 0। ठीक है, गॉट इट। जब हम टू लीनियर इक्वेशन को एक साथ डील करते हैं तो हम उसको क्या बोलेंगे, कौन सा इक्वेशन बोलेंगे, जब हम टू वेरिएबल के लीनियर इक्वेशन को एक साथ डील करेंगे।
And simultaneous equations?
Yes, it is simultaneous equation. So एक दो प्रॉब्लम हम simultaneous equation के भी ले लेते हैं। Simultaneous equation के पहले ओके, आई थिंक यहाँ पर एक और कंडीशन है, तो हम एक और कंडीशन ले लेते हैं यहाँ पर फर्स्ट, व्हेन शून्यम सामुच्चय सूत्र। ठीक है, इफ द न्यूमरेटर्स आर सेम। ठीक है, अगर आपके कभी वैल्यूज आ गए, सपोज यहाँ पर मैंने ले लिया 6 2x plus 1 plus 6 3x plus 4 is equals to 0, like this। अगर क्वेश्चन आ गया तो यहाँ पर क्या हो रही है, आपकी जो न्यूमरेटर वैल्यूज है वो क्या है, दोनों साइड्स, यहाँ पर दोनों न्यूमरेटर वैल्यू क्या है, व्हाट इज द वैल्यू ऑफ न्यूमरेटर हियर, दोनों साइड क्या है, यहाँ पर दोनों 6 है, तो इट इज सेम। तो यहाँ पर क्या होगा, जब आपकी न्यूमरेटर वैल्यू सेम होती है तो आपका जो डिनोमिनेटर वैल्यू है उसको भी ऐड करोगे ना, तो उसकी एडिशन यू गेट 0। डिनोमिनेटर इज द सम ऑफ डिनोमिनेटर इज 0। इसका मतलब 2x plus 1 plus 3x plus 4, जब न्यूमरेटर सेम है तो डिनोमिनेटर की एडिशन जो होगी वो इक्वल्स टू 0 होगी। ठीक है, तो 7x plus 5 is equals to 0। आपको न्यूमरेटर पार्ट को कैलकुलेट करना, क्रॉस मल्टीप्लाई करना, यहाँ पर विदाउट क्रॉस मल्टीप्लाई करे, विदाउट कैलकुलेशन आप डायरेक्टली यहाँ से सॉल्व कर सकते हो और x की वैल्यू निकाल सकते हो। कब निकाल सकते हो, जब आपका न्यूमरेटर पार्ट सेम हो। ठीक है, इट इज अ थर्ड कंडीशन। समझ में आया। एंड जब डिनोमिनेटर पार्ट भी सेम होगा ना, तभी आपका इक्वेशन पार्ट जो नीचे से सम की पार्ट होगी वो भी सेम होगी टोटल। ओके, समझ में आया? यहाँ तक का समझ में आया? सिंपल इक्वेशन में कोई डाउट है? शून्यम सामुच्चय सूत्र में कोई डाउट है?
नो मैम।
तो हम आगे बढ़ते हैं। आगे बढ़कर हम साइमल्टेनियस इक्वेशन के कुछ सम ले लेते हैं, ठीक है? सॉरी, आपको व्हाइट बोर्ड दिखाई दे रहा है क्या?
नो मैम।
जस्ट अ मिनट। ओके, सो लीनियर इक्वेशन बाय टू वेरिएबल ये होता क्या है, पहले तो हम ये देख लेते हैं और फिर उससे जुड़े हुए एक आध दो प्रॉब्लम कर लेते हैं। सपोज हम मैंने यहाँ पर लिखा x प्लस वाई इज इक्वल टू 8। तो यहाँ पर कितने वेरिएबल टर्म्स है? टू, x एंड y, राइट? सो हम इसको इस टाइप को क्या बोलेंगे? इट इज टू वेरिएबल बाय लीनियर इक्वेशन। लेकिन जब हम यहाँ पर एक से दो, ठीक है, एक से जो दो अगर हम लीनियर इक्वेशन साथ में डील कर रहे हैं, यहाँ पर मैंने लिख दिया x माइनस वाई इज इक्वल टू 4। अब मुझे यहाँ पर दोनों की वैल्यूज को फाइंड करना है और यहाँ पर मुझे दोनों इक्वेशन को ये साथ में सॉल्व करना है। तो हम इस टाइप को बोलेंगे इट इज साइमल्टेनियस इक्वेशन, ठीक है? तो हम इससे जुड़े हुए भी एक हाथ दो प्रॉब्लम ले लेते हैं। ठीक है, दिस इज द इक्वेशन। और अब हमें क्या निकालना है? वी हैव टू फाइंड आउट वैल्यू ऑफ x एंड वैल्यू ऑफ y, ठीक है? यहाँ पर आप देखोगे इसके लिए छोटा सा फॉर्मूला है। क्या फॉर्मूला है? x इक्वल्स टू न्यूमरेटर डिवाइडेड बाय डिनोमिनेटर। लेकिन आपको ये पता होना चाहिए कि न्यूमरेटर में आपको क्या लेना है, ऊपर क्या लेना है एंड नीचे क्या लेना है, वैल्यूज। तो यहाँ पर आप देखेंगे कि आप डील जब करोगे इस वैल्यू को, तो हम मिड टर्म से डील करेंगे, ठीक है? हम क्या करेंगे? इसको मिड टर्म से डील करेंगे। तो हम यहाँ पर लेते हैं और फिर क्रॉस मल्टीप्लाई करेंगे, मतलब एक एक वेरिएबल को हम सिंगल एक बार एक वेरिएबल को मल्टीप्लाई करेंगे, क्रॉस मल्टीप्लाई, ठीक है? तो हम y टर्म्स को लेंगे ऊपर एंड x टर्म को भी हम क्रॉस मल्टीप्लाई करेंगे। लेकिन जब हम x को क्रॉस मल्टीप्लाई करेंगे तो उसको हम लेंगे नीचे साइड, ठीक है? सो y टर्म को हमने एक बार ऊपर ले लिया क्रॉस मल्टीप्लाई में। सो हम देखेंगे फर्स्ट वी हैव टू मल्टीप्लाई दिस टू नंबर। 3 14 जा 42 माइनस 8 5 जा 40, ठीक है? तो ये आ गया हमारा न्यूमरेटर पार्ट। डिनोमिनेटर पार्ट में हमने क्या बोला कि हमें x वेरिएबल को भी मल्टीप्लाई करना है, लेकिन हम इसमें क्या करेंगे? इसको कांस्टेंट से मल्टीप्लाई नहीं करेंगे। दिस इज द कांस्टेंट वैल्यू ना, हम यहाँ पर कांस्टेंट वैल्यू से मल्टीप्लाई नहीं करेंगे। तो हम किससे करेंगे? हम डायरेक्टली क्रॉस मल्टीप्लाई करेंगे ऐसे, ठीक है? और कभी भी हम मिड टर्म से स्टार्ट कर रहे हैं, ये बात हमें ध्यान में रखनी है। सो 3 4 जा 12 and 2 5 are 10, right? So this is the numerator by denominator part। और यहाँ पर कभी भी साइन हमारी जो होगी वो माइनस की होगी। तो 42 माइनस दिस, राइट? 40 आएगा ना, 8 5 are, okay। So 42 minus 40 you get 2 and 12 minus 10 you get 2। So x की वैल्यू क्या आ गई है यहाँ पर? 1। x की वैल्यू क्या आ गई है? 1। और जब हम किसी भी इक्वेशन में हम x की वैल्यू 1 पुट करेंगे तो हमारा आंसर बरोबर आ जाएगा, y की वैल्यू निकल जाएगी। तो पुट कर लेते हैं। फर्स्ट इक्वेशन में मैंने पुट किया है, ये फर्स्ट इक्वेशन है आपकी। तो फर्स्ट इक्वेशन में हमने x की वैल्यू लगा दी है यहाँ पर 1 प्लस 3y इज इक्वल टू 8 अगर हम लेते हैं तो क्या होगा? 2 प्लस 3y is equals to 8 and 3y is equals to 8 minus 2, y equals to 6 by 3। सो y इक्वल्स टू y की वैल्यू क्या है आपकी 3। इसी को हम बोलते हैं साइमल्टेनियस इक्वेशन। समझ में आया?
Please explain it again, ma'am. Please.
Which one?
The another example.
Okay. बहुत छोटा सा एग्जांपल ले लेते हैं, so you can understand easily. अब यहाँ पर मैंने लिया x plus y is equals to 6, ठीक है, और यहाँ पर लिया x minus y is equals to 4, ठीक है। आपको स्कूल मेथड पता ही होगी। हम स्कूल मेथड में क्या करते हैं, हम तो डायरेक्टली यहाँ पर फर्स्ट क्या डील करते हैं, यहाँ पर तो डायरेक्ट है, ठीक है, प्लस वाई भी है माइनस वाई भी है, तो ये इजीली कट जाएगा और x की वैल्यू आपको निकल जाएगी, राइट, क्योंकि 2x यू कैन राइट हियर 2x, y कट हो जाएगा 2x एंड 6 plus 4 यू गेट 10, x की वैल्यू आ जाएगी 10 डिवाइडेड बाय 2 इट इज 5, ठीक है। और जब आप y की वैल्यू x की वैल्यू कोई भी एक इक्वेशन में पुट करोगे तो आपको y की वैल्यू निकल जाएगी। लेकिन हमारा यहाँ पर जो फॉर्मूला है, जब बड़े नंबर होते हैं तो हमें इतना प्लस माइनस ना करना पड़े, उसके लिए हमारे पास एक छोटा सा फॉर्मूला है, न्यूमरेटर डिवाइडेड बाय डिनोमिनेटर। सो ऑलवेज वी हैव टू स्टार्ट बाय मिडिल वैल्यू। ये आपकी मिडिल वैल्यू है, इट इज फॉर x टर्म ओनली। हम क्या करेंगे, क्रॉस मल्टीप्लाई करेंगे, ठीक है। सो क्रॉस मल्टीप्लाई करेंगे, सो y मीन्स यहाँ पर वैल्यू कितनी है 1, y मीन्स यहाँ पर वैल्यू कितनी है 1, सो मल्टीप्लाई इट यू गेट 4 into 1 4, right, and 6 into 1, यहाँ पर आप देखेंगे तो माइनस साइन है, लेकिन हमने अब देखा कि हमें पहले भी माइनस लगाना है, तो माइनस इंटू माइनस इट बिकम प्लस। अब यहाँ पर हम x की वैल्यूज को भी मल्टीप्लाई करेंगे, क्रॉस मल्टीप्लाई करेंगे, लेकिन यहाँ पर हम x की वैल्यू को कांस्टेंट वैल्यू से मल्टीप्लाई नहीं करेंगे, क्योंकि हमने क्या बोला था कि हम इसमें जब साइमल्टेनियस इक्वेशन स्टार्ट करते हैं तो हम मिड टर्म से स्टार्ट करते हैं, ठीक है। जब हम मिड टर्म से सॉल्व करेंगे तो हम फर्स्ट मल्टीप्लाई लाइक दिस करेंगे, सो 1 into 1 यू गेट 1, और x into y यहाँ पर भी 1 into 1 ही है, तो हम डायरेक्टली इस यहाँ पर भी लिख सकते हैं प्लस, क्योंकि यहाँ माइनस है, माइनस इंटू माइनस हो जाएगा आपका प्लस, सो यू गेट 1, सो 10 डिवाइडेड बाय 2, राइट। क्या ये हमारी x की वैल्यू 5। हमने सिंपल ट्रेडिशनल मेथड से भी इसको सॉल्व किया था, अभी हमने इस इक्वेशन से भी सॉल्व किया है वैदिक मेथड से, ठीक है। सो भी हमारी x की वैल्यू क्या है 5, गॉट इट?
Yes, ma'am.
इसमें भी एक कंडीशन इसमें भी है, जिसमें आप क्वेश्चन देखते ही समझ जाओगे कि x इक्वल्स टू 0। आई थिंक व्हेन द रेशियोज आर सेम ऑन द x टर्म, मुझे परफेक्टली तो नहीं पता, बट सर इट इज ना, व्हेन द रेशियोज आर सेम इन लीनियर इक्वेशन, सो वी गेट x इक्वल्स टू 0 डायरेक्टली।
हाँ, किसका प्रोपोर्शन सही होता है और बाकी 0 हो जाता है।
यस, सो एक एग्जाम्पल, इसी को हम एग्जाम्पल माने तो, एक मिनट, इन लीनियर इक्वेशन व्हेन द रेशियोज आर सेम, ठीक है। अब यहाँ पर मेरा क्वेश्चन है 6 divided by 2 it is 3 and 4 divided by 2 ओके, सो यहाँ पर आप देखोगे, यहाँ पर क्या हो रहा है, जब आप 6 डिवाइडेड बाय 3 करोगे एंड 4 डिवाइडेड बाय 2 करोगे, तो यहाँ पर जो रेशियोस आ रही है वो इक्वलिटी रेशियो क्या है, 1:2, राइट। जब आप डिवाइड करोगे एक्स टर्म को, डिवाइड करोगे तो कैसे आएगा, 6 डिवाइडेड बाय 3, सो यू गेट 2। प्लीज जिसके भी बैकग्राउंड से साउंड आ रहा है वो अपने आप को म्यूट कर ले। 4 डिवाइडेड बाय 2 करोगे तो यहाँ पर भी वैल्यू क्या आ रही है, 2। सो वी कैन से डायरेक्टली कि x की जो वैल्यू है वो कितनी है, 2, और जो नेक्स्ट टर्म है यहाँ पर नेक्स्ट वेरिएबल क्या है, y, सो y इक्वल्स टू क्या होगा, 0। सो यहाँ पर आपको कैलकुलेट करने की जरूरत ही नहीं पड़ेगी। ओके, एनी डाउट? नो, ओके सर, कंटिन्यू।
इतना जल्दी कंप्लीट कर दिया, वेरी गुड, बहुत अच्छा है। या मैंने देखा है कि पहले रोशनी को इस टाइम बहुत इम्प्रूवमेंट होके देख रहा हूँ, बहुत खुश लग रहा है।
यस सर। सर मैंने मतलब आपकी जो मल्टीप्लिकेशन मेथड है मैंने वही सिखाती हूँ मैं भी, जो उसी को फॉलो करते हैं क्या, क्योंकि कैसे बच्चों को पता होना चाहिए कि इंस्टेड ऑफ लर्निंग द पैटर्न दे हैव टू नो व्हाई द रूल्स आर केम।
यस यस, करेक्ट। अच्छा सीख रहे हैं क्या? बच्चों को समझ में आ रहा है क्या वो पैटर्न?
यस सर, मैं पैटर्न नहीं फॉलो कर रही हूँ ना, मैं डायरेक्ट बैलेंसिंग मेथड से ही मल्टीप्लिकेशन ले रही हूँ। सर आपने वो कंचन मैम का आंसर नहीं दिया था।
क्या मैम?
आई थिंक कि हाउ वी कैन इजीली टेक डिजिट, कि कितने डिजिट आएंगे। सो वी कैन मल्टीप्लाई द हायर डिजिट फ्रॉम फर्स्ट नंबर एंड सेकंड नंबर, सो वी गेट डायरेक्टली, कि हमें पता चल जाएगा कि कितने डिजिट में आंसर आने वाला है।
कितने डिजिट में आंसर आने वाला नहीं बोल सकते, लेकिन उसको भी थोड़ा ऑब्जर्वेशन विलोकनम को यूज करके हम कर सकते हैं, लेकिन
कर सकते
इतना
तो
steps-
अगर हम
इतना
हाईएस्ट डिग्री मल्टीप्लाई करेंगे तो हम बता सकते हैं ना कि हमें कितने स्टेप फॉलो करने हैं।
हाँ स्टेप्स आ जाए, लेकिन डिजिट नहीं, डिजिट क्योंकि अपन को लास्ट प्लेस में 2 डिजिट आएगा तो
यस, वो तो बैलेंसिंग पे डिपेंड्स होगा ना, बट वी हैव टू फाइंड दैट मच ऑफ स्टेप्स।
हाँ वो सही है, मल्टीप्लाई करेंगे तो अपन को आ जाएगा। लेकिन मैं एक स्मॉल सजेशन देना चाहता हूँ आपको।
यस
मतलब आपने जो भी दिया है बहुत अच्छा दिया है, उसमें मेरे को कोई प्रॉब्लम नहीं था, लेकिन स्मॉल स्मॉल सजेशन मैंने ऑब्जर्व किया था आपका क्लास में, ऑब्जर्व किया था।
बोलिए सर, सो वी गेट इम्प्रूवमेंट।
नहीं वो सही था, उसमें कुछ नहीं। सपोज ये मान लो ax plus ay is equal to z मान लो, जो भी simultaneous equation, so you are selecting middle term. Okay, so instead of finding x, try to find minus x. अभी माइनस एक्स करेंगे तो क्या होता है कि आप दोनों को मल्टीप्लाई कर लेना डिनोमिनेटर के लिए। हाँ, माइनस एक्स लेने के बाद फिर आप इसको भी इसी डायरेक्शन में ले सकते हैं, स्मॉल चेंज, एक ही डायरेक्शन जाए तो इजी और बता रहा हूँ। मतलब क्या है कि 2x plus 3y is equal to 6 था और 3x plus 4y is equal to some 2 था। In your procedure you are doing x is equal to m था, m ले रहा है, और you are doing first this one in this direction you are, so that is 6 minus 24, but the denominator you are doing in this direction.
Yes.
So you can see the directions are oppositely we are going. So that is 9 minus 8, so that we are getting here minus 18 upon 1 that is minus 18. So if you take same question with a small change for getting the same pattern, that is the reason I am changing. Otherwise, there is a no new in this one also. मैं क्या बोल रहा हूँ कि minus x ले लो. Then you can go this direction again. 24 minus ये वाला.
Okay.
6 on. फिर भी same direction. जो भी आपने बताई वही मेथड के बारे में बात कर रहा हूँ, ज्यादा नहीं. जो भी आपने वो बताई वही बात इंक्लूड करिए. माइनस एक्स करने के लिए बोल रहा हूँ. माइनस अपॉन सॉरी ये 8 था इज इक्वल टू माइनस एक्स इज इक्वल टू माइनस 18/1 मतलब एक्स इज इक्वल टू फिर माइनस 18 आ जाता है. इसमें कोई चेंज नहीं. सिर्फ मैं क्या बोल रहा हूँ कि एक ही डायरेक्शन में जाने के लिए यहाँ से यहाँ इधर भी यहाँ से यहाँ ऐसा एक ही डायरेक्शन में जाने के लिए आप माइनस एक्स को फाइंड आउट करेंगे तो सेम डायरेक्शन ऑन मेरा पॉइंट बोल रहा हूँ. गुड फाइन बहुत अच्छा है. या कुछ डाउट है तो मैडम को पूछ सकते हैं क्योंकि उनको 2 o'clock क्लास शुरू होने वाली है नेक्स्ट बार. तो उनको और एक 15 मिनट्स बाकी है. आपको कोई डाउट है तो मैडम को पूछ.
Then I'll you.
मैम क्वाड्रेटिक इक्वेशन का है क्या वैदिक मैथमेटिक्स में कुछ?
क्वाड्रेटिक इक्वेशन का है लेकिन उसके जो रूल्स रेगुलेशन वो चेंज है. हम इतना इजीली क्वाड्रिकल इक्वेशन नहीं फाइंड आउट कर सकते लेकिन हमें फैक्टर्स पता होना चाहिए. कुछ रूल्स है उसके वो भी पता होना चाहिए जब हम क्वाड्रिकल इक्वेशन भी इजीली सॉल्व कर सकते हैं.
You don't mind ma'am, quadratic equation topic will be 3 to 4.
हाँ सर लेने वाले.
मैंने not by me.
हाँ
लेने
वाले सर. एक सर है वो लेने वाले.
Yeah.
आपको किसी को भी सिंपल इक्वेशन में कोई डाउट है या आपके पास कुछ सम है तो हम सॉल्व कर सकते हैं विद इन 5 मिनट्स. ओके सर.
Yeah. So much.
Bye everyone.
थैंक यू मैम.
Yeah.
थैंक यू ऑल.
आप और एक 10 मिनट्स ब्रेक लेके आ सकते हैं. एग्जैक्टली 2 o'clock रश्मि यादव मैडम ने डिविजन्स के बारे में डिस्कस करने वाले हैं. सो वी हैव 10 मिनट्स.
Can we start, sir? मेरी वॉइस आ रही है आपको सर?
हाँ मैडम
Yeah,
आ रहा है।
ओके, स्क्रीन विजिबल है?
या विजिबल है, 1-2-3 मिनट वेट कर लेंगे।
ओके ओके।
हाँ मैडम 1-2-3 मिनट वेट करेंगे।
ओके, नो इशू।
हाँ मेरे को आ रहा है। स्टार्ट कर सकते हैं।
ओके। डिवीजन आप सब लोगों को आता है थोड़ा बहुत या नहीं आता है? मतलब बेसिकली जो लोग क्लास अटेंड कर रहे हैं आज,
है सब लोगों को थोड़ा
थोड़ा बहुत
जानकारी होगा।
जानकारी है। ओके, तो फर्स्ट ऑफ ऑल इसका जो पहला मेथड जो हम पढ़ेंगे, बेस मेथड। बेस मेथड क्या होता है कि आपका बेस क्या होता है? बेस जो होते हैं आपके वो होते हैं 100, 10, 100, 1000, 10,000 इन अप टू अबव। तो जो फर्स्ट मेथड है हमारा, अगर हम उसको देखें, या तो हम उसको निखिलम मेथड कहें, निखिलम मेथड के स्पेस में अगर हम इसको ट्रांसपोज मेथड के नाम से पढ़ें तो ज्यादा बेटर है। ट्रांसपोज, ठीक है, ये आपका एप्लीकेबल है बेस अबव और लोअर, मतलब अबव और लोअर जो भी है आपका उस पे। ट्रांसपोज एंड अप्लाई मेथड, अगर मैं इस मेथड की बात करूं तो जो भी, ओके सर, मेरी वॉइस आ रही है आपको सर?
हाँ यस मैडम। हाँ मैडम, क्योंकि आउट ऑफ कंट्री पीपल आर वाचिंग, फॉर देम वी आर ट्राई टू कंटिन्यू दिस।
ट्रांसपोज एंड अप्लाई मेथड, ओके। ट्रांसपोज एंड अप्लाई मेथड में क्या है? below the base and above the base. If we want divide Wait. One, 3, 8, 2 divided by 95. Then what we find? 95 is below the base, above the base. It's below the base. What? 100 minus 95, what we get? 0.5 in negative. Bar denoted negative. Then what we do? First, next slide. 1382 divided by 95, and we get 0.5. After transpose, we get what? 0.5, because it's negative, and transpose, it's positive. Then divide it into 3 parts. It's our dividend part. It's remainder part. And it's divisor. तो divisor हम क्या लेंगे? Divisor it's 0.5. Deviation. What we get deviation? Negative 0.5. Or after transpose, we get deviation 0.5. Then divisor is 0.5. 0.5. क्यों? Because 100 में कितने zeros हैं आपके? 2 zeros. That means you take divisor 0.5. Not only 5. If you get only 5, then you get answer wrong. So divisor part having 2 digits. That's why remainder part having also 2 digits. 8 and 2. And divided में आपका 1, 3. Cross. अब आपको क्वेश्चन आ रहा है, तो क्वेश्चन में आप क्या करेंगे? 1 as it is in the question part. Okay. Then question 1, जो क्वेश्चन में हमें 1 मिला है, इसकी मल्टीप्लाई हमें किसमें करनी? डिविजर पार्ट के 0 and 5 में 1 by 1. तो जब 1 by 1 आप मल्टीप्लाई करते हैं, what you get? 1 into 0, 0. 1 into 5, 5. 3 plus 0, 3. And process again. 3 into 0, 0. 3 into 5, 15. That's his remainder. 8, 5, 13. And 15 and 2, 17. Now, here is 2 digits, then it's carry forward. 1, 4, 7. It's your remainder. It's your actual divisor. Remainder is greater than your actual divisor. So that's why subtract 95 one time. Remainder क्या है? 52. It's your actual remainder, and subtract one time, that means plus 1. So quotient you get 14 and remainder you get 52. आपका remainder actual divisor से बड़ा नहीं होना चाहिए. If yes, अगर ऐसा है, then subtract actual divisor with remainder and add in question part 1. Okay. Clear? Clear or not?
Ma'am,
Yes,
can you explain once again another example?
Okay. Once again with another example. 11034 divided by 889. Okay. So what is base here?
1000.
1000, तो आपको डेविएशन व्हाट 111 its bar. After transpose, what you get? 111. It's okay. यहाँ तक clear है?
Yes, ma'am.
Okay.
Yes, ma'am.
Then it's a dividend. It's divisor. And it's remainder. Okay. डिवीजन आपका जो आप ट्रांसपोज मिला क्या व्हाट 111 इन डिवीजर वी हैव 3 digits. That's why in remainder part we take 3 digits 0 3 4. Rest of it dividend part, right? For question one direct written in the dividend question part. Okay, यहाँ तक process complete, clear?
Yeah, ma'am.
Yeah. Then again now ये जो 1 हमें क्वेश्चन पार्ट में मिला है इसकी मल्टीप्लाई करनी है डिविजन पार्ट के 1 से बाय 1 आपको लिखना है 1 into 1 1 1 into 1 1 and 1 into 1 it's 1. Okay, then 1 plus 1 you get 2 and process again 2 into 1 2 2 into 1 2 2 into 1 2 add 1 1 2 2 2 4 then 4 4 4. यहाँ आपके डिजिट जो है अपने हैं तो आप रिमाइंडर पार्ट में जाएंगे और अब आपका रिमाइंडर आएगा व्हाट यू गेट 8 3 2 5 4 9 and 7. You get remainder 7 8 9. It's your question. Okay, in last question क्या था? That's it. आपने जो रिमाइंडर गेन किया था वो एक्चुअल डिविजर से बड़ा था. एक्चुअल डिविजर इज 95 और you get remainder 147. That's why we subtract 95 from the remainder and add 1 in question. Okay, आपका जो रिमाइंडर है हमारे एक्चुअल डिविजर से बड़ा नहीं होना चाहिए. इफ है तो आप सब्ट्रैक्ट करेंगे इसमें से एक्चुअल डिविजर और आप ऐड करेंगे क्वेश्चन में 1. क्लियर? वन मोर क्वेश्चन.
Ma'am, 1000 divided by 24. Can I take this?
1000
divided by 24.
अभी above the below base के नियर बात हो रही है. Okay.
Okay. Okay.
Only base digits. After base completed, then we take. तो ये बिलो बेस का प्रोसेस था. एक एग्जांपल और मैं आपको क्वेश्चन दे रही हूँ, आप इसको बताएं मुझे. देन अब द बेस चलेंगे. 15346 डिवाइडेड बाय 989. बेस क्या है यहाँ पे 1000.
Yes.
डेविएशन जो होगा व्हाट
11
0 11
है ना. और आफ्टर ट्रांसपोज यू गेट 0 1 1. देन 0 1 1 3 4 6 1 5 1 as it is 0 1 1 5 0 5 5 11 10 and 4. तो what 11 का आप लिखेंगे 1 और ये फॉरवर्ड होगा 1 यहाँ 10 + 1 is 11 1 और ये 1 फॉरवर्ड होगा यहाँ तो 5 5 1 1 it's your remainder and 15 is your quotient. Any doubt?
No, ma'am. Ma'am, left sides में 0 is compulsory for 3-digit number.
Yes, because base is 3 digit, base have 3 zeros. That's why divisor have 3 digits. According to base zeros, okay, if base have 2 zeros, then divisor have 2 digits. Two 3 5 7 6 6 3 divided by 1 1 2 1. Okay, to base क्या? 1000 deviation 1 to 1 after transpose 1 bar 2 bar 1 bar. इसकी मत इट्स
मैम
रिमेंडर
क्यों ले रहे? सॉरी मैम,
ट्रांसपोज किया ना, ट्रांसपोज में वेट अ मिनट बिकॉज डेविएशन क्या है हमारा, ये अबव द बेस है. ओके वो बिलो द बेस था तो आपका डेविएशन नेगेटिव था, ये अबव द बेस है तो डेविएशन आपका क्या आ रहा है पॉजिटिव. तो ट्रांसपोज आप करेंगे तो ट्रांसपोज पॉजिटिव का नेगेटिव है, नेगेटिव का पॉजिटिव. ओके क्लियर? Clear or not?
Ma'am, can you explain one again? 1 to 1.
आप डिविजर देखिए, डिविजर इज above the base. तो आपका डेविएशन व्हाट यू गेट 1121 minus 1000. 1 to 1 it's positive deviation. Then transpose पॉजिटिव का ट्रांसपोज क्या होगा नेगेटिव. इन लास्ट क्वेश्चन 989 1000 minus 989 and you get 011 it's negative below the base or transpose positive. Here we have above the base, then deviation is positive and transpose is negative. Okay, clear or not?
I'm sorry, please once again, ma'am.
लास्ट समझ आया था आपको, लास्ट क्वेश्चन जो मैंने कराया था?
नहीं, वो भी इसका समझ में नहीं आया था, इसलिए मैं पूछ रही हूँ अभी ये वाला कैसे समझ में नहीं आया.
डिवीजन का फिर से समझा दीजिए, समझ ही नहीं आया.
व्हाट?
डिवीजन का कॉन्सेप्ट फिर से समझा दीजिए ना.
फिर से समझा दूं? ओके वेट, एक फ्रेश क्वेश्चन के साथ मैं अगेन स्टार्ट कर रही हूँ. डिवीजन का जो मेथड है इसमें हमारे दो मेथड आप मान के चलो, ट्रांसपोज एंड अप्लाई, एंड सेकेंड इज फ्लैग. Okay, transpose and apply method. Below and above, base, ये for all. ठीक, कैसा भी डिजिट्स हो आपका, बेस क्या होता है आपका, बेस 10, 100 and 1000 अप टू जहां तक आपका रेशो. इफ बिलो द बेस क्या नंबर होते हैं आपके, 989, 989, 9999, and above the base number what, 121, 12, 101, 1121, like that. Okay, यहाँ तक कोई डाउट?
नो मैम, क्लियर मैम, यहाँ तक समझ आ गया.
ठीक, इफ डिवीजर आपका बिलो द बेस है, 989 है, देन डेविएशन आपको क्या मिलेगा, 0, 1 बार, 1 बार. ओके, इट्स डेविएशन. डेविएशन आपको क्या मिलेगा, 0, 1 बार, 1 बार. आफ्टर ट्रांसपोज 0, 1, 1. डेविएशन आपका निगेटिव है, दैट्स व्हाई आपका ट्रांसपोज करके क्या हो जाएगा, पॉजिटिव. ओके, इफ नंबर आपका अबव द बेस है तो 1 to 1, तो आपको डेविएशन क्या मिलेगा यहाँ पे, 21. तो डेविएशन आपको कैसा है, पॉजिटिव. आफ्टर ट्रांसपोज व्हाट यू गेट, 2 बार, 1 बार. ओके, the point is clear or not?
Yes ma'am, till here the point is clear.
Clear. अब हमने क्वेश्चन क्या लिया था, पहले ही वाले लेते हैं. कोई नेक्स्ट क्वेश्चन, नेक्स्ट क्वेश्चन मैंने लिया अगर 1, 2, 2, 4 and divided by 89, तो बेस इज व्हाट, 100. डेविएशन 1 बार, 1 बार. ट्रांसपोज 1 बार. डिविडेंड, रिमाइंडर and divisor. Divisor is 11 after transpose 11. Okay, हमारा एक्चुअल डिविजर 89 है, बट हमने ट्रांसपोज करके डिवीजर हमारा हमें मिला 11. 11 हैविंग 2 डिजिट्स. 11 में आपके कितने डिजिट्स हैं, 2 डिजिट्स. यस,
हम एक मिनट थोड़ा मैं नोट बना लूं इसका, 1 मिनट रुक जाए.
ओके,
मैम डिविएशन मतलब माइनस करना है ना?
यस, माइनस. बेस डेविएशन देखो, बेस 100 माइनस 89. इफ आपका बिलो द बेस है तो डेविएशन जो आएगा निगेटिव. इफ आपका अबव द बेस है तो जो भी नंबर है आपका लाइक 1 to 1 माइनस 11, 100, तो ये अबव द बेस है, ये बिलो द बेस है. ओके, तो ये पॉजिटिव आएगा. डेविएशन आपको कैसे मिलेगा, जो भी आपका बेस है उसमें से आप एक्चुअल डिवीजर को सब्ट्रैक्ट करेंगे, देन यू गेट डेविएशन. क्लियर? आगे करूं?
यस मैम।
ओके, तो आपको 11 में कितना डिवीजन पार्ट में 2 डिजिट्स, देन इन रिमाइंडर पार्ट 2 डिजिट्स। लास्ट से आपको डिजिट लेनी है, स्टार्टिंग से नहीं, लास्ट से। तो 1 12, देन 1 is direct in the question part and आपको 1 मिला, 1 into 1, 1 by 1 करेंगे आप, एक साथ नहीं लिखना है। 1 into 1 1, add 2 plus 1 3, and 3 into 1 again 3, and 3 into 1 3. Then you get 67.
सॉरी मैम, कैसे मल्टीप्लाई किया मैम?
मैम ये लास्ट स्टेप समझाया ना कैसे किया आपने?
ये आपने डायरेक्ट लिखा क्वेश्चन पार्ट में
जी हाँ, ये
डिविडेंड का,
लिखा।
इसकी
हाँ।
मल्टीप्लाई आपने इसमें की 1 by 1 करना है। 1 into 1 1, 1 into 1 1। ओके, अब आपको ये ऐड करना है, क्योंकि ये क्या है आपका 2 plus 1 पॉजिटिव है। अगर ये निगेटिव नंबर होता तो आप इसको सब्ट्रैक्ट कर देते, बिकॉज दोनों पॉजिटिव है तो ऐड हो गए 3। फिर अगेन 3 की मल्टीप्लाई करनी है, यहाँ पे कोई डिजिट नहीं है तो अब कहाँ लिखेंगे आप रिमाइंडर में? 3 into 1 3, and 3 into 1 3, और देन आपको ऐड कर देना है। इफ यहाँ पे अगर आपका ये होता 13 होता इन केस, तो यहाँ पे 17 आता, तो आप ये 1 कैरी फॉरवर्ड करते। अब ये सिंगल डिजिट है तो आपको सिंगल ही रखना है। ओके,
ठीक है।
मैम मल्टीप्लाई समझ भी नहीं आया, प्लीज मैम।
हाँ जी,
मल्टीप्लाई आपने कैसे किया तो समझ में नहीं आया।
इसकी मल्टीप्लाई आपको इसमें करनी है, डिवीजन के नंबर में। 11 नहीं पढ़ेंगे आप, इसको 1 और 1 पढ़ेंगे।
अच्छा, 1 और 1 पढ़ेंगे। हाँ,
तो 3 into 1 3, 3 into 1 3। एक बार इसमें करनी है 3 की मल्टीप्लाई, एक बार इसमें करनी है, और आपको एक के नीचे एक लिखना है। क्लियर?
मैम एक और बार समझ में नहीं आया, बिल्कुल नहीं समझ में आया, बिल्कुल।
आप समझने की कोशिश नहीं कर रहे होंगे, या तो फिर आपको 1 की मल्टीप्लाई समझ में आया?
नहीं मैम, वाकई में समझने में बहुत दिक्कत हो रही, मतलब बहुत कॉन्सेंट्रेट करना पड़ रहा है, बड़ी मुश्किल से समझ आया है।
आपको क्या पार्ट समझ नहीं आया?
मैं मल्टीप्लाई
ये जो आपका 1 है, इसकी मल्टीप्लाई आपको 1 में करनी है, तो आपको 1 मिलेगा, आप यहाँ लिखेंगे। फिर इस 1 की मल्टीप्लाई आपको इस 1 में करनी है, और आप यहाँ लिखेंगे। सिंपल। इसमें क्या हार्ड एंड फास्ट रूल है? आप समझ आया या नहीं आया?
जी मैम, अब समझ में आ गया। इसके बाद फिर नेक्स्ट स्टेप क्या होगा इसका?
फिर आपको 1 की क्रिया आपने 3 की करनी है। 3 into 1।
हाँ जी, वो भी समझ में आ गया। 33 आ गया, आंसर 67 आ गया।
बस ये आपका क्वेश्चन है, ये आपका रिमाइंडर है, बिकॉज ये रिमाइंडर पार्ट में आया है। दैट्स इट।
अच्छा,
If number is 10312 and divided by 89, इसका आंसर मुझे बता दीजिए सब लोग, चैट बॉक्स में लिख सकते हैं आप, देन आगे बढ़ेंगे।
मैम ये एक बार आप सॉल्व करके बताइए ना।
ओके, बेस 100 है, डेविएशन क्या होगा 11, ट्रांसपोज क्या होगा आपका, डेविएशन आपका नेगेटिव है तो ट्रांसपोज आपका पॉजिटिव होगा। यस, आप एक बार अपना रिमाइंडर चेक करें जिन्होंने आंसर मुझे भेजा है। ठीक है, ट्रांसपोज आपका 11, देन 11, रिमाइंडर पार्ट में आपका क्या आएगा 1 2, बिकॉज डिवीजन में आपके कितने डिजिट्स हैं 2 डिजिट, तो रिमाइंडर पार्ट में आप लास्ट से 2 डिजिट रखेंगे 1 एंड 2, हियर 103। ठीक है, 1 आपका एज इट इज इन द क्वेश्चन पार्ट 1, देन 1 into 1, 1 into 1, ये भी 1 आ गया, तो 0 + 1 आपको कितना मिलेगा 1 मिलेगा। अगेन मल्टीप्लाई करेंगे 1 into 1 1, 1 into 1 1, 3 + 1 4 + 1 5। यहाँ पे अब आपकी कोई डिजिट नहीं है तो जो भी मल्टीप्लिकेशन आप लिखेंगे वो आपकी रिमाइंडर पार्ट में जाएगी। तो 5 into 1 5।
स्टेप समझ नहीं आया मैम, इससे पहले का स्टेप थोड़ा सा समझा है। 11 सॉरी 1 1 मल्टीप्लाइड बाय ये जो फर्स्ट वाला 1 से समझ आया, फिर नेक्स्ट वाले से कैसे करना है
1 into 1, 3 + 1 4, 4 + 1 5, ये आपको ऐड करना है बिकॉज ये नंबर आपके कोई भी नेगेटिव नहीं है। यहाँ पे आपका कोई डिजिट नहीं है ना, तो आपको रिमाइंडर पार्ट में लिखना होगा इसके नीचे।
समझ आ रहा।
लास्ट क्वेश्चन आपको समझ आया था?
लास्ट आया था मैम, फिर ये नहीं आ रहा है।
12 के नीचे वो 1 और 5 क्यों लिखा आपने?
3 + 1 + 4, 3 + 1 4, 4 + 1 5, इसकी मल्टीप्लाई आपने ये की और फिर यहाँ पे लिखा, राइट? इसकी मल्टीप्लाई फिर आपने यहाँ पे की और फिर यहाँ पे लिखा। इसी की तो कर रहे हैं बेसिकली। क्लियर और नॉट?
नहीं मैम, अभी तक भी नहीं।
बाद में आपको वीडियो प्रोवाइड करता हूँ, आप देख सकते हैं।
हार्ड एंड फास्ट रूल क्या है? सिंपल 1 into 1 ही तो कर रहे हैं। या तो आप समझना नहीं चाह रहे हैं या फिर आप क्लास को डिस्टर्ब कर रहे हैं, क्योंकि लास्ट में दोनों ही चीजें हैं। कुछ नहीं है, जब मैं कह रही हूँ 1 into 1 is right there and 1 into 1 is this, उसमें समझने जैसा तो कुछ रूल मैंने लगाया ही नहीं है अभी तो। कंसंट्रेशन इट्स इम्पोर्टेंट। किसी का डाउट है? सबका आंसर आ गया? ओके, कंटिन्यू। लास्ट क्वेश्चन हमने लिया था अबव द बेस। अगर मैं अबव द बेस क्वेश्चन की बात करती हूँ, टू 3 5 7 6 6 3 and divided by 1 1 2 1. ओके, तो ये क्वेश्चन है। इफ ये आप क्वेश्चन लेते हैं तो आपका बेस कितना है यहाँ पे 1000, डेविएशन आपका यहाँ पे क्या आएगा 1 to 1, राइट? बिकॉज ये अबव द बेस है, तो आप जब ट्रांसपोज करेंगे तो आपको क्या मिलेगा 1 बार 2 बार 1 बार। बिकॉज ये अबव द बेस है तो आपको डेविएशन पॉजिटिव मिला है, तो आपका ट्रांसपोज करके नेगेटिव आएगा। जब हम बिलो द बेस बात कर रहे थे तो हमारा डेविएशन नेगेटिव आ रहा था और ट्रांसपोज करके हमें पॉजिटिव मिल रहा था। ठीक है, अब हम 3 सेक्शन बनाएंगे इसके, डिविडेंड पार्ट, डिविजन पार्ट एंड इट्स रिमाइंडर पार्ट। आपके डिविजन पार्ट में डिजिट्स कितने, 1 बार, 2 बार, 1 बार, 3 डिजिट्स, then you take 3 digits in remainder part from last. डिविडेंड पार्ट में मिला आपको 2, 3, 5, 7। बाकी कोई चेंजेस नहीं है इस मेथड में भी। 2 आप एज इट इज लिखेंगे इन क्वेश्चन एंड 2 की मल्टीप्लाई आप करेंगे 1 बार में तो आपको मिलेगा 2 बार, फिर 2 की मल्टीप्लाई आप करेंगे 2 बार में तो आपको मिलेगा 4 बार, एंड 2 की मल्टीप्लाई अगेन इंटू 1 बार में 2 बार। अब आप देख रहे हैं कि 3 और ये 2 बार इट्स नेगेटिव, तो आपको यहाँ पे क्या मिलेगा, 1। इन लास्ट क्वेश्चन आपका ये पॉजिटिव था तो आपने ऐड किया था, बिकॉज ये नेगेटिव है तो आप क्या करेंगे, इसको सबट्रैक्ट। क्लियर?
यस मैम।
फिर अगेन आपको क्या करना है, 1 इंटू 1 बार 1 बार, 1 इंटू 2 बार 2 बार, 1 इंटू 1 बार 1 बार। तो 5 माइनस 4 1, 1 माइनस 1 0, इस बार आपको मिला 0। 0 की मल्टीप्लाई जब आप करेंगे 0 0 0, तो 7 माइनस 2 आपको क्या मिलेगा, 5, एंड 5 माइनस 2 आपको मिलेगा 3। एरो मैंने इसलिए लगाए हैं यहाँ पे कि इट्स डिनोट की ये आपका जो प्रोसेस है यहाँ पे कंप्लीट हो चुका है, आप इसमें मिस्टेक ना करें। 3 इंटू 1 बार 3 बार, 3 इंटू 2 बार 6 बार, 3 इंटू 1 बार 3 बार। अब आप रिमाइंडर पार्ट में आ गए, आपके डिविडेंड पार्ट में कोई डिजिट्स नहीं है ये, तो आप सब्ट्रैक्ट करके इसको एज इट इज लिख सकते हैं। 6 माइनस 1 4, 4 माइनस 3 क्या मिलेगा आपको, 6 माइनस 1 5, 5 माइनस 3 2, 6 माइनस 6 0, एंड 3 माइनस 3 0। तो जो आपका रिमाइंडर आ रहा है वो 200 आ रहा है, एंड आपका जो क्वेश्चन आ रहा है वो 2103 आ रहा है। इट्स क्लियर और नॉट?
क्लियर मैम।
दैट्स गुड।
क्लियर मैम।
ओके, इक्वेशन आप ट्राई करेंगे।
Clear, ma'am.
35896 डिवाइडेड बाय 1112, आंसर दीजिए मुझे। basis 1000, deviation 112, transpose 1 bar 1 bar 2 bar, 32 and 641. Check your remainder. 1 bar 1 bar 2 bar 3 5 8 9 6. 3 as it is. 3 1 2. Yeah, correct remainder. Then 3 into 1 bar 3 bar, 3 into 1 bar 3 bar, 3 into 2 6 bar. So 5 minus 3 2. 2 into 1 bar 2 बार, 2 बार एंड 4 बार। तो 8 - 3 आपको 5 एंड 5 - 2 3, 9 - 6 3, 3 - 2 1 and 6 - 4 it's 2. Your answer is quotient is 32 and remainder is 312. सबका यही है, किसी का डिफरेंट है तो वो चेक कर लेंगे। ओके, नेक्स्ट मेथड अबव द बेस हो गया आपका, बिलो द बेस हो गया। मैंने आपको बताया था एक फ्लैग मेथड, फ्लैग मेथड, ठीक। तो फ्लैग मेथड में हम क्या करते हैं कि हमारा अगर डिजिट्स है 3 2 2 6 डिवाइडेड बाय 2 1 3, ये कहाँ है, ना अबव द बेस है ना बिलो द बेस है, इट्स कंडीशन नियरेस्ट सब बेस। तो आपको क्या करना है, इसके जब आप इसका पार्टीशन करेंगे तो सेम पार्टीशन होता है इसमें भी, रिमाइंडर, डिविडेंड एंड डिवीजर। आपका जो डिवीजर है एक्चुअल, उसका जो फर्स्ट डिजिट है आप यहाँ रखिए बेस में, एंड रेस्ट ऑफ डिजिट्स आपके ये फ्लैग डिजिट होंगे, इसलिए इस मेथड का नाम है हमारा फ्लैग मेथड। ओके, पार्टीशन में किसी को कोई दिक्कत, एनी डाउट? पार्टीशन में किसी को कोई प्रॉब्लम? नो प्रॉब्लम।
नहीं मैम।
आपके फ्लैग में कितने डिजिट्स हैं? 2 डिजिट्स हैं, दैट्स मीन रिमाइंडर में आपके 2 डिजिट्स आएंगे लास्ट, रेस्ट ऑफ 3 3 2। ओके, क्लियर? अब आपको क्या करना है, ये जो नंबर है हमारा बेस में हमने लिखा है, इस नंबर से इसको डिवाइड करना है। 2 को जब आप 3 से डिवाइड करेंगे तो आपको क्वेश्चन कितना आएगा?
1
1, ठीक है। डिवाइड के बाद आप क्या करते थे, सब्ट्रैक्ट, तो आपको रिमाइंडर कितना मिला? 1। ये जो रिमाइंडर का 1 है ये आपका इसके साथ लिखा जाएगा, और ये क्या पढ़ा जाएगा अब? 12 12
अच्छा
12 आप आगे लिखेंगे और वो 12 पढ़ा जाएगा। बेस में मैंने इसलिए लिखा है जिससे कि मुझे पता चले कि ये आगे से फॉरवर्ड हो क्या है, राइट? यहाँ तक क्लियर?
जी जी।
नेक्स्ट आपको क्या करना है कि ये जो आपका क्वेश्चन में नंबर आया है 1, इसकी मल्टीप्लाई करनी है जैसे आप करते रहे पिछले मेथड में भी। 1 × 1 1 एंड 1 × 3 3। अब आप जब 12 में से 1 को सब्ट्रैक्ट करेंगे, यहाँ आपको सब्ट्रैक्ट ही करना है, 12 में से आप 1 सब्ट्रैक्ट करेंगे तो आपको क्या मिलेगा? 11, ठीक है। आप इस 11 से जब इसको डिवाइड करेंगे 2 तो क्या मिलेगा आपको, कितना क्वेश्चन आएगा?
5
और रिमाइंडर आपका कितना बचा?
1
तो आपने यहाँ लिख दिया, तो ये आपका हो गया फिर से 12। ओके
ओके।
अब क्या करेंगे, 5 × 1 5 एंड 5 × 3 15। ओके, अब आप इसको प्रॉपर सेपरेट करके जब आप लिखेंगे तो क्या आएगा आपका, ये 4 आएगा।
एडिशन नहीं होगा यहाँ पर?
नहीं, एडिशन नहीं होगा यहाँ पे, ये फ्लैग मेथड सब्ट्रैक्शन। 12 - 3 9, 9 - 5 4, तो आपको 4 मिला। अब आप इसको जब डिवाइड करते हैं इससे तो ये कंप्लीट डिवाइड जा रहा है ना, और रिमाइंडर आपका कुछ नहीं जा रहा, तो आपका ये नेगेटिव टर्म आएगी यहाँ पे। 2 - 15 करेंगे आप 13 आएगा, तो आपको आगे से कैरी लेना होगा। जब यहाँ पे आपको 13 आएगा और यहाँ पे 2 आएगा और ये नेगेटिव का रहेगा, तो आप यहाँ से कैरी लेके जाएंगे इसको पॉजिटिव बनाने के लिए, राइट? तो आप कैरी ना लेके जाने की जगह आप इसको 1 टाइम डिवाइड कर लो। आप इसको 1 टाइम डिवाइड करो इससे 1, तो 1 टाइम जब आप डिवाइड करेंगे तो आपका रिमाइंडर कितना बचेगा? 2, और इसकी मल्टीप्लाई करेंगे 1 × 3, तो 22 में से जब आपके 15 और 1 16 जाएंगे तो आपको कितना मिलेगा? 6, एंड 6 में से आपका 3 जाएगा तो 63। तो आपका क्वेश्चन आएगा 151 एंड रिमाइंडर आपका आएगा 63।
मैम लास्ट स्टेप फिर से जरा रिपीट कर दीजिए।
लास्ट स्टेप में अगर मैं इसको कंप्लीट डिवाइड करती हूँ तो यहाँ पे मेरा 2 आएगा, राइट?
जी जी जी।
राइट, ओके। और मेरा रिमाइंडर कुछ नहीं जाएगा, ठीक है। तो जब मैं इसको मल्टीप्लाई करूंगी 2 into 1 तो ये हो जाएगा 2, यहाँ पे 2 हो जाएगा। इस वाले लाइन को भी इग्नोर करना और 2 into 3 आपका 6 हो जाएगा। तो 6 into 6 ये तो आपका 0 आ गया। अब जब आप इसको 2 में से आप 15 minus 2 कितना हो गया 17 को सब्ट्रैक्ट करेंगे तो आपको मिलेगा माइनस के 15। उसको आपको पॉजिटिव बनाने के लिए आपको यहाँ से कैरी लेना होगा, ठीक है। कैरी तो लेते हैं जब आप नेगेटिव का पॉजिटिव करते हैं।
जी 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 हाँ।
तो उससे बचने के लिए मैंने क्या किया कि 1 टाइम कम डिवाइड किया, ठीक है। तो मेरा यहाँ पे रिमाइंडर आ गया 2, कैरी ना लेना पड़े मुझे आगे, और मैंने उसको पॉजिटिव, ये बड़ा नंबर हो गया। एक नया क्वेश्चन लीजिए, उससे समझने की कोशिश कीजिएगा। मुझे आगे कैरी ना लेना हो इसलिए मैंने यहाँ पे अभी से पॉजिटिव नंबर लेगी। 1 टाइम कम डिवाइड कर लो। एक और क्वेश्चन।
मैम ये फ्लैग मेथड में माइनस होता है ना, प्लस नहीं होता है?
यस, 3875 डिवाइडेड बाय 31। इसको ट्राई करें। सिक्स 4875 डिवाइड बाय 378।
नहीं,
पहले इसको करते हैं। तो
पहले
जब आप
small numbers
फ्लैग
करते हैं।
मेथड में करेंगे तो 3 एंड ये 1 आपका आएगा, फ्लैग डिजिट में 1 आपका आएगा और बेस में आपका 3 आएगा। तो आपकी फ्लैग डिजिट में 1 डिजिट है, दैट्स इट। रिमाइंडर पार्ट में आपका 5 3 8 7, राइट। अब यहाँ क्वेश्चन, इस 3 को जब इससे डिवाइड करेंगे आपको तो क्या मिलेगा? 3 को आप 3 से डिवाइड करेंगे 1 टाइम्स आएगा, आपको कोई रिमाइंडर नहीं मिला यहाँ पे, ठीक
जी।
3 minus 3 0। अब आपको क्या करना है, नेक्स्ट स्टेप 1 into 1। तो 8 minus 1 आप करेंगे तो आपको क्या मिलेगा 7। अब 3 को आप 7 से डिवाइड करेंगे कितने टाइम्स जाएगा आपका 2 टाइम्स, 2 आ गया। और रिमाइंडर आपका क्या मिलेगा यहाँ पे 1। तो आप 2 into 1 आप मल्टीप्लाई करते हैं तो आपको क्या मिलता है 2। तो 17 minus 2 आपको कितना मिला 15। अब 15 से जब आप इसको डिवाइड करते हैं तो आपको कितना मिलता है 5,
सॉरी 5
और रिमाइंडर आपका आगे कोई फॉरवर्ड नहीं होता। आप 5 into 1 करेंगे तो आपको मिलेगा 5, और 5 में से 5 करेंगे तो 0। ये कंप्लीट डिवाइड हो रहा है आपका, तो आपका रिमाइंडर कितना है यहाँ पे 0। एंड क्वेश्चन आपका कितना है 1 to 5। एक और क्वेश्चन ट्राई करना है, या लास्ट जो क्वेश्चन चैट बॉक्स में आया उसको करें। क्वेश्चन है आपका 6 4 8 7 5 डिवाइडेड बाय 3 7 8। ओके, इसको करने के 2 मेथड है। आपने विनकुलम नंबर पढ़ा है, क्योंकि अगर आप 8 से डिवाइड करेंगे तो जो वैदिक का जो प्रोसेस होता है कि हमें 5 से बड़े डिजिट नहीं ले जाने हैं, तो वहां पे 8 से डिवाइड करना होगा आपको। अगर हमने विनकुलम नंबर पढ़ा है तो उसको कन्वर्ट कर लेंगे हम किस में, विनकुलम नंबर में। लास्ट फ्रॉम 10 एंड ऑल फ्रॉम 9 से 2 बार एंड 4। अब आपको जो डिवाइड करना होगा वो 4 से, और मल्टीप्लिकेशन भी आपको 2 2 की आएगी। तो आपको हर्डल्स नहीं आएंगे मल्टीप्लिकेशन में। 7 और 8 जैसे बड़े डिजिट जो है वो हमारे कम हो गए हैं। ओके, यू शुड ट्राई। क्लियर? फर्स्ट ऑफ ऑल आप छोटे डिजिट से डिवाइड कीजिए, 23062 डिवाइडेड बाय 41 एंड इसका मुझे आंसर बताइए।
मैंने जो लास्ट मेथड आपने सिखाया था उस वाले मेथड
फ्लैग मेथड से, फ्लैग मेथड से। अबव द बेस एंड बिलो द बेस के लिए आप ट्रांसपोज एंड अप्लाई मेथड अप्लाई करेंगे, बाकी डिजिट्स के लिए आप फ्लैग मेथड अप्लाई करेंगे। Anyone get answer? Five, 6, 2 and 20. Correct. Can you show the above one with either method? Solution. Which one? 378, 41. Okay. Three, 7, 8, right? So 6, 4, 8 and 7, 5. What should you do? ऐसे करना है या विनकुलम वाले प्रोसेस से करना है? एक बार और मुझे कंफर्म करा दो, क्योंकि श्री राम सर आपके बीच जुड़ चुके हैं और उन्हें वेट कराना बिल्कुल अच्छी बात नहीं है। 422 बार से करना है, 378 से करना है?
422 बार से कर लो।
422 बार। ओके, नहीं कैंडिडेट का बाय 378 ही करना है।
अच्छा कर लो, कोई बात नहीं।
ओके, जब आप इसको 3 से डिवाइड करेंगे आप, तो ये आपका कंप्लीट डिवाइड जाएगा और आपको यहाँ मिलता है 3। ठीक है, और रिमाइंडर आपका कुछ नहीं बचता। तो आप जब इसे 2 into 7 करेंगे तो ये आपको मिल जाएगा 14 और फिर आपका ये नंबर जो आएगा यहाँ पे नेगेटिव आएगा। तो इसके हर्डल से बचने के लिए आपको क्या करना है, इसको कि 1 टाइम डिवाइड करना है, कंप्लीट 2 टाइम डिवाइड नहीं करना है। ये आपके ऊपर डिपेंड करता है कि आप हर्डल्स को आगे तक ले जाना चाहते हैं या इसको स्टॉप करना चाहते हैं। तो जब आप इसको 1 टाइम डिवाइड करते हैं तो आपको यहाँ क्या मिलता है आगे के लिए रिमाइंडर 3, 4। फिर 1 into आप 7 करते हैं तो 34 में से जब आपके 7 जाएंगे तो आपको कितना मिलेगा बताइए? 27।
यस मैडम।
27 से आप जब इसको डिवाइड करेंगे फिर ये जाएगा आपका 9 टाइम्स। अगर आप इसको 9 टाइम्स डिवाइड करेंगे, देखिए 9 टाइम्स आपने, ओके आपको ये भी मल्टीप्लाई करना था 1 into 8, बिकॉज यहाँ पे आपका 8 था। तो आप देखो अगर आप 8 में से 8 कर दोगे 0 यहाँ डिवाइड के लिए आपको कुछ नहीं बचेगा, बिकॉज आपका रिमाइंडर भी क्या जा रहा है 0। फिर आप इस 9 की मल्टीप्लाई जब आगे के प्रोसेस में करोगे तो वो भी आपका हर्डल से लाएगा। तो हर्डल से बचने के लिए अगर आप वैदिक से डिवाइड करना चाहते हैं, फर्स्ट ऑफ ऑल आप ये डिजिट चुनिए, नहीं तो आपको बार बार ये कम टाइम्स डिवाइड करना होगा। ठीक है, अब आप इसको 9 टाइम्स डिवाइड नहीं करेंगे, अब आपको इसको 7 टाइम डिवाइड कीजिए तभी आप 100 से बच। तो 7 टाइम जब आप इसको डिवाइड करते हैं तो क्या मिलता है आपको, 3 7 जा 21 और ये आपका 6 आएगा। और आप इसका 7 × 7 49 एंड 7 8 जा 56। अब आपका ये रिमाइंडर कितना बचेगा, बताइए मुझे। 68 माइनस 8 आपका बचा 60 एंड 60 में से जब आप 49 को सब्ट्रैक्ट करते हैं तो आपको मिलता है 11। अब आप इसको 11 से जब आप डिवाइड करेंगे, आप देख रहे हैं कि यहाँ पे ऑलरेडी 56 आ रहा है, तो आपको एक बड़ा रिमाइंडर चाहिए। तो आप इसको आई थिंक 2 टाइम्स तो 3 टाइम्स जा रहा है, आप इसको 1 टाइम ही डिवाइड कीजिए। तो जब 1 टाइम आप डिवाइड करते हैं 3 डिवाइडेड बाय 11 तो 8 बचेगा 87। और फिर आप 1 × 7 एंड 1 × 8 तभी आप हर्डल से बच सकते हैं। ये आपके ऊपर डिपेंड करता है। इसीलिए बेसिकली अगर आप फ्लैग मेथड से डिवाइड कर रहे हैं और आपके लास्ट में 5 से बड़े डिजिट्स हैं तो आप विनुकुलम करके शॉर्ट डिजिट बना लीजिए, इतने हर्डल्स आपको फिर नहीं आएंगे। तो यहाँ पे जो आपका रिमाइंडर बचता है 87 माइनस 56 31 एंड 31 माइनस 7 24। अब आप ये जो आपका आ रहा है 5 एंड माइनस 8 इट्स 3 बार, राइट। अब आपको इसे भी कन्वर्ट करना है, तो इसे कन्वर्ट करने के लिए आप क्या करेंगे, लास्ट फ्रॉम 10 और इसमें से एक कम कर देंगे तो वो आ जाएगा आपका 237। अब आंसर चेक कीजिए कितना आ रहा है। आई थिंक ये करेक्ट आंसर है। ओके ठीक है, क्लास ओवर करते हैं बिकॉज श्री राम सर ऐड हो गए हैं और
लेकिन
वेट कराना जी।
आपको बहुत बहुत धन्यवाद है क्योंकि मैंने
नो
सोच
नो
रहा है कि जो स्वामी जी ने उसको बुक में दिया है वर्टिकल क्रॉसवाइज के सूत्र को यूज करके
हाँ हाँ
चेंज करने
हाँ,
का
वो थोड़ा
हाँ
टिपिकल सा पड़ता है डायरेक्टली।
मैंने सोच रहा कि शायद आप वो टीच करेगा, लेकिन आप जो भी
नहीं
ऊपर
नहीं,
वाला सूत्र आपको
एक्चुअली
याद
मैं
है,
अबव मेथड में ही मैंने देखा बिलो एंड अबव में कि बहुत ज्यादा हर्डल्स आ रहे हैं, तो वो अगर मैं डायरेक्ट कराऊंगी तो वो बहुत ज्यादा न्यू कमर्स के लिए बहुत ज्यादा इशू हो जाएगा, फिर वो नहीं समझ आएगा।
ये सही है। सुबह से मैं यही बोल रहा हूँ कि सब एक ही मेथड में टीच करने के लिए कोशिश करना है, आप वही किया है। अब शायद नया लोगों को ध्वजांग पता है स्वामी जी का मेथड, तो इसी तरह करके आपको जो किया है और उसको भी बहुत फायदा है। बहुत बहुत धन्यवाद है मैडम।
थैंक यू सर। अलजेब्रा भी टच करना चाहती थी बट नहीं हो पाया।
कोई बात नहीं।
हाँ हाँ हाँ,
थैंक यू सो मच।
थैंक यू। अभी श्री राम सर ऐड हो गए तो आप उनको बुलाइए। मैं भी सुनना चाहती हूँ उनका लेक्चर।
गुड इवनिंग एवरीवन। तो मैं आपको डॉक्टर श्रीराम चौधरी को इनवाइट कर रहा हूँ। सर ने पीएचडी और एमएससी मैथमेटिक्स में कर चुका है और फिलॉसफी बीए में कंप्लीट कर चुका है, बीएड भी कर चुका है। और सर ने रिटेड लेक्चर था महाराष्ट्र से, और सर को हॉनर भी दिया गया है, माधव गणित पुरस्कार केरला से दिया गया है। और सर ने चेयरपर्सन नेशनल करिकुलम फोकस ग्रुप मैथमेटिक्स एनसीईआरटी न्यू दिल्ली से। और सर ने ऑल इंडिया कन्वीनर था वैदिक मैथमेटिक्स शिक्षा संस्कृति उद्यान्यास का ऑर्गेनाइजेशन है। और क्या है कि सर ऑल इंडिया मेंबर था वैदिक गणित टीम विद्या भारती। और सर ने बहुत सारे रिसर्च भी किया था इंडियन हिस्ट्री पे। और सर इंडियन हिस्ट्री का जो सोसाइटी होते हैं इंडियन सोसाइटी ऑफ हिस्ट्री ऑफ मैथमेटिक्स, उसका मेंबर भी है सर। और सर ने बहुत सारे रिसर्च पेपर्स ने पब्लिश किया है वैदिक मैथमेटिक्स के ऊपर, और बहुत सारे वेबिनार्स में भी अटेंड किया है उसका पेपर्स। और सर ने आर्ट ऑफ लिविंग में हेड ऑफ द डिपार्टमेंट मैथमेटिक्स में काम करता है, टीचर्स को ट्रेनिंग भी देता है सर ने। अब तक सर ने बहुत सारे पेपर्स पब्लिश किया है, कम से कम 40 के ऊपर से पेपर पब्लिश किया है सर ने वैदिक मैथमेटिक्स, नेशनल और इंटरनेशनल वाइडली जर्नल्स पब्लिश किया है सर ने। ठीक है, सर ने अब तक 6 बुक्स लिखा है वैदिक मैथमेटिक्स और मैथमेटिक्स रिलेटेड। तो आज और एक बात क्या है कि जो रेडियो टॉक होते हैं ना टीवी पे या रेडियो पे टेलीविजन पे भी सर बहुत सारे शोज किया है। और मैं सर को वेलकम करता हूँ। सर आपका टॉपिक शुरू कर सकते हैं, मैं आपको होस्ट भी बना रहा हूँ। Thank you.
सभी को मेरा नमस्कार। मेरा आवाज आ रहा है चरण जी?
हाँ सर, हाँ सर.
Okay. Allow me to share the screen now.
Yeah, you can, sir. Already I make it, sir.
Yes. Thank you. Today my topic of discussion is solution of quadratic equations, Indian methods. So I will not be focusing only on the Bharati Krishna Tirtha's method, but I will have a quick round journey, what can be said, of the solutions of quadratic equation in India from ancient times. So Shulva Sutra are the scripts on geometry. The time period not later than 800 BC, means nearly 3000 years back. These are the scripts related to geometry, no doubt. But while discussing the geometrical constructions, they discuss the topics from algebra also, because they needs, while constructing some peculiar type of Vedis and Chitis and etc., they need quadratic equation. So the equations which they tackled at that time, remember 2800 years back nearly, are of this type. 972x square equal to 972x plus m. M is arbitrary. So that m changes according to the construction. But they need to solve this, and they have solved this successfully for the construction purposes. And the problem was enlargement of isosceles trapezium. So given an isosceles trapezium, they want to enlarge it to a particular dimension. So they have the results done about this 972x square equal to 972x plus m. But because it is a book on geometry and particularly related with Yagya constructions, they have not given any method how they are solving. Similarly, they tried enlargement of falcon shape altar, and this particular enlargement demands the solution of such type of equations: 7x square plus x by 2 equal to 7 by 2 plus m. Again, m is arbitrary, which can be determined according to the situation given. Now then, Aryabhatta has written a script, we all know, Aryabhatiya, in 499 AD. This particular script has a 33 verses on Ganita as a Ganita Pada, and in one of the verses, he has given the rule for finding the number of terms in AP when the sum is given. First term and a common difference of AP is known. So the problem is like this. I have a formula n by 2 equal to twice a plus n minus 1d for finding the sum, no doubt, where a and d are and n has usual meanings. But the problem is not to find s or the sum, but to find n when a, d and sn is given. And if this is the problem of where we need to find n and not sn, we have to solve a quadratic equation, n square plus twice a minus d into n minus twice n equal to 0. Without solving such type of quadratic equation, we cannot find the value of n. This clearly shows that even at the time of Aryabhatta, they know how to tackle the quadratic equation. Again, Aryabhatta has not given any method how he has got it. Possibly he has assumed that everybody knows, and his intention was not, the topic was not on the quadratic equation. That's why he has not given any particular formula to solve it. A correct formula for solving the quadratic equation is first given by Brahmagupta in his script Brahmasputa Siddhanta. There is a chapter called Kuttakadhyay. Kuttakadhyay is another name for algebra. And in that Kuttakadhyay, 44 verse, I will not go into details of the verse, I will just read the translation. What is the formula? 4 times the coefficient of the square term multiplied by the constant term is added to square of the coefficient of middle term. Square root of this minus coefficient of the middle term divided by twice the coefficient of the square term gives the roots. That is what the translation goes. Then what will be the mathematical form of that? Indians always use the form of the quadratic equation ax square plus bx equal to c. We usually use ax square plus bx plus c equal to 0. But in Indian tradition, it was equal to c on the right hand side. So if this is a given equation, then coefficient of x square will be a, coefficient of the middle term will be b, and constant term will be c. So he is saying exactly this. What will be the root? Root will be equal to plus or minus under root of 4ac plus b square minus b divided by twice a. So just you read the translation and its mathematical formulation, you will understand the correct what Brahmagupta is saying. So this is not a strange formula to us. Exactly same formula we use in our books or in our practice. But why it is plus or minus 4ac plus b square and then minus b? Only because the assumed equation is equal to c. If I assume ax square equal to bx plus c equal to 0 or minus c equal to 0, whatever the situation, then I will get the routine formula. Minus of b plus minus b square minus 4ac upon twice a. So giving a formula for solving a quadratic equation, the credit goes to Brahmagupta first. And time for Brahmagupta is 628 AD. As you can see on your screen, 628 AD. So in 628 AD, so nearly 2000 or minus some years back, Indians know the formula for solving a quadratic equation for all values of a, b, and c. Then the modified form we are using in our syllabus without naming or without giving the credit to Brahmagupta. Then comes another mathematician named as Sridhara. He has given what we used to call today as a third term method. The same, I'm quoting from Bhaskaracharya's Bijganita book. He has also quoted Sridhara as saying that Sridhara has given this rule. The third term method, which we used to apply today for solving a quadratic equation, is different than Sridhara's method. And Sridhara is saying a simpler way to solve a quadratic equation by finding the third term. By finding the third term means we complete the square and then solve it. Let us have a mathematical interpretation. Again, we start with ax square plus bx equal to c. What Sridhara says is chaturahata, means multiply both sides by 4a and add b square. First step, multiply both sides by 4a and then add b square. This will give me this equation, 4a square x square plus 4abx plus b square. I am adding b square both sides and multiplying by 4a. So right hand side will be 4ac plus b square. Now we observe that the left hand side is a perfect square, 4a square x square plus 4abx plus b square of 2ax plus b. So I write 2ax plus b whole square is equal to 4ac plus b square. Taking roots of both sides, I will get the formula which Brahmagupta was saying. X is equal to plus minus root of 4ac plus b square minus b upon twice a. So By same way, we can have a simple derivation of the known result. See, I will do that for you. Derivation of the current formula. We apply very slightly complicated method to derive it, but see by Sridhara's rule how it can be derived. Assume the equation ax square plus bx plus c equal to 0. We used to do that always. Multiply by 4a and add b square. That is what is Sridhara is concisely saying. Equation becomes 4a square x square plus 4abx plus 4ac plus b square equal to b square. Now transfer that 4ac to the right side. Then remaining three terms are the perfect squares of 2ax plus b whole square equal to b square minus 4ac. Taking square roots and finding the value of x, we will get the known form of the Brahmagupta's result, or known form which we used to apply in our syllabus. So within 3 steps, we can derive the current formula by Sridhara's technique. And now just go to home, or you might be remembering what we used to do to derive this result is we divide by a first, and then add b square minus 4a, b square plus 4a, etc. And then remaining things. But that method which used to apply in the syllabus or in the school naturally generates the fractions. Fractional term like b square minus 4a is b square minus 4a. To avoid that fractions possibly, Sridhara has suggested multiply by 4a and then add b square, so that slightly original numbers ABC increase to 4a square or 4ab and 4ac. But finally, it reduces to a very simpler form and its deduction. Let us solve some problems by applying Sridhara's method. Because we are familiar with this result, so I'm not interested in giving you some examples based on this Brahmagupta result, minus b plus minus. I will directly move to Sridhara method and compare it with current method. Let us solve this equation. Multiply both sides, 3x square minus 17x is equal to 10. Multiply by 12 and add minus 17 square. We will get 13x square minus 204x plus 289 equal to minus 120 plus 289. This much part, if you can handle easily, multiplying by 12 and add 289, then the rest of the things are easy. It is 6x minus 17 square equal to 169. 169 is a perfect square. So when we take square root, we will get 6x minus 17 equal to 13. And the roots are 5 and 2 by 3. When we solve that equation, 6x minus 17 equal to plus 13 will give me 5. Minus 13 will give me 2 by 3. Now let us have what we do in current situation. We first divide by 3 both sides. So we get x square minus 17 by 3x plus 10 by 3. Then we add both sides, 289 by 36. Now just start comparing. Similar numbers are appearing Sridhara method and current method, but in a different form. 289 is appearing again. But my addition of 289 and 336, and then I have to add that fraction to give me x minus 17 by 6x whole square equal to 169 by 36. And the answers are same. No doubt answers will be same. So just compare what Sridhara has said and what current method is applying. And in all cases where we need to solve a quadratic equation, I find that Sridhara's technique is simpler to apply and get the answers a bit quickly than the current method. Let us have one more example. Yes. Okay. Solve. This is a simple one. I agree. In the previous example, I have purposely taken some bigger numbers. X square minus 3x is equal to 88. Multiply by 4a, a is 1. So I have to multiply by 4 to get, and then add minus 3 square equal to 9 both sides. This will give me 4x square minus 12x plus 9 equal to 352 plus 9. 8 into 4 is 352. So 352 plus 9. Left hand side is a square of 2x minus 3 whole square, and right hand side is 361 or 19 square, again perfect square. So answers are 2x minus 3 plus or minus 19, and two roots are 11 and minus 8. Of course, by observing the equation, we can write the roots straight away, I agree. But just to explain you the Sridhara method, I have selected that. Let us try one more. 15x square plus x equal to 2. Start multiplying by 4a, means here we need to multiply by 60 and add 1. 1 square is 1. So multiply both sides by 60, add 1. You will get a perfect square on the left hand side. Right hand side will be a perfect square number. Left hand side will be a perfect square expression. And you can find the roots. I hope you will be able to do within a minute. First term. Second term will be 900x square plus 60. I'm multiplying by 60. Yes. So don't worry about the numbers. Don't fear about the numbers. You are Vedic mathematics students, so no need to fear for multiplication. Then 30x plus 1 equal to 11 square. Give me 11 and 1 by 3 as the x equal to 1 by 3 one root, and x equal to minus 2 by 3 will be the second root. Minus 2 by 5, sorry. Now I am confident that you have got the control of the Sridharacharya method, and I'm very sure you are going to apply it in future also. Now we come to another method, which is a Vedic mathematics method given by Swamiji. Again, the same all-time great sutra, Urdhva-Tiryagnam, or vertically and crosswise. Actually, in the book, Swamiji has given 2 more methods for solving quadratic equation. One is by Adyam Sutra, as it's called Adyam Adyena Antyam Antyena. And another, very interestingly, he is saying us to differentiate the given quadratic equation. I repeat, what is the suggestion of Swamiji? And those who have gone thoroughly with the book, or studied that book, at one place, Swamiji is suggesting to differentiate that given quadratic equation and equate with the discriminant. Means 2ax plus b will be differential coefficient equated to under root of b square minus 4ac, and that is our standard result. So instead of even remembering the formula minus b plus minus etc., if you remember to differentiate and forget about the differential, if you don't want to use that word differentiation, just remember for ax square plus bx plus c equal to 0, roots are 2ax plus b equal to under root b square minus 4ac. You are through with the problem. But still, this Urdhva-Tiryagnam method is easy and practicable for students and teachers also. This method is, I must say, not discussed by Swamiji. But the power of the Urdhva-Tiryagnam Sutra is such that indirectly we are using this method in our classes without knowing that we are applying the sutra with Urdhva-Tiryagnam. Let us see what I am saying. Again, I consider the equation ax square plus bx plus c equal to 0. Now, what is the suggestion? Write the factors of a. Consider the factors of coefficient of x square, that is factors of a, and consider the factors of c. Just ignore b for a time. We consider 2 factors of a, 2 factors of c. Write them column wise like this. A1, A2, factors of a. Factors of a means a1 multiplied by a2 should be a, and c1 into c2 should be c. So a is to be split into 2 numbers whose product is a. Similarly, we write the factors of c, c1, c2 vertically, but not horizontally. Don't write a1, a2. You have to write a1, a2, and then c1, c2. Once we And which factors are to be selected? When I say write the factors, natural questions is which factors are to be selected and in which order they should be written. The order and the selection depends on a condition that actually we have applied the Urdhva form, A1 into A2 equal to A, C1 into C2 equal to C. That much we have done. Now remains a crosswise form. So we will select the form A1, A2 and C1, C2 in such a way that the product of the cross A1 into C2 plus C1 into A2 will be equal to B. So factors are to be selected in a such a way that the cross product, Tiryak Gunakar, that cross product A1 into C2 plus C1 into A2 or A2 into C1 is equal to B. Once that is achieved, and this will be easy after some good practice, you can just write the factors so that the cross product is equal to B. Once that is done, everything is done. Means we can declare that A1 plus C1 is one factor. Sorry, A1x plus C1 is one factor. And second factor is A2x plus C2. And if we want to factorize the equation, but what are the roots then? Even from this table, A1, A2, C1, C2, I can directly write the roots as minus of C1 upon A1, directly roots. Once I arrange the factor this way, first root minus C1 upon A1, second root minus C2 upon A2, full stop. Job is over of solving a quadratic equation. So where is the skill? The skill part is only that we need to select proper factors of A and C, arrange them in an order such that their cross product gives the answer for coefficient of X in the given equation. Then if you want to write the factors, write the factors. If you don't want to write the factors and directly if you want to write the roots, you can directly write minus C1 upon A1, minus C2 upon A2 as the root. And our problem is solved. So this is the power of a sutra or Dvatiryavyam. Actually, this crosswise technique is there in the syllabus, but not without any name for Urdhva Sutra, etc. We used to do these things everywhere. I agree that. So let us have one or two examples so that we can have a correct command over it. Again, I am taking a little bit complicated equations so that simple equations can be solved anytime. 6x square plus 19x plus 10 equal to 0. So I will select factors of 6 and 10 in such a way that their cross product is 19. So 3, 2 are the factors for 6. And then I select 2, 5. So that the product is 3 into 5 plus 2 into 2 for 19. What I am saying, selection proper. If I write 5, 2, then I will get 3 into 2, 6 and 2 into 5, something different number than 19. So that adjustment of the second factor or a proper choice for a second factor, they are writing in a proper order is important. Once this is done, 3x plus 2 is one factor, 2x plus 5 is another factor, minus 2 by 3 is the root, first root, and minus 5 by 2 will be the second root. So by just observation, I will be able to write the either factors or the roots. Now consider this example. 12x square minus 17x minus 7 equal to 0. Slightly complicated when there are minus signs, but factors of 12 and 7. Remember, 7 has only one factor, 7 and 1. 12 might have more factors than 1. So I will first write the factors of 7 and then arrange the factors of 12 so that the product is minus 17. So for minus 7 and 1, if I write the factors for minus 7, then there is no choice for me to write a factor 4, 3, so that 4 into 1 and 7 into 13 plus will give me minus 17. So observation, Vilokanam, as what Swamiji was always saying, is a very important aspect in Vedic mathematics. You need to observe the equation first before start solving. image of on observation, when I observe that, oh, -7 has only one choice. Either it is -1 and 7 or -7 and 1. I select -7 and 1. Then I can write 4, 3. But by practice, you may fail in first attempt. You may not get the cross product equal to -17. But that practice will give you some hints how to choose the factors. Naturally, the answers are 4x minus 7, one factor, 3x. Remember, factors are to be written horizontally. Don't write the factor 4x plus 3. No. Or minus 7x plus 1. No. The factors will be 4x minus 7, horizontal choice, and 3x plus 1 to give me the roots 7 upon 4 and minus 1 upon 3. Now, I am very sure you start feeling more comfortable with the method. So I have one more example for you. Try this. Again, simpler. 3x square plus 7x plus 2 equal to 0. Try yourself. I will give you 15 seconds for that only. Start. Hope you are reaching the answer. Again, no choice for 3 and 2. Only 1, 3, and 2, 1 are the factors. You have to arrange so that the sum is 7. Nothing special in it. I'm very sure about it. I have no choice. 3 has factor 1, 3, and 2 has factor 2, 1. Just I need to arrange them so that the product is 7. X plus 2 is one factor, 3x plus 1 is another factor, equated to 0 or directly from minus 2 upon 1. And try this now. Slightly difficult, I agree. At x square minus 22x plus 15. You have to give the time. You may get in one stroke, but if not, try another factor or another order, both ways. Again, 15 has no choice. 3 and 5 or 15 and 1. See which factor works. 8 has only two choice, 2, 4, 8, 1. Arrangement of the factors will be, yes, 2, 4, and minus 3, minus 15. Because I want the cross product to be minus 22. I must select minus 3 and minus 5. You can have the answer now, straight away. You can write the factors and roots. I'm very sure you're getting the answers which you're observing on the screen. 3 by 2 and 5 by 4 as a root. Try this. Find the roots of the equation. 24x square minus 25x plus 6. I'm sure you have selected the factors of 24 and 6 so as to get minus 25. So the factors are 8, 3 and minus 3, 2 again. There is plus 6, but I want the product minus 25. So instead of selecting 3 and 2, I will select minus 3 and 2. So I will get the product minus 25. 16 and minus 9. Minus 16, minus 9. Yes. And the answers are 8x minus 3 and 3x minus 2 factors. And the roots are 3 by 8 and 2 by 3. Straight away from the factors or by equating to 0, whatever you prefer. There are cases where we don't need factors. We need only roots. In that case, you can jump over to roots straight away after you arrange the factors. So you need not write the factors and then the roots. You can directly write the roots. By observing 8, 3 and minus 3, 2, it will be minus of minus 3 by 8, 3 by 8, first root, and minus of minus 2 by 3, 2 by 3, second root. Now, I have brought you one example from a famous book, Leelavati, which is like this. In the battlefield, Arjuna picked some arrows to kill Karna. So we know there is a war between Arjuna and Karna. That situation is brought to the mathematical quadratic equation problem. So what he did, he diverted all of the arrows from Karna by half of the picked arrows. So whichever arrows he picked, half of it he used to divert the arrows coming from the Karna. Secondly, second data given, he killed all the horses of chariot by 4 times the square root of the number of picked values. Here exactly that quadratic equation form appears. He killed the horses by 4 times the square root of the number of picked arrows. Third data given, he used 6 arrows to dethrone the Shalya. We know Shalya was his Sarthi. Shalya formed the chariot. Then he used 1 arrow each to cut the umbrella, flag and bow of the Karna, that is Chhatra, Dhwaja and Dhanushya, and beheaded him with 1 arrow. So he killed Karna with 1 arrow. This was the data given by Bhaskara. And then he is asking us to find if all the arrows are used, how many were picked initially. From where we get the sense that it may be a quadratic equation by the data given, 4 times the square root of the number of picked values. So let us solve it. How? It is easy finally, though data is, word problem is slightly complicated. X square be the number of arrows picked by Arjuna. I have purposely selected X square only because what is said in the data is 4 times square root of the picked arrows. If I select X, then I have to write 4 root X. Then I have to square it. Of course, it is solvable, but better to start with X square. With the number of arrows picked by Arjuna, half of it used means X square by 2. 4 times square root means 4X. 6 for Shalya, 1 each for umbrella, flag and bow means 9, and 1 for beheading the Karna means 10. So what Arjuna has done, if he picks X square number of arrows, he is using X square by 2 for some purpose, 4X for another purpose, and 10 for last purpose. So I will get a quadratic. X square minus X square by 2 minus 4X minus 10, because all are used, equal to 0. It is said all are used, nothing remains within, so equal to 0. So I got a quadratic. I need to solve it. It takes its simple form, X square minus 8X minus 20. And by observation, I can see that X minus 10 into X plus 2 equal to 0. No need to go any method. Minus 20 is there and minus 8 is there. We can arrange by practice. Otherwise, you can apply any one method you like. I advise to apply Urdhva Tiryak always. Now, 2 answers. X is equal to 10 and X is equal to minus 2. Because X square is the number of arrows picked, we ignore the value X is equal to minus 2. Minus 2 cannot be number of arrows picked. So 10 is the number, but that value is X. And my initial assumption is X square is the number of arrows picked. So answer will be 100. So from the given data, we can say that initially Arjuna has 100 arrows and he used 100 arrows in the sequence described in the problem. Of course, this is a not the actual problem as we can understand. Just he has used the situation to create a problem which finally leads to solution of the quadratic equation. And Leelavati is famous for all such type of problem. There are many problems, you will not believe me. Many problems which finally turns into the quadratic equation. We need to solve a quadratic equation. Initially, when we read a problem, we don't feel like that. But once we start solving and deciphering that verse and deciphering that translation, then we will remember that. You will understand that we are getting actually a quadratic equation for us to solve. And of course, that can be done anytime. Now, let me move to one special type of quadratic equation, which is discussed by Swamiji again. And many times we need such type of quadratic equation. That special type is x plus or minus 1 upon x is equal to a upon b. Of course, b not equal to 0. Two conditions. Left hand side is sum or difference of reciprocal terms, x and 1 upon x. So sum or difference of reciprocal terms. And right hand side is a rational number. This is the situation in hand. And of course, when it is sum or difference of reciprocal numbers like x plus 1 upon x, we are going to get a quadratic when we simplify it. But what Swamiji is suggesting us, don't simplify. So don't try to get a quadratic equation out of it and then apply a method. If right hand side is a rational number, then you can solve it under some condition, equation, without simplifying the given x plus 1 upon x equal to a upon b. So what is that method? Method starts like this. We want to find the roots of the quadratic equation x plus or minus 1 upon x is equal to a upon b. First, concentrate on that denominator b. That denominator b, I will factorize. Means I will find two factors, two values, in such a way that sum of their squares or difference of their squares, c square plus d square or c square minus d square equal to a. One way I should get the answer. If not, then of course method does not work. Remember that. This is not a particular case. So particular fractions will be useful. Some may work, some may not work. Always you. And the beauty is, if this particular method does not work, it will be a perfect square quadratic. You are going to get either irrational root or even the complex roots. So that if when we want to get the rational roots, I will get the value of b, factors of b in such a way that c square plus d square equal to a or c square minus d square equal to a. So what I will get after this situation. On the right side, I will write a equal to c square plus or minus d square upon c into d. When I simplify that, we get c upon d plus or minus d upon c. So I have one sum of reciprocals on the left side, another sum of reciprocals, c upon d plus d upon c on the right hand side. So from the given quadratic, I change it to two sides of equal forms, sum of reciprocals. Once I achieve this, Swamiji tells us that first root of the equation is c by d, second equation will be plus or minus d by c, simply. So I'm explaining it in more detail. In practice, you will not require more than 15 seconds to solve such a problem. Once you achieve that, once we are able to write a equal to c square plus d square for factors of b, then you need not do any simplification, nothing. Straightway answer will be c upon d first root. Second root will be plus or minus according to expression in the numerator. If it is c square plus d square, I will get d upon c value as a root. If it is c square minus d square, I am expressing a in terms of the factors of b. Then my second root will be minus d upon c. Let us move to example so that you will get a beauty of the situation. One example only. X plus 1 upon x is equal to 29 upon 10. So factors of 10, 5 to 5 square plus 2 square is 29. So I am through with the situation. Factors 10 and 5, I select for 10. Then 5 square plus 2 square equal to 29. So for 29, I will write 5 square plus 2 square upon 5 into 10 in the denominator. And simple observation will give me 5 by 2 plus 2 by 5. So format becomes same. Sum of reciprocals x plus 1 upon x on left side. Sum of reciprocals 5 by 2 plus 2 by 5 on the other side. So straight away, the roots of the quadratic equation, 5 by 2, one root, 2 by 5, another root. Many times we come across such situation where the terms given are the sum or difference of the reciprocals. That's why Swamiji has given a method for it. Of course, everything is by observation. No sutra involves in it practically. Now solve this slightly complicated situation. X upon x plus 3 minus x plus 3 upon x equal to 15 upon 56. But my observation tells me that the left-hand side is difference of reciprocals, x upon x plus 3 and minus x plus 3 upon x. Once I observe that it is a difference of reciprocals, I will try to express right-hand side as difference of reciprocals. So I have to factorize 56, 8, 7 factors. 15 is the answer. But I have to write it x square minus 7 square equal to 64 minus 49, 15. So difference gives me the answer 15, not the sum. 8 square plus 7 square will be different, but 8 square minus 7 square is 15. So I will write for 15, 8 square minus 7 square and not. And on the left hand side, of course, it is minus sign. That is also a hint for that. So we have a situation now. X upon x plus 3 minus x plus 3 upon x is equal to 8 upon 7 minus 7 upon 8. 8 square minus 7 square divided by 8 into 7 gives me 8 upon 7 minus 7 upon 8 and not roots but the values. X upon x plus 3 equal to 8 upon 7 and x upon x plus 3 is equal to minus 7 upon 8. Now I can find the value of x easily just by cross multiplication. First root will be minus 24, second is minus 7 by 5. You can check the answers. So even if I start solving this given equation by our routine method of cross multiplication, LCM, and so many things, just do that after going to home. Try to solve this particular problem, x upon x plus 3 minus x plus 3 upon x is equal to 15 by 16, 56 by our routine method. Have a LCM, cross multiplication, so many terms you have to adjust. Product will be 56 multiplied by something, 15 multiplied by something, many calculations. Of course, time and energy both will be more required than what Swamiji has given us a technique for solving such examples where remember the condition is left hand side is a sum or difference of reciprocal and we must be able to express the right hand side rational number as a sum or difference of the reciprocals. Then only such thing will work that you can just equate two sides. Otherwise, you have to go by the regular way. This is a particular case I'm repeatedly saying, not the general one. And the last part, factorization of homogeneous second degree polynomial in two variables. In probably 11th or 12th class and more than that, we required to factorize ax square plus twice hx square plus by square. So what is the difference in the earlier equation and this is there are two variables instead of one. It is ax square plus 2hx square. This is the standard form and plus by square. Usually we have ax square plus bx plus c, but homogeneous second degree polynomial is expressed in a standard form as ax square plus twice hx square plus by square. Same Urdhva-Tiryak Sutra is applicable. And those who are familiar with such type of equation will know that or understand that these equations are always difficult to factorize. But let us see what happens with Urdhva-Tiryak. Again, factors of a and b means coefficient of x square factor and coefficient of y square factor are to be selected and written orderly in such a way that their cross product is twice h, means their cross product is coefficient of xy. So if I write the factors of A as A1, A2, same idea which we had done earlier, and the factors of B as B1, B2, I must have A1 multiplied by B2 plus A2 multiplied by B1 equal to twice H. That twice, we all know the reason for that. Once that is done, my factor again A1x plus B1y, not A1x plus B only. The factors will be A1x plus B1y and second factor A2x plus B2y. So by observation, many a times, we can straight away have the factors. What is the advantage of this? We know that such type of a homogeneous second degree equation in two variables always represents joint equation of lines. Of course, there is a condition. When this happens, when such type of equation is factorizable only when h square minus ab is greater than 0. You cannot write at randomly select a, h, and b. If you want to have a factors of this equation, then there is a condition. Similar to previous case, the condition to get a linear factor was b square minus 4ac greater than 0. Here the condition will be h square minus a into b greater than 0. If not, linear factors are not possible. We know under this condition, when this condition is satisfied, this equation means a polynomial equal to 0 represents a pair of lines or joint equation of lines passing through origin. There is always a problem, find the separate equations of lines when a joint equation is given. Means nothing but to factorize this equation and equate each factor to 0. We apply a technique of factorization as said before. Even in geometry, Urdhva will work and you will get the answer. Let us have a problem. See, I have given a problem straight away. Find the separate equation of lines 10x square plus 19xy plus 7y square. We arrange the factors 2, 5 and 1, 7. Select for 7. No other choice. Sum is 19. So first factor is 2x plus y. Don't call 2x plus 1. I repeat. Second factor is 5x plus 7y. Equate each factor with 0 to have the separate equations of lines. So equations of lines with joint equation is 10x square plus 19x plus xy plus 7y square equal to 0 is 2x plus y equal to 0, 5x plus 7y equal to 0. Clearly, it is a equation of lines passing through origin because constant term is absent in the equation. Let us try this. Have a hand. Find separate equations. Well, x square minus 11xy, 5. No choice for minus 5. 1 and 5 are the only choice. So select that way 4, 3, 2, 6. I don't know what will happen. Yes, 3, 4 is okay. 3, 4 for 12. 1 minus 5. Give me minus 11. Yes, 15 minus 4. And in fact, the joint equation will be, separate equations are 3x plus y equal to 0 and 4x minus 5y equal to 0. So same technique of Urdhva can be straight away applied to homogeneous equations of second factorization for homogeneous equations of second degree in two variables, or find the separate equations of lines in geometry. Again, I must say that this is not, you will not find this in the book. This is our study of Swamiji's methods or application of those studies for in this different situations. Thank you for everything. I'm grateful to organizers for giving me a chance to deliver a lecture on the topic of my choice in this one-day workshop on different aspects and applications of Vedic Mathematics Sutras in various disciplines. I thank all the distinguished and enthusiastic learner teacher participants. Many of them I know personally for their cooperation. Namo Namaha. If there is any query, any doubt, any comment, you are welcome. Now I stop sharing, if you permit me that way. Yes. Thanks for taking this topic. Kanchan to everyone. Thank you. Any query, any doubt, any comment? Still 10 minutes time, 5 minutes time.
क्लास तो बहुत अच्छा है, बहुत इंफॉर्मेटिव है सर। मैं आपको बहुत बहुत शुक्रिया बोलता हूँ कि हमको बहुत सारे मेथड दिया, और मैंने आज एक अच्छा मेथड सीखा है कि जो अपने जनरल ट्रेडिशनल मेथड और क्वाड्रेटिक इक्वेशन वाला बहुत लेंथी होता है उसका, जो आपने 4a से मल्टीप्लाई करके सॉल्व करने का तरीका बताया था वो बहुत आसान।
Thank you.
लास्ट जो आपने होमोजेनियस इक्वेशन दिया था उसमें अपन को जो इक्वेशन आया था इन टू वेरिएबल,
हाँ,
तो उसमें हम एक्स वैल्यू वाई वैल्यू 0 माना है या तो दूसरा वैल्यू आ सकते हैं, मतलब वो दोनों साइमल्टेनियस इक्वेशन लास्ट में आते हैं ना, दोनों को
हाँ, yes, I agree, because same technique of Loparam and Sthapanabhyam is used for general quadratic. Same can be used for this particular case, but because I was discussing the Urdu Tiriyak method, I decided to go that way.
Thank you, Sriram ji. Thank you very much.
Mutturaman ji, namaste. Namaste.
Listen to you.
Namaste, Mutturaman ji, namaste.
नमस्ते जी, नमस्ते। बहुत दिनों के बाद आपसे, आपको देखना, आपका बातों को सुनना, आपका एक्सप्लेनेशन वो तो ना